Professor Kaushik Ghosh from IIT Roorkee. In this third and fourth technical session, we'll be having keynote address by Dr. Sankar Prasad Rath from IIT Kanpur and invited talk by Dr. Chitranjan Das from Germany and Rajendra Singh Thakur from CSIR, CSM CRI, Bhavnagar, India. So we'll start with the keynote address of Dr. Sankar Prasad Rath. Professor S.P. Rath has pursued his graduation and post-graduation from the Calcutta University. He received his doctoral degree from the Department of Inorganic Chemistry, Indian Association for the Cultivation of Science, Jadhavpur, during 1999, under the supervision of Professor Animesh Chakravarti. He has also worked as research associate at IACS Kolkata. He has worked as NIH postdoctoral research associate with Professor Alan L. Balk at the Department of Chemistry, University of California, Davis, USA from 2001 to 2004. He has been ABH Fellow, experienced researcher with Professor Dr. Peter Komba, Heidelberg University, Germany from 2012 to 2013. He has served the Department of Chemistry, Indian Institute of Technology, Kanpur as assistant professor, associate professor, and is currently working as professor. He has received several reputed honors and awards, which include Jagdev N. Gupta and Srimati Murthy Gupta Chair Professor IIT Kanpur, Bronze Medal from Chemical Research Society of India 2015, Alexander von Humboldt Research Fellowship for Experienced Researcher in the year 2012, P.K. Kelkar Faculty Research Fellowship from IIT Kanpur during 2009 to 2012. He is the member of several professional societies. He is the life member of Chemical Research Society of India and Indian Association for the Cultivation of Science. He is also a member of Society of Biological and Organic Chemistry, American Chemical Society, and Society of Porphyrins and Phthalocyanins. He has been working for several national and international committee work, which include the membership of Academy Advisory Committee, IIT Jodhpur, Interview Committee, KVPY, IISc Bangalore for several years, Selection Committee of several universities, NITs, etc., Young Scientist Expert Committee, Chemical Sciences, Science and Engineering Research Board, SERB, from 2015 till date. He's also an external expert for the National Science Center, Poland, from 2015 onwards. He has chaired several sessions in national and international conferences in India and abroad. He has been the convener of ACS On Campus program of American Chemical Society. He is a regular reviewer of many major scientific journals published by ACS, RSC, VCH, Elsevier, etc. He has reviewed various projects of the funding agencies such as DST, SERB, CSIR from India, and NSC from Poland, NIH from USA, NSF from USA. He has reviewed many master and PhD theses from Indian universities, NITs, and IITs. His major research areas of interest include bioinorganic chemistry, multi-heme protein and enzymes, binding and activation of small molecules, supramolecular chirogenesis, NMR spectroscopy of paramagnetic molecules. He has supervised more than 10 PhD students and 14 research scholars are enrolled under his supervision. He has guided 4 postdoctoral fellows and several MSc and summer students. He has published several research papers in highly reputed journals. He has successfully undertaken about a dozen research projects sponsored by DST, CSIR, CARE, and REACH funding agencies. On behalf of the organizing committee of the Web Conference on Novel Trends in Chemical Sciences 2021, I request Professor S.P. Rath to deliver his lecture in order to enrich our participants. Thank you, sir. So you can start now.
Good morning to everybody and greetings from IIT Kanpur. Let me first thank the organizer for inviting me to talk in front of you and also for the introduction. I will be talking today a very general, broad topic that how we survive in this earth, how we live with oxygen. You know, this is very oxygen. All of you have studied, all of you know about it. Now, let me introduce how this simple molecule actually helps us to survive in this world. Before I start, let me also, you can also look at my lectures in NPTEL, which is online and which are also free on the topic of bioinorganic chemistry. Let me begin with just a minute. Let me take the laser pointer. If you look at the composition of Earth, you can see that around 78% is populated with nitrogen, around 21% is oxygen, and then the rest is other gases. So there are a huge oxygen environment, around 21%, where we live. Now, this is a very simple molecular orbital diagram of dioxin, which you have studied in school days. Now, if you look into it, that this is what is the dioxygen, and that the unpaired electrons are here. There are two unpaired electrons in the pi orbital, pi star orbital. It's a anti-bending orbital, and these are all filled. So there are two unpaired electrons, and that is why dioxygen is in paramagnetic with triplet state, two unpaired electrons here. Now, but please note that this is in the anti-bonding state. Now, let us look at that what would happen if you selectively take electrons out and give electrons. Please note that chemical reactions are nothing but electron transfer. You can take electron, you can give electrons like this. So if oxygen likes to bind or react with anything, either it will give electron or it will take electrons. And what would happen if it gives electron or if it takes electron? Let me just do the oxidation. Oxidation in the sense that you can, if you remove one electron from the antibonding orbital, then you have only one unpaired electron. Okay, and in this oxygen is O2 plus. This is oxidation. So dioxin can be oxidized. Now, if dioxin can be reduced, if you add more electrons, what would happen? Then this orbital will get one electron here. Okay, so you have one unpaired electron. So this is reduction, and it is O2 minus. We call it as a superoxide. And if it is 2 electron is reduced, then what would happen? The 2 electron comes to the antibonding orbital, it will form O2 minus, and this is called peroxides. Okay, now this is oxidation. So oxygen is getting oxidized to form dioxygenyl ion, and if you give electron, 1 electron, 2 electron, then dioxin will form superoxide and peroxides, and as a result of this addition or of electrons or take out of electron, you can see that bond order is also getting changed, bond strength is getting changed, and that is what is you have already studied. Like, for example, if it is O2 plus, then this bond order is more, so bond distance is shorter, 1.12 angstrom, as compared to the dioxygen, which is unoxidized, 1.21. However, if you add electrons, means if dioxin converts to O2 minus and O2 2 minus, you can see the bond distance increases. Please take a note that the superoxides is having long bond or bond, and the bond dissociation energy is lowest. Okay, this bond dissociation energy is the lowest, and you will see how nature took this advantage of breaking O bond through these superoxides. Now, let me tell you one thing. Like this oxidation of oxygen. So you all studied or you all very familiar that oxygen actually is an oxidizing agent. But please note that here oxygen is getting oxidized. That means dioxin would be reduced. Okay. So this oxidation of oxygen, if you do it, okay. Now this oxygen, if you add PTF6, then it forms O2 plus PTF6 minus, which is in red in solid. Okay. And you can see that this is O2 plus, very strong bond. And this is very, very unique example where dioxin is also getting oxidized. Okay. And this is an inspiration. If one look at that O2, the first ionization potential is 12.2 electron volt for oxygen. And surprisingly, xenon also, the first ionization potential is almost identical. And this gentleman in Bartlett has looked into these values and he thought if dioxygen can be oxidized, why not xenon? Because their potential are similar. Please note that xenon is an inert gas. Why it is inert gas? Because it is not easily reactive. It cannot be reactive because it is a full filled orbit, full filled electrons in the outermost orbital. Okay, it cannot take electrons, or you cannot. If it takes electron, it has to go to go to the next higher level, in a higher energy level orbital. So then Neil Bartlett, when he looked into these values, he thought that then if dioxin can be oxidized, then xenon also can be oxidized like this. Indeed, this is the inspiration for the synthesis of XCPTF6, which is the first noble gas compound. Okay, so xenon is a noble gas, and you know, if you look into the periodic table, they have been kept in a separate place because they don't react. Now, this is the first reactions from an inert gas, and now there are so many molecules reported in the literature. In every textbook, the inert gas is no longer inert. It is also reactive. It also takes parts in reactions. But this becomes the first molecule of the noble gas. Okay, just please note that. Now, coming back to dioxin chemistry, because you see the redox potentials O2 to O2 minus is minus 0.33 volt. This is the standard reduction potential, and O2 minus to O2 2 minus plus 0.89, and all these E0 values are shown here. And however, this O2 dioxygen converts to water. The E0 value is plus 0.815. The large reduction potential for the 4 electron reduction of dioxygen is a measure of great oxidizing power of dioxygen. So dioxygen is so powerful because you see that redox potential is very large positive. Indeed, that is very, very interesting. And if it is so positive, then how we survive? We supposed to be burned because dioxin is so powerful oxidant, plus 816 volt, plus 0.816 volt, and so it's supposed to oxidize everything. Now, if you look into it, the dioxygen, the first reduction, the potential is minus 0.33 volt. And if it is E0 is negative, then delta Z is positive. So this is not a spontaneous reaction. Okay, not a favorable reaction. And this one electron reduction of O2 to O2 minus presents a barrier that protects us from the fully oxidizing power of dioxide. Indeed, dioxide is so powerful oxidant, it's like that you are living with lion, tigers, okay, that they can eat any point of time. But this is what is the barrier, like O2 converts to, if it is one electron reduction, then the reaction is not favorable. Now, if you look at that, dioxygen can react with all sorts of species, methane, methanol, and converts to something very useful, and delta H is large negative. So all these reactions are thermodynamically favorable and exothermic, but it would not happen in the absence of catalyst because it is very, very slow. Just like hydrogen and oxygen gives rise to water. If you look into it, this reaction delta Z is large negative, spontaneous, but it never happens because you need to provide an activation energy to, so that this hydrogen and oxygen combined gives rise to water. Large energy is required, which is called activation energy. And that is the reason why we survive, because environment you have hydrogen and oxygen, they do not combine and form water. If it happens, then we don't survive in this world. So fortunately, this never happens. One need to provide a high activation energy, and so that this can be taken place. Indeed, that is what is happening. Basically, you see that dioxin, as I have said, that is triplet state to one paired electron. And all these organic species around us is all singlet state. They are diamagnetic. So these will not be allowed according to spin. So this is spin forbidden reaction. And indeed, this is what is actually standing between you and the spontaneous human combustion. As I said that dioxin is such a powerful oxidant, we all should burn out, but it never happens because dioxygen cannot react because of the spin forbiddenness, and one has to have the same spin state to have a spontaneous reaction. Okay, and indeed, one need to provide an energy so that dioxygen can be in the singlet state, say 22.5 kcal per mole. If you provide, then dioxin can be singlet state, and then dioxin is very reactive. Otherwise, dioxin generally does not bind so easily, okay, because they are spin forbidden. And however, if you give this energy, then this dioxin becomes singlet, but then it will react immediately. Indeed, that is what is happening in biology also. So one need to provide 22.3 kcal per mole, and this is what is called kinetic barrier, and that is what is happening in case of biology also. Say you see that this is glucose, and in respiration, as you know that it reacts with, binds with oxygen, but because of the different spin state, because this is then glucose, S is equal to 0, diamagnetic, and this is paramagnetic. So this reaction will not happen unless and until a activation energy of 22.5 kcal per mole is given, and then it reacts, and then it produces huge amount of energy. Otherwise, it is forbidden. However, please note that this is a huge energy, 22.5 kcal per mole for a biology, and biology cannot provide this much energy. And That's why a activation of dioxin is necessary. So as you can understand that many people are working on small molecule activation, dioxin activation. So this is what is the need of activation, that dioxin can be converted from from AC equal to 1 to AC equal to 0. And because of that, huge energy is required. And if one can reduce this energy, and that is what is an art of science. In the biology, they actually reduce this energy. Okay, so coming back to this, that dioxin generally do not react because of the spin forbiddenness, but once you activate dioxin to form a singlet state, it immediately reacts. It immediately reacts and forms this kind of product which otherwise will never form. And indeed, inertness or this oxygen activation and all this phenomenon has been utilized in PDT, photodynamic therapy. What is happening? This is photofilm, very popular organic molecules. And what it does, like this photofilm, if you shine light, this will be activated. Okay, and this energy will be transferred to the triplet oxygen, and then this oxygen will be converted to singlet oxygen, and then this singlet oxygen is so reactive that if it reacts with any cell, it will burn it. Okay, and this has been utilized for photodynamic therapy for cancer tumor treatment. It's a very popular and very cheap method. By shining light, okay, one can make this cancerous cell dead. Okay, and this is very popular therapeutic treatment for cancerous and tumorous patients. So basically, when you have a cancer, so what they do, they inject this photofilm, and photofilm will accumulate on the tumorous cell, because these tumors are very fast growing cells. Okay, and it accumulates here, so light is getting shined on that tumor, and the triplet oxygen getting converted to singlet oxygen, very reactive then, and it will burn this cancerous cell. Okay, and red light is used because the red light penetrates the cell more. So this is the very popular treatment. Now you all know that two most important chemical reactions in biology is one, photosynthesis, another one is the respiration. Okay, in photosynthesis, the green leaves, they prepare food, and in the respiration, the food is being burned and produce energy, lots of energy, and we use all energy for our day-to-day life. Now, when food is converted into energy, like glucose plus oxygen gives rise to carbon dioxide, water, and ATP is generated. And this ATP actually store all this energy. So ATP is the universal currency for energy in living system. Okay, and this, when you need this energy, this get hydrolyzed. It's just like ATM card. So whenever you need money, you go to the ATM and you get some money and you spend it. And whenever you have excess money, you just keep it in the bank. Okay, so what is exactly happening? Like ATP adenosine triphosphate, you can see that POP bond. There are 3 POP bond, 1, 2, and there are several oxo group. And this is what is adenosine triphosphate, 1 phosphate, 2 phosphate, and 3 phosphate. And this is adenosine diphosphate, ADP. You see there are 2 phosphates, so you can see that 1 POP bond is getting hydrolyzed. So if you need energy, then what would happen? The ATP will be converted to ADP, and this phosphate would be liberated out, But by breaking this POP bond, you can get huge energy, and this energy you can utilize. And if you have energy coming out of the respiration, then POP bond will form, and then it will form the ATP. Indeed, looks like a magic and happening in biology. Please note that the chemical reaction which is happening in biology, if you understand it, then you can actually reproduce it. Indeed, we are actually doing every day in the laboratory these reactions. Okay, so basically what is happening, I will show you in a minute what is happening. So when one hydrolyzes, this POP bond will break and release huge amount of energy. Okay, and that is what is you are using in the form of phosphorus pentoxide. So in the laboratory, you use phosphorus pentoxides with the dimeric structure. You can see lot of POP bond. Okay, P2O5 is a drying agent in the laboratory. And if you, this is what is white powder, and you take white powder, put it in a petri dish, and if you just add 1 drop of water, and you can see that huge amount of energy is getting released. Why? This POP bond is getting hydrolyzed, because you can put water. Let me show you. So this is water. So once you break this bond, so this is OH and this becomes POH. Okay, and ultimately it will form this phosphoric acid. You can see that this will be phosphoric acid. Okay, so huge amount of energy is being liberated out of this, and that is what is happening in biology. ATP is converted to ADP, and ADP is converted to ATP again. So basically what is happening, say you have taken breakfast. Okay, now what happens to that? We call it that you have eaten electrons in the form of food. And that electrons, whenever you take something in a breakfast, whatever food you take, that electrons come through ferredoxin. Okay, and basically the energy which is liberated out of the respiration is that O2 converts to water and release huge amount of energy. But one need to have a potential 0.815 volt and 4 protons and 4 electrons. Now nature need to get those electrons. How this electron counts? So whatever food you have taken this morning, okay, that food actually supplies all these electrons, and this electron is taken like ferredoxin first, and ferredoxin, what they do, they give the electron to NAD, and NAD get reduced, but then ferredoxin get oxidized, takes another electron. Okay, so this electron comes from NAD to flavoprotein cytochrome B to cytochrome C to cytochrome A3. You see the potential is increasing, and this is become a spontaneous electron flow. So if this get electron, it pass to this get electron is passed to this, but then NAD will be reduced so that they can take another electron, just like that. And when it reaches to oxygen, okay, then this oxidation is happening, the respiration is happening, which indeed release huge amount of energy. And with this energy, I am talking in front of you. You are all listening or doing whatever activity you want to do every day. Okay, so this is what is the energy, and energy is getting stored, and this is what is happening once you eat something. Okay, now this is what is the dioxin reduction center. As I said, the dioxin will be converted to water, release huge amount of energy, and this is where dioxin comes and bind, okay, in cytochrome C oxidase, which is the last enzyme in the respiratory chain. Okay, and dioxin comes and binds between iron and copper. This is heme protein and this is copper protein, like this. So dioxin comes and binds like this. You can see that this is the protein structure where dioxin can comes and binds. This is iron, this is copper, and this huge protein chains which is wrapping around this molecule. Okay, and if I remove these protein chains, you can see this molecule where dioxin comes and binds between iron and copper. This is iron center, this is copper center, and this is what is the dioxin. Okay, and this is the catalytic cycle of cytochrome C oxidase, where dioxin converts to water and with the help of 4 proton and 4 electron. Please note that if you add 4 proton and 4 electron all together, then and then only dioxin will be converted to water and release huge amount of energy. However, okay, huge amount of energy. However, if you by mistake, if you give 1 electron, 2 electron, what would happen? The superoxides will form after 1 electron reduction, and then the peroxides, then hydroxyl radical can be generated. Okay, if you give stepwise electrons. Okay, please note that these are all very reactive oxygen species, O2 minus, O2 2 minus radicals, and these are very poisonous for biology. We call it biological poisons, and these aging and age-related diseases are results from these reactive oxygen species. So in the environment, all these reactive oxygen species are getting formed, is there, and that's why you are looking age-related disease. You are suffering from the disease. So like this. So whenever you grow old, you can have this kind of skin because of the reactive oxygen species. Otherwise, you should look like this. So you are looking like this in the old age, but you supposed to look like this. Okay. And if the environment is full of pollutant, full of reactive oxygen species, even at the young age, you'll be looking like this. Okay, be careful. And that's the reason these are the antioxidants which can destroy those reactive oxygen species like green tea, tomato, and oranges, and all these fruits. And that's why if you go to beauty parlor and you are exposed like this, and you can be stay teen at even at the very old age. Okay, because these fruits destroy those reactive oxygen species. Okay, so this is a good remedy at home, and there is a science behind it because these are full of antioxidants. So if you are not using it, you can start using it at home because these are very cheap and one can remove this reactive oxygen species at home at no cost, no additional cost. Anyway, these reactive oxygen species are extremely harmful, but these are all undesired intermediate because nature wants to use oxygen for oxidation to water. Oxygen will convert to water and release huge amount of energy. So these reactive oxygen species are unwanted, undesired intermediates which are happening by mistake. Okay, but nature utilized them for something very good, very useful reactions. So these reactive oxygen species are getting utilized by several enzymes to form something very, very useful molecules. So what can be a better waste management than this? Okay, this is very, very powerful. You see, some extremely poisonous things is utilized for with extremely useful, extremely good things. Okay. Now, let me talk about another enzyme, cytochrome P450, which indeed convert oxygen to water. Okay. And by doing that, the RH organic molecule will be converted to ROH. So basically this oxygen is getting inserted between RH, ROH. Okay. This enzyme is a very, very important enzyme and responsible for oxidative metabolism of drugs, steroids, and carcinogens. And it is also part of body detoxification system. For example, say I am sure that many of you have taken medicine in this morning or eaten something. Now, if you look at that, you take that medicine and take a glass of water and dip into it, you will see that mostly they are insoluble. Now, if it is insoluble, how it reacts inside your body, how it works? Because that organic molecule will be converted to something very water soluble species, ROH. Okay, and then only it will be useful. And the cytochrome P450 is silently doing that. And also it is destroying if there is an excess drug inside your body. Okay, so in other words, it saves our life. Okay, from external toxic species. And with the help of dioxygen, it is doing that. I'm not going to discuss all in details, but you can see that this cytochrome P450, this is what is the structure, X-ray structure of this enzyme. And you can see that this is red color is the heme, iron is sitting, and this water molecule, and this the green one is the huge proteins which are wrapping that molecule. Okay, and these huge proteins are actually controlling the reactions. And if you remove this protein, you can see that this is the heme center iron, and this is the water oxygen. And now a drug molecule like camphor, his substrate, you can see that which comes and sits comfortably just above this iron. And you can see that if I remove this protein, you see that this is the camphor drug substrate, and it will be hydroxylated. So the specific position is dictated by these protein chains. And this is what is happening. The cytochrome P450, it forms 5-exohydroxy camphor. And this specific reaction, this specific reaction is happening because the organic part is actually dictating that how the camphor will be sitting around this iron so that the closest carbon is getting hydroxylated. So specificity is what is getting controlled by the protein which is present around this inorganic molecules. Okay, and that's the reason why often we see that in only one reaction happening in biology. Instead, if you work in the laboratory, you will see that there are many products are happening. But in biology, that is only one product and yield is 100%. How this is happening? Okay, the specificity comes from the protein chains. Anyway, so this design which makes the difference. I will just show a slide where you can see that cytochrome P450, catalase, and peroxidase, they are exactly identical. The reactive species are exactly identical, but they are all behaving completely different. For example, cytochrome P450, it is the substrate oxidation is taking place. Whereas catalase and peroxidase, it is the electron transfer to the substrate. How it is happening? Look at the design. The iron 4 oxo is highly reactive and it is exposed to the substrate in this cytochrome P450. So substrate can come and the oxo transfer can be possible. In contrast, catalase and peroxidase, the protein chains which are wrapping around this enzyme are indeed blocking the substrate to come close to the oxo group. Okay, substrate can only come through this periphery, through the heme centers, and that is why only electron transfer. So this is a fantastic example where you can see that the design that makes all the difference. They are all same, but doing different work because of the complete design. Okay, and this is the beauty in biology. So reactive intermediates are indeed very similar, but they are very same. Indeed, we can learn this from biology, from nature. And this is iron 4 oxo species, is highly reactive intermediate, and substrate can be oxygenated to product. Okay, and this can replace the chlorine technology with alternative based on nature oxidants. Okay, because at present we are using chlorine, and this chlorine is poisonous. Earlier we used to spread DDT. Okay, now we don't use it. This is banned already because these are poisonous. These are not good for environment. However, this kind of species which can be generated, which is used by nature, and we can successfully utilize to do the same job. Indeed, one of our very close friend in US, he has made a catalyst called Tamil catalyst, and just by looking at the biological enzyme, and you can see that this is what is present in catalase and peroxidase, and this is what he has made in the laboratory. Okay, they are looking identical. Okay, so this is in enzyme it is iron 4 oxo, here it is iron 5 oxo, and this is the active form of the catalyst, and this does like miracles. Okay, these Tamil catalysts are extremely useful, and they are being licensed, they are being they are in the market, and very, very useful, and one can use it. Or actually, industry, they are utilizing this Tamil catalyst and for various activity like water cleaning, pesticides destroyed, laundry, drinking water, disinfection. Many places they are utilizing this catalyst, and one of our very good friend has made it. Okay, now I will come to this important biological reactions, two important biological reactions that I have stated earlier. One is respiration. Okay, this glucose, it takes electron and converts to water and carbon dioxide and releases huge amount of energy. And this oxygen is getting transported in our body by hemoglobin and myoglobin. You have all studied this. Okay, and I forgot to tell that this oxygen is being produced in photosynthesis. Now, this is what is oxygen carrying proteins in biology, hemoglobin and myoglobin. You have all studied. This is heme centers. 4 heme centers are in hemoglobin. In myoglobin, 1 heme centers are here. And this is what is happening. This iron 2, when it binds to oxygen, it converts to iron 3 O2 minus. Okay, So dull red becomes bright red, and when it releases oxygen, it comes back. So this is deoxyhemoglobin or myoglobin, and this is oxyhemoglobin myoglobin. So basic structure of the monoheme is same, and this is what is the X-ray structure of this myoglobin. You can see that one heme unit where actually dioxin comes and binds, and these are huge protein chains which are wrapping the molecule, which controls the specificity. Now if I remove this protein, you can see that this is the sixth position where uh, binds dioxin, and this is the iron. Okay, and this is the X-ray structure where you can see that iron binds dioxygen like this. You can see the small dioxin is getting coordinated on iron, and if I remove this protein, you can see that iron dioxin bond is happening. This is the this is the X-ray structure of oxyhemoglobin, where you can see that there are 4 heme centers where dioxin can bind, and huge proteins which are wrapping around this molecule. Okay, so let me remove this protein. You can see that all iron binds dioxin very comfortably. So how dioxin binds? So this is what is the iron center, and iron is sitting above the plane. Now when dioxin comes and binds, this iron 2 becomes iron 3, and it comes on the plane, and dioxin becomes O2 minus, and this is deoxy to oxy, and there is a change of the spin state from high spin iron to low spin iron. Okay, now how we know that this is what is the electronic structure? That it is iron 3 low spin and O2 minus. Okay, because from the resonance Raman, you can see that this O2 minus, the resonance stretch is 1097, and in the myoglobin, it has been found 1105, which is very close to O2 minus. So that confirms that it is O2 minus in case of hemoglobin and myoglobin. Okay, so many institute or many colleges, they teach that when dioxin binds to iron, oxygen remains as hello.
Yes, sir. Yes, sir.
Okay, I think there was a internet problem, I guess. Okay, so let me share the screen again, actually, because I could see that. Can you see the slide again? Hello?
Yes, sir. It is
Can it
visible now.
is visible?
Yes, sir. It is visible now.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. It's visible, sir.
Okay. I don't know where it stops because there are some issues in the internet. That's what it was showing. Anyway, so in case of oxygen carrying protein in our body, we have both hemoglobin and myoglobin. But please note that myoglobin is a monomer. It's a one heme center. In case of hemoglobin, there are tetramer, 1, 2, 3, 4, 4 heme centers. Why nature designed these two different? Okay, because in case of hemoglobin, since it is 4 heme center and all this protein is wrapping, so there are some cooperativity is happening. What is this cooperativity? Say, for example, if there are 1% standing here. So if there is a fire, nobody can help. But if there are 4 persons standing together, if one get affected, others can protect or can help. Okay, and this kind of help is very, very essential. I will tell you what I mean by saying so. So basically, there is a huge structural change once dioxin binds to iron center. Okay, so this iron was sitting above the plane in case of heme center. Now, once dioxin binds, this iron comes to the plane. But please note that this is connected to the protein chain, huge protein chain which is wrapping. This is connected. And here also it is connected. So there will be a huge structural change once dioxin binds to iron center. Okay. Now this one can think of, like if you have performed in musical chair. I don't know how many of you have seen musical chair or participated in a musical chair. So when there are musical chair, I carefully see what is happening. So like in this musical chair, you see there are in heme center for hemoglobin, there are 4 chairs, 4 unit, 4 heme centers. Now, if one heme center binds to oxygen, it will be HbO2. Now, the second oxygen goes to another heme centers. Third oxygen goes to the third chairs. Fourth oxygen goes to fourth chair. Okay. So the statistical probability of oxygen binding is as follows. Like K1 would be much higher than K2, which is higher than K3, which would be higher than K4. Just like in musical chair, like whenever there are 1 person and there are 4 chairs, so you can sit at any chair if you wish. Okay. Now, whenever there are 2 person and 4 chairs, so probability is less. Whenever the 3 person and 4 chair, probability is even lesser. And whenever there are 4 chairs and 4%, the probability is even lower. So this is what is the statistical probability. K1 is greater than the K2, then K3 and K4. This is happening for any chemical reactions. Okay, but in reality in hemoglobin, it is just an opposite. Like K4 is greater than K3, is greater than K2, is greater than K1. And this is because of the cooperative binding. So more and more dioxin binds to iron center, it actually helping the other unit to bind oxygen comfortably. Okay, so this is what is the cooperativeness. However, no such cooperativity was, however, observed in case of myoglobin. Now, what these protein chains are doing, like when iron binds to dioxin, it becomes iron 3O2 minus. Now, this is what is happening in biology, like it is reversibly binding oxygen. But if you do the same reactions in the laboratory, like in my laboratory, we work on it, like dioxin forms the stable mu oxodimer, which is very, very stable, very, very stable, rock. So protein chain helps to bind dioxin reversibly, because in the synthetic heme, there is no protein chain, but it will bind oxygen, but it will immediately convert to mu oxodimer. So this is what is the proposed mechanism, like once it binds oxygen, then in case of synthetic heme, the other center comes like this form mu peroxo species, and mu peroxo species getting iron 4 oxo, and then iron 3 mu oxodimer. And as I have said that in case of peroxo, this bond dissociation energy is lowest. So nature took this as an advantage to form iron 4 oxo. Okay, but protein chains helps binding oxygen reversibly, because this is wrapped by protein chain. So it will not allow another iron center to come close to form mu peroxo species. Okay. So this is what, in the presence of globin chain, protein chains, that dioxin comes and binds reversibly. But without protein, this one iron center, if it binds, then another iron center comes and forms mu peroxo species like this, and dioxin cannot bind oxygen reversibly. So we understand the role of protein chains around this molecule. Now, how one can understand this? Now, this if you can put hands like this, you can put some substituents around the periphery of these heme centers. What would happen? Then what happens that if it forms mu peroxo species, there will be severe steric effect. So it will not form. And so if one can make like this kind of molecule where dioxin can bind uh, reversibly. Indeed, this is what is happening. In that case, dioxin binds reversibly. Indeed, this Coleman, he has made this molecule like picket fence porphyrin in 1975 synthetically. And he has shown that it binds dioxygen reversibly. And indeed, one can make this artificial blood. And there are many research groups, including us, who are trying to make artificial blood. And you see that for thalassemia, for many other patients, one need to donate blood. Now, if you have an artificial blood, it can be given directly, just like you take medicines. It was given directly. So people are trying, we are trying hard to make this artificial blood so that if one needs blood, it can be given. Okay. Now, what we have studied, that this heme center can bind dioxin reversibly. Okay. So what is happening, that iron 2 getting iron 3 once dioxin binds, and when oxygen is getting released, iron 3 comes back to iron 2. So this is what is happening. Iron 2 goes to iron 3 comes back to iron 2, just like this. So iron 2 is converting to iron 3 and iron 3 coming back to iron 2. So this is all the time happening. Now, this dioxin binding, as you have seen, that dioxin is also an oxidizing agent. Indeed, instead of binding dioxin to iron center, dioxin also can oxidize iron 2 to iron 3. And once this iron 3 is being formed, it cannot bind dioxin anymore. So if it is irreversible oxidation, then this iron 3 can no longer be utilized. Such slow oxidation of hemoglobin forms iron 3 which cannot bind dioxin. So overall efficiency of hemoglobin decreases over the time. Okay. Now, just like that, say if today a baby get born in this earth, so from tomorrow onwards, what would happen? The baby will be growing. And after certain years, he will be an adult. And after several years, he will be old. And then one day we die. Why? Because our body cannot function properly. We cannot walk properly. We cannot see properly. We cannot eat properly at the old age. So what is the nature's solution? Nature's solution is that we die, and then if you believe on the next life, you can again take a birth, but that is different issues. So nature's solution is that in case of hemoglobin, also the same, that nature destroy those hemoglobin. So decomposition and regeneration of the blood. And red blood cell has lifespan only 120 days. So in our body, all the time heme is getting destroyed. Blood is getting destroyed. All the time that is happening. And fresh blood is getting formed. Because when this, if it is not happening, then what would happen? That hemoglobin mostly will be oxidized to iron 3 and it cannot bind to oxygen. And this is what is the heme decomposition process, that hemoglobin will be converted to biliverdin, then bilirubin, and then bilirubin diglucuronate, and this excrete through the body. And this is happening all the time. This is water insoluble and yellow in color, bilirubin. And this is also, this becomes water soluble and body, it is excreted by our body. So in our body, our blood is getting decomposed all the time. So it is better that you donate your blood, because if you don't, otherwise it would be destroyed automatically. Okay, better you donate your blood, otherwise it would be destroyed eventually. Now, what is happening during this process? What is happening? The bilirubin is being formed, which is getting excreted through urine, and iron is getting recycled. You see that most 98% of iron in our body coming through this recycling process. Only 2 to 3% iron we are getting from diet we take every day. Still, most of the women are iron deficient, and they are suffering from anemia, and that is why they take these iron tablets. Okay, because only 2 to 3% iron we take it from our diet. Major 98% is coming through this recycling process. Still we are iron deficient. Okay, now think a situation that if all this iron have to come from the diet, not possible. Okay, now this is what is a very spontaneous process, and this is what is the heme degradation. Iron is getting recycled. You see, this heme is so stable. It's like a rock. It is being utilized by so many enzymes like hemoglobin, myoglobin, cytochromes. All cytochromes have this heme center. However, if one put is a hydroxy group, then immediately and spontaneously it is getting cleaved to bilirubin, which is yellow. You see, this is what is the beauty of the chemistry. We chemists should take proud of it, that how just putting a small group can change entire chemistry. Something very stable becomes very, very unstable and immediately undergo a decomposition process. This is what is the nature's design. Okay, indeed, I have made many such molecules. I have shown to the world that even by replacing hydroxy, if you put NH2 group also, it would happen in the same way. Anyway, so this is the bilirubin which is getting excreted in our body, and this is spontaneous. However, if it is not spontaneous, if there is a problem in the liver, then what would happen? This bilirubin will accumulate in our body will turn yellow, and that is what is called jaundice. So why people suffer from jaundice? Because there is an excess of bilirubin. Okay, although it's supposed to be spontaneous. So this is what is happening in our body. Hemoglobin, it will be decomposed, it will be converted to bilirubin, which is water insoluble, and this will come to the liver, okay, which is water insoluble again, but it converts to water soluble, and then it goes to, it excrete from our body in the form of urine. However, it also can be deposited on the skin. So you will find that in your skin there are a lot of blood spots, black spots. These black spots on your faces are basically this bilirubin. Okay, there is some problem in your body. That is why there is some excess formation and it is not going out of your body if your liver is not very strong. Okay, if your liver is not very strong, you will have this jaundice and you can have a lot of black spots on your face. Okay, this jaundice. So it is very common, particularly it is very common for the new baby jaundice. Okay, if you have jaundice, if you go to the doctor, doctor will ask for the bilirubin, the total bilirubin and direct bilirubin. So this is very high for the patients who are suffering from jaundice. And new baby jaundice is a very, very common thing. Most of the newborn baby are suffering from jaundice. Indeed, I also had jaundice. And why it is so? Because when this baby was inside the mother's, then there was the blood he had or he or she had was called fetal hemoglobin. Okay, but when a baby takes birth, then this fetal hemoglobin has to be converted to adult hemoglobin. And in order to do that, all this hemoglobin will be destroyed completely. Now, if the baby's liver is not very strong, then what would happen? Then this body turns yellow. There will be excess bilirubin in the body, and that creates the problem. So exposure to mild UV light from the sun is usually sufficient to destroy. So in the village, generally mother, they expose their kid to the sunlight, and the sunlight, the UV light is good enough to destroy those bilirubin and you are safe. But if you are in a city and if you have a lot of money, then you go to the nursing home or hospital, and in which what they do like this, they expose the blue light. Okay, so we call it blue light treatment, basically the UV light, which indeed destroyed. So basically, and by doing that, they do nothing, just exposed to the blue light. This is LED light. So you can put it LED light at home, it will do the same job. So nurse becomes very happy because she is making a lot of money out of that. Doctors become so happy. Hospital, nursing home becomes so happy. But poor chemist, they actually discover this molecule, the process. Okay. So you should feel proud being a chemist. So what is basically happening, as I have said, that heme converted to mesohydroxyheme, and then this converts to biliverdin, which is green, and then it converts to yellow bilirubin, and then it excretes from the body. You can see the same thing is happening if you have a bruise. Like if you play football, you can get some injury. Not many people are playing football these days, football or some games where there is a chance of getting an injury. Indeed, this happens to one of my close friend. So he get injured and he was almost crying. I took the advantage of that. I took the photography to see that what is indeed happening of this bruise with time. Okay, so the pictures is not very clear because the resolution was very poor. It was taken long back, many years back it was taken. So you see that when you get a bruise, there it will be red because blood will be coming out. But then this heme oxygenase would be immediately excreted. The enzyme comes and takes its job. With time, you will see that that bruise will be turning like green, although it will be looking black because it is a dark green color. and then yellowish, and then after a few days, it would be your body color. So in the village, if you are, there is not too many doctors around you. So people are taking care automatically. Nature build our system in such a way that it will be taken care like that automatically. You don't need to go to doctor. You don't put any ointment, because heme oxygenase will work on it, and heme oxygenase convert hemoglobin to bilirubin, and this bilirubin is strongly antioxidant, very strongly antioxidants. Okay, and it protects our skin, and it converts to yellow automatically in the absence of any medicines ointment. But if you go to the doctor, doctor will prescribe some ointment where this bilirubin is a very, very small quantity, 0.001%. And that's why you have to put it for a 1 month or for 2-3 weeks to get it cured completely. Okay. Why it is so? Because in the city, or if you have a lot of money, you use this soap. Soap is basically the base and which kills everything. All this bilirubin, biliverdin will be getting killed. So one need to use those artificial medicines, artificial ointment. But please note that naturally you're supposed to have 100% lot of bilirubin, strong antioxidant, but in the ointment you will see that antioxidant is very, very small quantity. Now I also like to show you one thing, like the potato. If you cut it, fresh potato, and you just keep few hours, it will turn brown. Similarly, same thing happens to apple also. Now, why this protects like this? Because the tyrosinase enzyme, which utilize oxygen and protect the surface. Now, whenever you need, you just remove this outer skin, and it will be as fresh as it was like this. Just remove this outer skin. Okay, and this protection is very, very important for the potato. That is why it is not getting destroyed. That is why insects cannot come and destroy this. This is not present in case of brinjal. In case of other like banana, you don't have. That is why, if you cut it, it is getting destroyed. But not in potato, it is happening. Okay, so this is what is the technology which one should adopt. We must learn how to put this protection, and this is what will change the world. We have to learn from biology. Indeed, this is the enzyme which converts to phenol to diphenol, and then quinone, which is brown in color. This is what is the coating on the potato. And I will stop here. And this is what is my group at IIT Kanpur. You can see my group, our research activity, just by clicking in the web page. You just Google, in the Google, you just use SP Rath, then you can come directly to our website and see that what kind of work we have been doing over the years. Last 17, 18 years we have been working. Around 20 PhD students graduated under me in my laboratory. Okay, so I'll be happy to ask any questions if you have. Thank you.
The lecture is open for discussion. Participants can ask questions. If they have any questions, any doubts, they can ask.
Hello. anybody have any questions? Okay, I think Vikas Pandey has raised his hand. Vikas, can you ask your questions, please? Vikas, can you ask you have to unmute. You have to unmute first.
Unmute.
Yes, sir. Yes, sir. Yes, sir.
Yeah, please go
Sir,
ahead and ask.
I would like to ask that whether is there any relationship of bilirubin with the hepatitis A, B, and C?
Yeah, there are relations. I think I am getting muted. Ah, okay, please don't do that. Okay. Yes, there are relationship, of course, but I cannot tell you more than that because it is the doctor who can tell you more. I can tell only chemistry component, chemistry part.
Okay, sir. Sir, I would like to ask one more thing that I have one phytochemical compound extracted from plant. So this shows activity related to this jaundice. And we had given this extract to human beings, and it is found that the levels of bilirubin in their blood decreases after 2 or 3 days. So it is a plant extract. So I want to go further into it, and I want to extract that component which is actually responsible for decomposition of bilirubin. Sir, how can I proceed further, sir? Do you provide any idea, please?
No, actually, say for example, as you can see that what is happening. Say this bilirubin, first, whatever you have extracted from the plant naturally,
Yes.
it is good things to do, but you have to identify the molecule first. What is that
Okay.
molecule? What is the chemical structure of that molecule? How then it is working with this bilirubin, which you can study in the laboratory. So to me, if I am in your place, at your place,
Yes.
I would do that. I would first try to identify what is the molecule
Okay.
which you have extracted, number one.
Yes.
Number two, I will try to do in the laboratory, because in the laboratory you have a small molecule, you can have better control.
Yes. Yes.
Okay. And then you just try to combine with your bilirubin and see that how it is getting decomposed. Okay. Now, without understanding your molecule, you cannot do anything. Just like, if you close all this light from the room, you cannot see anything. Okay. So you need to first know what molecule you have isolated. And then only you can see, you can think that what could be the reason.
Sir, it is possible to conduct the decomposition of bilirubin by using this extract?
Yeah, why not? So extract, as I said that first you need to know
Okay, okay.
what
Yes, yes, sir.
there,
I need to separate that. Yes, yes.
you need to know what is there in the extract, because extract can be several things and you don't know what is happening. But even with extract, you can study with the artificial bilirubin and then see that how it is participating in the decomposition process. Mm. Thank you.
Thank you, sir. Thank you.
Thank you. Anybody else?
Participants can ask questions. They can unmute themselves.
Anybody has any questions? Anybody?
Participants can ask questions if they have any question. They can ask. They can unmute and ask their questions.
Looks like there is no questions.
I think no questions.
Okay.
So it is a great pleasure for the Department of Chemistry, Government Digvijay PG Autonomous College, to have an eminent teacher and active researcher like Professor Rath between us as our keynote address. He is a highly reputed and recognized academician, not only in India, but all over the globe. He has discussed about our life with oxygen. He discussed about the chemistry of singlet and triplet oxygen, antioxidants, oxygen in biology and diseases. I extend my heartfelt gratitude towards Professor Rath for accepting our proposal for keynote address on such a short notice. Thank you very much, sir.
Thank
Now
you.
I'll hand over the session to Dr. Dakeshwar Kumar Verma.
Okay. So should I close it?
Thank you, sir. Thank you for
Thank you
your
so much,
nice
sir.
lecture, sir.
Yes, sir. Thank you, sir. Nice lecture, sir.
Okay, thank you. Thank you. So should I close it now? I guess. Okay.
Yes, sir.
Okay,
Yes, sir.
thank you.
Yes.
Okay, thank you.
Participants, just a minute. Our speaker just join shortly. Please keep quiet, all participants.
हाँ. Very good morning, all of you. I welcome you all in this session. And our next speaker is Dr. Chitranjan Das from Germany. Dear participants, you all are requested to keep calm and patience. You all will get feedback form at the end of this session. Dr. Das sir, are you here? Hello. Am I audible, sir? Gokul sir, am I audible?
Yes, sir. Yes, sir.
Hello. Dr. Chitranjan Das sir, are you here?
Hello, can you hear me?
Yes, sir. Yes, sir. Yes, sir.
Hello.
Yes, sir.
Sorry,
Yes,
I think
sir. Yes. Okay. Okay. Okay, sir.
Very good afternoon, sir. I welcome you in this platform and thank you so much for here with us. Dear participants, we have Dr. Chitranjan Das sir from Germany. Before his lecture, let me introduce him. It is my privilege to introduce Dr. Chitranjan Das, entrepreneur, solar cell CTO, Persosol Startup Germany. Sir has completed his UG and PG degree from Sambalpur University, India. He completed his Master of Technology in Material Science and Technology from Indian Institute of Technology, Kharagpur, India. Here, his research area is semiconductor, material, and properties. He did his PhD in physics from BTU Cottbus, Germany, and his research focused on spectroscopic and electrochemical study of TiO2 and Si photocathode. Recently, he is pursuing his postdoctorate from Institute of Applied Material Energy Storage System, Germany. He was also postdoctorate researcher at Institute of Applied Material Energy Storage System, Germany, with research area surface and interface engineering for conversion materials and devices. He was research assistant at FAU, Germany, and his research area was preparation of titanium dioxide nanotubes by anodization and study of the photocatalytic property. He has various organizational skills, which includes he is organizer at Symposia UEMRS Fall Meeting 2019, Warsaw. He is also an organizer at Symposia C EMRS Fall Meeting 2018, Warsaw. He also acted as scientific committee member at Symposia Q EMRS Fall Meeting 2017, Warsaw. He is a reviewer of various prestigious journals like ACS, Ville Science, RSC Journal, and Elsevier. He is also a guest editor of very prestigious and famous Journal of Material Chemistry C and Applied Surface Science. He has worked with various industrial collaborations such as IMEC, Belgium, and his work includes cleaning of INP with in situ ultra high vacuum H2O cleaning, and surface characterization using synchrotron radiation, surface characterization of ALD, titanium dioxide layer on RuOx TIN Si surface, ALD growth of Al2O3 on graphene 2014. He has published more than 45 research papers in various international journals of ACS, APS, RCS, RPS, Valley Science, Elsevier, Springer, etc. Also, he has Google Scholar citations of 1932 plus with H index of 21 and I10 index of 30. Dear sir, I warmly welcome you to deliver your lecture. Thank you so much. Sir, mic over to you. Sir, please unmute your mic, sir, please. I kind request. Yes, sir, please, sir,
Can you
go
hear me
ahead.
now?
Yes, sir, you're audible, sir. Please.
Thank you very much, Dr. Barma, for the kind introduction. And I'm really thankful to all the organizers and to give me this opportunity to discuss my work in front of the audience. So my today's discussion topic is like X-ray photoelectron spectroscopy in the understanding of surface chemistry. So here I will be speaking mostly, or like I would like to introduce the X-ray photoelectron spectroscopy to the audience, and also how the group where I was working, how you use this technique to study different in different research facilities, just like solar cells, water splitting, and lithium-ion battery, and many other fields also. So let's get into the talk. Excuse me, someone wrote something. Could it removed? There is some red lines. Okay, anyway, so my talk is like X-ray photoelectron spectroscopy, and I would like to introduce a little bit of theory, and then the technology and how to measure different samples, different devices, and so on. And then I will also guide you through some of my applications, how I did this photoelectron spectroscopy and what we understand from this photoelectron spectroscopy used on different devices such like photoelectrochemical water splitting systems, solar cells, and energy storage, mostly lithium-ion battery I was working on. But probably I will not explain about energy storage system and its application, XPS application in it. So why I choose surface science tool, XPS as surface science tool. So here is lots of systems that we can study, like for example, like EDS, Raman, XPS, XRD, ellipsometry, and so on. So most of them are like they are used for different purpose. So here you can see how deep we can analyze, and here the detection range, atoms per centimeter square. So it depends on what's our use. So we have to choose each one of them or combination of one or more. So for example, if you see like Azure or XPS, so they are very sensitive in case of atomic sensitivity, but it's also really limited to 0 to maximum 100 nanometers. So that means it's very surface sensitive. So you cannot measure very bulk or like this big or micrometer big thin films. So and also another thing is that like most of the things like solar cells, water splitting, or lithium-ion batteries, and they are very surface sensitive. If we change the surface of these materials or the devices on the film, then the property changes completely. So that's why we are focusing on the XPS application to study the surface and interface of various devices, materials, and films. So I would like to explain what is photoelectron spectroscopy and how the measurements and what's the theory behind it. So I think most of us know or well acquainted with this photograph. So it's Professor Albert Einstein, and he got his Nobel Prize in 1921. It's almost like 100 years ago. So this is the 100th anniversary of his Nobel Prize award. So he got this Nobel Prize. His contribution was the photoelectric effect. So and then almost 20 years, sorry, 60 years, after 60 years, so Professor Kia Zegman from University of Uppsala developed this, use this process to characterize the materials. That's called photoelectric. Use this photoelectric effect to characterize the materials. That means here he used X-ray and incident the X-ray to excite electrons, and from this one can study the different properties of materials. So how it works? Actually, the photon means like it can have various range. So it can have wavelength 10 to the 3 millimeter to 10 to the minus 12 meters. So that means it combines all the starting from radio to gamma rays. So all are not photoactive. For example, here you can see this. Now, like if we are eliminating with 700 nanometers, which is like a visible to infrared region, we don't excite electrons, so that the electrons cannot emit from the surface of any object or any film or any material. But when you are decreasing the energy wavelength of this light, for example, for 550, so there is some material, it's like I think it's sodium in case, sorry, it's a potassium. When we are taking a potassium film and then incident with 550 nanometer, then the photoelectrons are ejected. And then from these photoelectrons, we can say what are the characteristics properties of this film. So even we go beyond like 400 nanometer, then again, we can increase the outcoming of electrons from this surface. And if we go to the X-ray region, so we have like soft X-rays and hard X-rays. So soft X-rays starting is around 200 to 2000 electron volts, and whereas hard X-rays can be go from 2000 to 5000 or even 10,000 electron volts. And depending on what we need, we use this different kind of X-rays. So this is very simple equation, like we incident the energy, then the photoelectrons absorb this energy coming out, and it has it gives you a kinetic energy, and from this kinetic energy one can determine what kind of material it is, and it's coming from which core levels, or we'll discuss it in detail. So basically, we in the XPS community, we are using this notation, like this is the photon energy, this is the work function that's all the materials have, and this is the kinetic energy of the outcoming electron. So how we already see this, how what photons interact with the film or any object, but when it comes to X-ray, how it works. For example, here we incident the material, it's atomic scale image. So when we incident X-ray on an atom, so what happens, that the X-ray interacts with the core electrons. So these are called core electrons, and this is the outermost electron is known as valence electrons. Then it interacts with these electrons, and some energy from X-ray is translated to electrons, and these electrons get excited, and some of them get emitted from the surface of this atom. So that's a free electron, or we call it photoelectron. And so depending upon different core levels, so these ejected electrons are different kinetic energy, and this kinetic energy gives idea to us, like from which core level it's coming, and it's a characteristics of the material. So for different materials, the electron kinetic energy would be different for the same X-ray energy. So here is a clear view of like this Venn diagram. So here we can see like 1s, 2s, 2p, then 3s, and so on. Then we have like, that's called band gap, and then the form that's called band gap and Fermi level in case of semiconductor. Probably in case of in metals, then we don't see this valence band or band gap, so it's only a Fermi level, and then the vacuum system. So photon comes in and the electron goes out. For example, here it emits an electron from 2p level. And there is also probability that electron can be ejected from the 2s level or 1s level. So depending on this, what is the kinetic energy, and kinetic energy is given by h nu, the photon energy, and the binding energy of the electrons plus work function. From here, one can say if it's coming from 2p, 2s, 1s, because like we have fixed photon energy and fixed work function, then the binding energy is changing, so also the kinetic energy, or the other way around. And this helps us to identify the exact element, the composition, and the valence band structure, or the electronic structure, what we call electronic structure also. So how it works for a system, that means like we have, this is the material we have, and then how we measure it, because we for measuring we always refer to a reference energy, and our reference energy is the Fermi level, the Fermi level of the spectrometer. The spectrometer is connected to the ground, so that means the Fermi level of any material has the same Fermi level of the spectrometer. And then when we incident X-ray, then the core electrons comes out to the vacuum level, and from here then we measure the kinetic energy of the electron, and that says, okay, if this is higher or lower, or depending upon the differences, we can measure the binding energy. So here is a view graph, a clear view graph, where you can see like electrons are coming from different levels with the same X-ray. And how it works, here is a cartoon, you can see. So we eliminate the X-ray, and then it's monochromatized, and the X-ray goes to the sample surface, and the photoelectrons comes. And this is a spectrometer that measures the kinetic energy of this electrons, and then it gives a spectra. So here is just an example, like the electrons coming out, so X-rays coming out and electron going out, and electrons can go in all the directions, but we have to focus, just like here, the focusing mirror, you have also focusing mirror here, and then it's accelerated the electrons to get the proper kinetic energy, and then again it translates the kinetic energy to the binding energy. So here you can see, like you can see it's an example of random spectra, and here you use aluminum K alpha, which has kinetic energy of 1486.5 electron volt photon energy. And then when we incident, we see how the spectra looks like at different kinetic, at different binding energy. We have peaks, and on all other places it's really constant, or what we call background noise. And this background noise comes from this collision of these outcoming electrons with the atoms, and then we get this background. And when we have a core level, then this core level shows a peak. So we'll discuss what are these core levels in detail in next slides. And here basically there are two ways. Either we measure kinetic, or either we measure represent in a kinetic energy form or binding energy form. So most of the practice thing is like binding energy form, and when the binding energy is increasing, the kinetic energy decreasing, in the other way around. So what are the possibilities that one can work with X-ray photoelectron spectroscopy? So here you can see that it can measure check the availability of almost all the elements other than hydrogen and some rare earth elements, because this hydrogen and helium. Hydrogen has only one electron and helium has 2 electrons, so it's not possible to measure those things. But there are also some rare earth materials where the atomic cross section with the X-ray is very low, so that's why also we cannot measure those elements. And so another beauty is that the chemical analysis. That means one can say what kind of chemical chemistry has this surface, and one can use this X-ray photoelectron spectroscopy to analyze the depth of the material. Though in last slides we know that it's a very surface sensitive technique, and it's only useful for that approximately 3 to 10 nanometers, and it cannot go beyond that. But we can use depth profile sputtering and get the information from like micrometer level also. And also we can use this to measure the thickness of ultra thin films like nanometer levels, where the other techniques like it's not so good or not so reliable to measure the thickness of ultra thin films. And also one can use this technique to understand what's happening at the different interfaces. For example, like we know solar cells, silicon solar cells, and this is combination of many stacks. So if silicon with N-type and P-type, how they are making the band of at the junction. So this can be studied with the electronic interface properties using XPS. So what are the how we choose how we'll decide which element is what? So we already learned that when X-ray is incident, and then the core level electrons are ejected, and depending on the kinetic energy, it will have different. Depending on the kinetic energy, it will have different position in the spectra. For example, one spectra coming from, let's say, oxygen 1s. Oxygen 1s should be at 500. It should have a 530. But if we are using carbon 1s is at 282 or 284 electron volt. So depending on this, because this is also bounded to the nucleus, and the number of electrons has in Coulombic force between the nucleus and the electrons, and this force is broken, and then it's translated into kinetic energy. From there, we can determine what kind of materials. For example, it's here we see like lead, carbon, oxygen. Also here around 402, it's nitrogen and iodine and so on. So if it's a mixed bag of elements, also like 5 to 6 elements, we can determine what kind of elements are there and what are the concentration of those elements. So this is really informative that if you come to me with a sample and I say, okay, I don't know what are the composition, and then probably I can tell you what are the composition of this sample. So the next is the chemical shifts or chemical analysis. So chemical analysis, that as we know that when some materials, for example, here is an example of lithium. So when lithium stays outside, then it gets oxidized. So, and what happens? How do you know if it's lithium is quite shiny, and when it gets oxidized, it gets some color? So, of course, one can see this, say this, okay, if it's oxidized, it's getting some color, but there are some other materials like silicon or aluminum, they don't change their color. So how do you know that what are the, if it's oxidized or no? So that's very simple process. Like we can use XPS to investigate if it's oxidized or it has some other chemical properties. For example, like, so lithium is one lithium is bonded to two lithium is bonded to one oxygen, then they share electrons among themselves. So that means that so lithium takes electron, and so that's why it's shifted to higher binding energy. So I'm sorry. So lithium gives away electrons, so that's why it's shifted to higher binding energy. That means like lithium is oxidized. So less electron, more binding energy. And similarly, this is an example of carbon or that electrochemically prepared carbon, electrochemically treated graphite, a carbon. So this is graphite peak. This is carbon-carbon, another carbon-carbon bond. Then, but when its carbon has hydroxide or carbon oxides, then you can see the peak is shifted from lower binding energy to higher binding energy. And if it's ester or carbonate, it shifts towards more or higher binding energy. From here, we can say, okay, your carbon material is not only carbon, it has lots of oxidation or oxides or esters. Ester group is attached to here, or carbonate is attached to here. So this gives like, okay, the surface is not pure. Or if it's pure, we'll only see big peak of graphite only. Similarly, there is, as I was saying, this silicon example, like basically say when you lay outside the silicon gets oxidized by itself. Most of the elements gets oxidized by itself other than gold or platinum, silver. So for example, the silicon, elemental silicon has binding energy around 99 electron volt, but when it gets oxidized, it's bonded to 4 oxygen, silicon is bonded to 4 oxygen, then you get another peak, which is called silicon 4 4+ state, like when silicon is bonded to 2 oxygens, it gets silicon dioxide, and then it has 4+ oxidation state, and which is approximately 3.8 to 4 eV difference between the silicon and silicon oxide peak. So from here, one can say clearly that if it's oxidized or no or not. For example, like this yellow curve, you see this is mostly a silicon spectra, and the other peaks, like you have like certain amount of silicon dioxides and silicon suboxides, because these peaks are showing okay if it's oxidized to 3+ states, 2+ states, or 1+ states, and so on. So this is a clear indication that how your material is changing. Similarly, if silicon is attached to fluorine, it can be attached to 2 fluorines or 1 fluorine or 4 fluorine atoms, and here you can see the silicon is changing its oxidation state and the shift in core level. So shift in core level means that this binding energy will shift, and this binding energy shift by when it's like attached to 4 electrons, then 4 fluorines, then it will be shifted by almost like 4.5. When it's 2 electrons or 2 fluorines, shifted by only 2 eV. So from here also one can differentiate between if it's purely silicon or silicon dioxide or silicon fluoride or something siloxane and so on. So that's the beauty of this technique, that you can not only say if it's you have for example in this case silicon or silicon dioxide or silicon fluoride. And of course one will ask, okay, we see silicon fluoride at the difference of 4 electron volt, so also the silicon dioxide, then how to differentiate? Then if it's silicon dioxide, you should see lots of oxygen. If it's silicon fluoride, you should see also lots of fluorine. So from there, one can differentiate, okay, if it's silicon oxyfluoride or silicon fluoride and silicon dioxide and so on. So these are some examples. So another thing is that, as I mentioned, that one can really measure the thickness of the film or nanometer level film using the D'Alembert's rule, that when X-rays goes and the electron out, then it loses some energy, and from there how much of energy it's losing. So depending upon that, one can measure the thickness of the film. So here we are using this formula, the I is equal to I infinity exponential of minus d by lambda cos theta. This lambda is the attenuation length of the electron. That means that during the ejection of electron, it's interact with the material and losses some energy. So this losses of energy is in which level it will, which attenuation length, and that's called lambda. And by inserting the value of lambda and cos theta is the distance or angle between the emitted photoelectrons and collected electrons. X-ray, incident X-ray and the emitted electrons. And from there, one can really identify what thickness is. Or if we increase the angle, if we make more, we call it grazing angle, then you can see, for example, here the 0 degree, when your X-ray and spectrometer are same, then you don't see lots of silicon dioxide, but you just tilted your sample, for example, here, then you see lots of silicon dioxide. That means it's a surface sensitive. And with the variation of angles, one can really determine how thick is this nanometer scale film. In most of the techniques, it's not determined, but here one can use the theta value and change the angle and get the intensity, and from there you can manipulate the thickness of your film. So there is another process is called sputtering depth profile, and here you can see when you have sputtering, then you get the spectral response, or you see change in spectral response. And from there, for example, like here, you have gold film on silicon, and then you sputtered away. Then the thickness of gold should go down and down. At some point, you don't see anything. And from there, you can say, okay, and there's sputtering rate. And from there, you can say, okay, what's the thickness of the film? So another process is like what we call bottom-up approach. In this process, normally you put different layers of film and see if the signal is coming. For example, we take a material called MATI and then we put carbon on it or spiro on it. It's a organic molecule, and then we see this carbon is increasing. And at some point we don't see this signal, and then we see, okay, when it's approximately 10 nanometer, or we don't see the signal from the substrate, and from there you can say, okay, now my film is 10 nanometer, and so on. And another thing is that the quantification. Okay, we measure if we have iodine, gold, or whatever elements, but how to quantify? So this quantification is like the peak area under this curve. If, for example, it's a gold 4F spectra, and then when you measure, then we take the area under this curve and the sensitivity factor of the element. So this sensitivity factor is coming from many more things, just like incident photon flux, the number of electrons around it, atomic number, then photoelectric cross section, and so on. And these are mostly from the device of which machine we are measuring, but these are from the elements. So these, most of the time, this remains constant. And if you are using a SEM device also, these things remains constant. And from there, the intensity may vary. And from there, one can say, okay, what's the atomic percentage of different area, different elements I have in this material? And that's the accuracy is approximately with the 10% error. So I would say like this is one of the best method to determine the chemistry as well as the elemental concentration of your material. So we are almost at the end of this discussion about the X-ray photoelectron spectroscopy. So what are the advantages of this? So this is really non-destructive. Probably some of our colleagues are doing different kind of measurements, and so most of the measurements are destructive, but this XPS is a non-destructive method, and it's very surface sensitive. One can measure really from a flat surface like few atomic level to tenths of nanometer. And then here we can say composition and chemistry of the material, oxidation states, and also one can use this XPS method to image, like if you have a 2 by 2 millimeter square sample, and then you want to see what is where, then you can use this XPS imaging and see, okay, you have gold, platinum, whatever you have in this sample. And then it can be used for depth profile, but depth profile, I would like to say, like it's a destructive method. That means like you have to destroy your device, and then you cannot get the sample back or as it was. So what are the limitations? The limitations is like it needs really ultra high vacuum. It's not very easy to maintain this vacuum. It needs lots of effort, and it needs a specialized system. So this electronics is so complex, and you have to care about all the tiny stuffs with the XPS machine. So also it's often cause misinterpretation of results. For example, like there are certain peaks, they have the same binding energy, and then it's difficult to interpret them. And most of the time it's not good for non-conducting samples, just like polymer films or like ceramic films. So they cannot be measured. Even they can be measured, but it's really difficult to analyze them. And there are some materials, like I will show maybe later, the X-ray radiation degrades certain materials. Like if you incident X-ray and some polymers, they degrade. That means they break their bonds, and then whatever you measure, it's not reliable. So with these abilities and disadvantages, like it's still useful in the industry. It's okay, it's useful in our day-to-day research also, but it's mostly also useful in industry like polymer, surface chemistry, catalyst, corrosion, adhesion, semiconductor, dielectric materials, electronic packaging, magnetic media, or thin film coating. Nowadays also bioelectronics or bioengineering, even many other fields. So now in the next half an hour, I would like to discuss some of my own results or the results from our colleagues. and we using XPS technique. So as I mentioned that one can really measure the very thin film. So here, this is an example like for what we did, like it's a p-type silicon, and silicon is getting oxidized. That's quite obvious. And then we put titanium dioxide by atomic layer deposition, and the titanium dioxide by atomic layer deposition is really in nanometer scale. Or also we can measure like one monolayer of titanium dioxide. So what we did, we do layer by layer deposition, and here you can see the silicon thickness is going down and down and down. So after 200 ALD cycles, so normally it's 50 cycle the black one, then 100 cycle the red one, and so on. And after putting like 200 cycles, we see almost no signal of silicon peak. And this peak, you can see this peak is around 400, 3.5, and then it shifted to lower binding energy. So this shows like, okay, not only the thickness is changing, also the chemistry of the material is changing over the period of deposition. And from here one can measure like what's the thickness. So basically I used two different precursors, and one precursor has 0.06 nanometers and another is 0.015 nanometers per cycle. So it's really in atomic scale. And if you see also we check the titanium dioxide quality, and here you can see it's the here titanium 4+ oxidation state and titanium 3+ oxidation state. So this blue is 200 and black is 500. In the 500 we have lots of titanium 3+ states. That means it's not properly oxidized. But when we increase the processing, that means like we are continuing the deposition, then it's getting more like titanium dioxide and less titanium 3+ states. And this XPS has really versatile application. So I will this is an example of like a photoelectrochemical water splitting system. That means like here is a semiconducting material that is photoactive or photoactive for certain region, and then you incident the light, and the light excites the generates photo electron and hole pairs, and here the holes react with the water to reduce, to oxidize it to get to water, and O2, and the electron interacts with the water to get H2. But the problem is that this is very promising system for the sustainable energy and the green energy. The problem is that most of the time either you are using acidic solution or alkaline solution. All of this solution degrades the degrades the working electrode. That means the photoelectrode, either it is cathode or anode, it doesn't matter. So it degrades over the time. That means like it reduces its photocatalytic activity, and as well as in some cases we see there is a corrosion. That means at some point you don't see your material is hanging around it. So it's just like dissolved. So these are different schemes that people are using PEN or PEN separately, and so on. So in both the cases here, it reduces, and some places it's oxidize the material, and then you don't get any photocatalytic activity, and most of the so that's the problem. So with the XPS, one can really study what's happening here, why it's getting oxidized. So how strongly or how quickly or easily it's getting oxidized, and all these things. And for this, like we did what we did, we deposit a thin layer of titanium dioxide around this electrode. For example, like in my case, we use silicon. So we use titanium dioxide to coat with this, and then perform the photocatalytic activities. For here, you can see that it is silicon spectra before any electrochemical measurements. Just after electrochemical measurements, the silicon dioxide thickness is increasing. Here you can see like silicon dioxide approximately 1 nanometer, and then it's increasing to 2 nanometers. It's just after like few cycles. If you leave it for 1 hour, then you don't see any silicon. That means it loses a photocatalytic activity, and when it forms more than 4 nanometer, then you don't get photogenerated electrons to electrolyte, and then the catalytic activity stops. So, but when you put a titanium dioxide very thin layer approximately 3 nanometer, and titanium dioxide is semiconducting. That means electron can tunnel through it or pass through it, and then you don't change the oxidation of the silicon. And also titanium dioxide itself is oxidized, so you don't need to worry about that. And what we did also, we try to decrease the thickness of the silicon dioxide by HF etching, hydrogen fluoride etching, and then here we deposit titanium dioxide. And then here we can see after etching with the titanium dioxide, you don't see in this really prolonged oxidation of the silica, and so that's why it gives a better protection against the silicon's photocorrosion, and also keeps the longevity of the silicon photoelectrodes. So in the next example, I would like to explain about one of the most happening research. It's called perovskite solar cells. So this perovskite has this ABX3. So A is a cation, which can be methylammonium, permanganedium iodide, or cesium, or combination of all of this. And B is the lead or tin, or sometimes silver also. And the X is the halide, iodine, chlorine, or bromine. So depending on the substitution, one can really change the band gap of this material, and it's really very defect tolerant. If you take methyl ammonium lead iodide, then it has a band gap of 1.5. If you increase permanganate lead iodide, it can go to 1.7. If you, instead of lead, if you use tin, then the band gap can decrease. It can come to like 1.2 or 1.3. So here you can really play with the materials or elements and change the electronic properties of this material. But why this material is really getting famous in last 10 years? Here you can see this very crowded chart, and indeed it's crowded because it's a combination of different photovoltaic techniques. Like here we can say like multi-junction, single junction, crystalline silicon solar cells, thin films, and now the emerging, which is like Dyson style solar cells or perovskite solar cells. And this yellow and red is perovskite. And if you see, it's just yellow and brown. Sorry, yellow and brown. It started in 2009, peaking of the efficiency, and to date it's like 26.7. It's rapidly within 10 years. It started from 3 to 4% to the 26%. It's a lot of growth in the case of solar cell technology. And if you like, if you see silicon is started in 1970s, and it's showing approximately 30% efficiency or 28% efficiency. So you can see that's a time span. It's within 1 decade. It started. It's from 2 to 26% of efficiency. However, the problem is that unlike silicon or gallium nitride or gallium arsenide or 3,5 semiconductors, these kind of semiconductors are not stable for a longer time. Maybe you leave it in the outside for 1 hour or 1 day, depending on the combination, it degrades. That means it changes its photoactivity, and then and you don't get any efficiency out of that. That's the problem. So that's the reason that so far it cannot be industrialized. For example, like silicon, if you buy a silicon panel from the market, then they give you warranty of 20 years. But here it's so far it's not possible to say so. So here is an example, like as I was saying that, okay, these perovskite samples are, perovskites are not stable. So this is perovskite, it looks really brown. That means it can absorb the photon energy of like 500 nanometer or in the visible region. And then you leave it in the lab for half a day or 1 day, then it gets yellow. That means then the photocatalytic activity, photoactivity decreased, and then it can only absorb the band gap around 2 eV, which is mostly like green or so on, or approximately green color. And then it's not, it's kind of it's also semiconductor, but it has not proper band gap or so that it cannot convert the photon energy to the electrical energy. And here is an example, like we see it's the freshly prepared solar cell, and then we leave it for few days, and you see it's from brown to getting yellowish, and after a few days some more days, and you don't see any perovskite layer on it, so it's mostly semi-transparent, and then it decreases the activity. So what we did, we try to see what's happening here and here. Then we take a cell and put in the X-ray machine, and we see this is nitrogen. Okay, so we can't continue measuring for 10 hours in the dark without any illumination, and you see the nitrogen is not going away, lead is fine, and also valence band is not shifting. And then we just incident light, we see what's happening. We incident light on it. Okay, it was stable for like few hours, and then the nitrogen disappears because it's like organic inorganic hybrid, and these organic bonds are not stable, and it disappears. And when it disappears, it makes lead to lead zero state. Lead zero, it means metallic, so it loses its semiconductive properties and became metallic. And also here you see peak is coming around 0 eV. So that is the Fermi level that I was saying, like, okay, metals don't have band gaps, so they have Fermi level, and these Fermi levels are bad for semiconductors. And when we see, we measure almost like for 14 hours, and we see lead zero concentration is increasing, lead is staying stable, iodine is decreasing because it's like methyl ammonium iodide, and then methyl ammonium iodide is broken, methyl is going out, and iodide is going out. I don't remember, it's CHI or HI, so it's going out. And we always pump down the system, so that's why we see the iodine is coming, going down in the concentration, like started with 40% and end up with 30%. But lead is remaining constant, but lead zero is increasing like anything, and then it's disrupt the semiconducting properties of this solar cells. So what we do also, we use same what we learn from our LD techniques. So here there is an example, like it's a perovskite in dark and perovskite in light. You see the perovskite, how it looks like, and when you incident light outside, then it's converted. It's really crystalline. It's converted to another crystalline form. That means it's mostly lead iodide, or let's say we don't know. And then when you use like really thin layers of LD, and this thin layer is like 3 to 4 nanometers, not more than that. Otherwise, again, it will have some issue, and then the electrons cannot transform from this perovskite to the surface of to other contact materials. So again, what we did, sorry, here you can see the perovskite with LD, without LD. The same thing, 8 hours, 24 hours, and then you can see it still looks black or brownish, but here it's getting yellow. And here you can see with the incident over the increase of time, the iodine is not shifting, but the iodine concentration is going down. Here you can see the peak intensity, and peak intensity is decreasing. Whereas in lead, the lead zero state is coming out, which is at binding energy 137. And for here, the nitrogen is decreasing. Another thing is that here it's a combination of bromide. And when there is, so this is pristine, we see lots of bromide. After aging, we don't see any bromide. And when we put aluminum oxide, we see clearly aluminum oxide, and after aging also we still have aluminum oxide bromide. So this means like the sample is stable when you are using really tiny amount of aluminum oxide, and the aluminum oxide is only 3 to 4 nanometer, and that can be seen. So here I just want to show you that how the XPS can really measure a tiny change in the substrate or what's happening there. So just here put aluminum, we see aluminum, and if the bromide is going out, then we don't see any bromide here. Even we see how the chemistry of this surface is changing, like its carbon has two peak. After degradation or aging, like for this yellow, you see a very broad peak of carbon. But basically, when you put aluminum oxide, then it's not changing that much. Of course, it's changing because the aluminum oxides hinders this carbon to come out, and then it's changing. But unlike the degraded, it's not completely out. So another thing is that in the previous studies, we just studied the film of the perovskite film, but the solar cell consists of many more layers. For example, like it's a ITO glass, indium tin oxide, which is a conducting transparent oxide. Then ETL, what is called electron transporting layer. It's mostly metal oxide like tin oxide or titanium dioxide. Then the perovskite, we already learned it about the perovskite. Then the HTL, hole transporting layer, and then the metal contact, that's the photo-generated electrons and holes separated. Here in this case, in the present architecture, holes will flow to gold and electron will flow to ITO, and then you get a photocurrent. And there are, as I was explaining, there I don't know if you could see it clearly, but there are many various kind of perovskites. Here you can see cesium tin iodide, permanganonium cesium tin iodide, or lead iodide, and so on. So depending on the combination, you can manipulate the band gap of these materials, and that's really good for the application. And for that, you need to have different ETL or ETM. So this either can titanium dioxide, zinc, so on, cerium oxide, PCBM. PCBM is a organic molecule, and the C60. Whereas the whole transporting layer, you have many more: copper oxide, molybdenum oxide, copper iodide, and so on. Spiro is another organic material, and so many others. So here I want to say, like, if you take one of these, then you have to find a proper combination, which one will work with what. It's not like all the combinations. You can take a MAPI, or sorry, MAPBRI3, and then use copper oxide, then it will work. Probably it will not work. So one is to find it. So in principle, normally the electrons and holes get separated here, and the electrons flows from the conduction band to the titanium to the ETL, and holes flow from perovskite to the STL, and then you have a complete circuit where you generate your current. So our goal is to study this, what's happening there. So first thing is that we can study or deposit by layer, as we layer by layer, and study what's happening in this layer from perovskite to STL. So what you do, we take a stake of perovskite, and then we put HTL and measures one by one. Just make one monolayer, measure one monolayer, measure, and so on, so on. And here you can see it's a nitrogen from the perovskite. So sorry, I may take few more minutes to complete my talk. So here is a perovskite, has nitrogen as 403, but when you put Spiro, it has also a molecule. This molecule has also nitrogen, and they're completely different. And from this shape, we can say if it's what kind of band bending is there. Whereas the lead is not changing, because like the lead is not changing, iodine is not changing, but the nitrogen is changing and carbon is changing. From here, since iodine and lead are the substrate, it's from the substrate and they are not changing. That means there is no changing at the band, at the interface for the perovskite. This is the perovskite, and then there is no change. But the Spiro is changing, and the carbon is also changing. The carbon is changing. Carbon is in Spiro as well as perovskite. From here, we can say, okay, there is a band bending at the perovskite and Spiro interface, of perovskite and STL interface, and which is a very favorable condition for this kind of structure. So that's why we see, okay, holes can pass through this and the electrons cannot go through this. So that's why this device is working. Also, we study different kind of structures, like So we study different kind of structures, like either you can take hole transporting layer, perovskite, and electron transporting layer, the other way or the other way around. Then here we use tin oxide, then MAPI and Spiro, and we switch light. And you see, sorry, it's in the dark. Then you see there is this band bending, in, like here we see like there is this band bending and still existing here. But when you incident light, this band bending is gone. And so from here, what we see, like we deposit, let's say 10 nanometer Spiro and make an XP spectra and then put light, and this is shifts, and this shows like, okay, there is a band bending here, and then this band bending is gone. Similarly, we take nickel oxide. Nickel oxide is the hole transporting layer. That means it's p-type semiconductors, and then we see this band bending. We just deposit very tiny amount of perovskite, and we see that there is a band bending. And when you incident light, then it's completely, that means like the peak is shifted to low binding energy, and then we see, okay, no, there is no band bending at all. So basically here it shows like which interface here it is. So we call this is as interface. So N, I, P, and in this case P, I, N. So P-type intrinsic semiconductor and N-type semiconductor, and it's other way around. And in both the cases, we found the band bending. You can see this is always between MAPI, or sorry, Spiro. It's between the perovskite and hole transporting layer. And here is also, if you put hole transporting layer first and then the perovskite, then you can see also hole transporting layer and the perovskite. It's always the it's always between the N-type, sorry, it's always between the P-type semiconductor material and the perovskite. Basically, in this community, people believe that the band bending is at the both ends, like P-type and N-type ends. So, but our spectroscopy XPS finding shows like, oh, no, it's only on P-type and perovskite interface. So also we want to study with, basically this is layer by layer deposition in the previous slide, what I saw, but if you do a layer by layer deposition, you cannot make a device inside the XPS machine. So what we did, like we take a device, like I was showing the perovskite, and then we sputtered it. So that's the problem. When you sputter it, after the sputtering, you don't see carbon spectra. It's only a single peak, or mostly a single peak. And the titanium should have a peak around, titanium dioxide should have a peak here, titanium 4+ oxidation state, I think we have seen in the previous slides. But when you incident high energy particles, argon ion particles, then you reduce this. So then you cannot say what's your real material, because we are manipulating the material by incidenting X-ray, by incidenting the argon ion. Then it's really difficult to understand what's happening. And for example, here it's from the top of the material, then it's carbon, and there is no carbon. See, this black to white is showing the intensity profile. So that means like if it's black, low intensity, if it's white, it's high intensity. And here you can see that it's high intensity, and at some point you don't see carbon. That means like it's sputtering our carbon. And so on. Also lead is lead 0. It's lead and lead 0. Lead 0, you can see that the lead 0 is increasing. So that means it's destroying the material, and then we cannot analyze this material. Only thing is that we can say, okay, this device has lead, iodine, titanium, and so on, all the elements. But we cannot say if it's titanium oxidation state 3+ states or 2+ states, and so on, or lead has oxidation state 0+ states or 2+ states, or carbon has so on. So it's difficult to say. For that, what we did, we tried to cut our solar cells in such a way that we can measure from here to here. It's not cutting, it's like a drilling away with a soft machine, and then we measure XPS along this line from here to here. As I was saying, like it's very surface sensitive, so it's not measuring deep into this, and also it's very space sensitive. That means we can measure at approximately 100 micrometer from here to here. Then you take multiple steps and you measure. For example, here is that we call taper edge because it's cut like in certain angle, so we call it taper edge, and you can see how it's measuring. So if you remember the structure, like we have gold, HTL, that's called spiro, perovskite, and ETL, and so on. And then here you can say when it's measuring, first it measures gold, then lead, which is representative of perovskite, and the titanium dioxide. So this is an image showing the way this region is gold. So you have gold layer here, you have lead, that means that's come from the perovskite, and you have titanium that's come from the titanium dioxide. So this imaging technique can be used to identify what is what. And then we did a detailed measurement. So just to say, like, it's lot carbon spectra here and throughout the whole of the sample, and then we put it all together, and this gives an image. Like here the highest intensity, here is a higher intensity, and there's a lower. And for example, like you see the gold, it's a gold layer. You see the gold is quite visible and quite strong, and then you don't see any gold. That means there is no gold, and so on. From there, you can, from this micrometer thick film, we can say what's the atomic concentration of various elements present. For example, here you have like gold, iodine, bromine, carbon, nitrogen, titanium, and oxygen, almost like 8 elements. So this precisely measure like which element is how many percentage. So this region is perovskite region. You see it has higher amount of iodine, lead, carbon, nitrogen, and so on. And this region is gold. So you have certain higher amount of gold here. Of course, the gold, certain amount of gold is penetrating towards the spiral layer of the perovskite layer, but here you don't see any. But the oxygen, this region is titanium rich region, and you see the titanium is higher here, and the oxygen. So this shows like, okay, this technique is really useful. And then from here we calculate which element is what, and we are expecting there should be iodine bromine ratio all over the same, but it seems like bromine is reaching towards one end. And from here also, again, if I plot, for example, it's the carbon, and I can plot it to fit into many peaks, or not as many as peaks, but we have to think, okay, there is a spiral, then you have like one nitrogen, carbon, and this different carbon, like this is phenyl. Yeah. So this ring like carbon has different, this carbon has different binding energy than this carbon and this carbon. So from here we can say, okay, which carbon it is. And that's why we have like 5 peaks here from different carbons. But here, as in the perovskite, we have only 3 peaks. And that's why we say, okay, this carbon is from perovskite and this carbon is from spiro. And also you can see this nitrogen, it has different kind of nitrogen and as compared to this. And here you can see the spiro nitrogen is a lower binding energy and perovskite nitrogen has higher binding energy. And when we move step by step, you can see how it's moving. And from there, one can say if it's the band bending is which direction. And here is an example, and I'm sorry. So here in an example, like iodine at low binding energy, and it's moving to higher binding energy. Higher binding energy, that means like electrons are more closely hold to the nucleus. That means it's going towards lower, the band bending is downward. And here you can see the band bending is downward, and the titanium is, it's not changing. So that's why you say, okay, this is at the perovskite and HTL interface. And the same thing like when you incident light, you see this lead is very straight, and when we incident light, it moves towards 0.6. This is the dark, and when incident light, it moves toward this. This is dark and it's moved toward this. So this 0.6 EV is known as the photovoltage, and that can be determined with the XPS. These are the XPS spectra. Just plot all together and make a image out of that. So from here, one can say, okay, what's happening at the interface and so on. Yeah, so I'm still continuing with my activities in perovskites, but now mostly I'm moving from basic science to the applied science. And now we got a funding from German Ministry of Economics and Technology, some 100,000 euros to work on this perovskite solar cells. And basically our goal is to, as we learned, that it's not very stable. It looks like this when you prepare, it's really freshly prepared, and you leave it for a few hours, then it looks like yellowish color. And so the goal is to make it stable, very stable, so that one can say in the market, okay, we have a stable perovskite solar cell for like 5 years. And then we want to, again, these are like 2 by 2 centimeter square. Then we want to make it upscaling in the industrial scale, and for that we want to make it flexible solar cells. That means it can be coated on polymer, or it can be put on your desk, your computer, at your building, or in your windows, or on your bicycle also. So that's the idea. So we want to make, we are in the process of developing the process for the thin film flexible solar cells, and then the application, this can be applied to any field, unlike silicon solar cells. Silicon solar cells can only be used on the rooftop or like open field. And if this is developed, or it's in developing stage, if it's successful, then one can really put in the poles anywhere on the rough structure, wherever it's feasible, one can put these things and harvest energy. Okay, with this, I am coming to my summary. Okay, XPC is a powerful tool to analyze the chemical and elemental analysis. It can measure variety of samples, thin films, powder, and so on. And it can measure your electronic properties, chemical properties of the surface and the interface, and useful in all the sphere of research, like electronics to biology, even like now space science also. So basically the goal is always science should work for a better future, and we believe that we are working for the better future of ours and next generation to come. And with this, I would like to thank Mr. Yunus Razabek to communicate with me and give me the opportunity to discuss my work with the group over there, or the students, researchers, and fellow colleagues over there. And also, I'm really thankful to Government Digbaje Autonomous College and all the organizers to give me the opportunity to discuss this data. And thank you very much. And I would like to discuss any questions, any suggestions. And with this, I end my talk from my side. So my talk is open for the discussion. Thank you very much, Mr. Chairman, Dr.
Verma, sir. Verma.
Yeah, Dr. Verma. Yeah, sorry.
Thank you, sir. Thank you so much, sir. Dear audience, if you have any question, please feel free ask to Dr. Das, sir. I kindly request you all, please. You all are requested to ask any question to Dr. Chitranjan Das, sir. Sir, actually, I have just for a query, I just wish to know how can we apply XPS for corrosion study, corrosion inhibition study actually?
Yeah, for example, like it's a basics means mostly the corrosion is in steel. So steel is consists of
Okay.
iron and chromium and some other things. So
Yes,
when it's corrosion, mostly it's getting oxidized. Iron and chromium and some other elements inside is getting oxidized. And the thing is that when it's oxidized, then you can see this iron changes its oxidation states, and chromium also. And that's the process. Like if you take a chunk of steel, and which is not corroded, and you give me, and then the chunk of steel which is corroded, and then one can see, okay, it's visibly clear, it's another thing. But when it's in nanometer level or micrometer level, then you can see these oxidation states are changing. And from there, or also you can say, like if it's iron is changing or the other elements over there is changing, then from there one can say if there is corrosion or no. if there is corrosion, is due to which element. So that's the basic way.
Okay, sir. Dr. Hemlata Mohbe madam is here. Madam, you asked a question. Please,
Yeah,
please,
please, madam.
you can carry this. You can play. Dr. Mohbe madam, please ask your question to Dr. Das, sir.
Please message or to unmute, I think.
Dr. Awad Hassan, sir. Yes, sir. They are unmute. Both
Yeah.
are unmuted. From your lecture, sir, I just come to know that XPS is not just a technique. I think it's a couple of a bunch of techos fellow who are working on solar cell, surface science, material science as well. So
Mhm.
those fellow can take help, can take benefited from this lecture, sir. It's a very helpful for.
Yeah.
Dr. Mohbe madam is here. Hello.
I think madam needs to unmute, or you need to unmute.
No, sir. It's unmuted, but I think there is some problem. Audience are requested to ask a question to Dr. Chitranjan Das, sir.
Or they can send them on chat also.
Yes, you can chat also. Whatever you have query and question, please chat also. Or you can ask directly. Okay, sir, I think we are not getting a response from audience or participants. So it's time for vote on thanks, sir.
Okay.
Really, it was a very nice lecture you shared to us. And it's a privilege to that thank you.
It was very interesting and very useful. We
Sharing
need
his,
energy.
thank you so much, sir, for accepting our.
Mrs.
Yes, ma'am.
Mohave
Yes,
is
ma'am.
saying something.
Yes, ma'am. Please, ma'am.
Sir, you have given a path for new solar panels. Which solar panels will be useful?
Thank you.
Which
hope.
alloys we should try?
Yeah.
You have told that zirconium, titanium, gold is very costly, then it will cost too much.
Yes, so we want to substitute gold with the conducting carbon.
Yeah.
Also, gold is difficult to pattern on such a large scale.
Copper will be getting corroded.
Yes. So
That will be-
carbon is one of the option.
Instead of copper, we'll take carbon. Yeah.
Yeah.
Sir, how much you have got success in your this experiment?
Honestly, in the lab scale, we are able to fabricate like 15 to 18% efficiency. But when it's come to large models, then it's going to 10%. And with the 10%, we cannot go to the industry partners and ask them, okay, give us few million euros. They say no.
Most of the inventions are from Germany, sir.
Yeah,
Huh?
yeah.
And
People
you
are
are there,
really.
and therefore we expect that for India's glory you will work.
Yeah,
And
thank
you
you.
will-
I hope one day I can start
Yes.
there in India,
Uh-huh.
or we can work together in India.
You are very successful in your endeavor, hard work and
Thank you, ma'am.
concentration with deep study is the
Thank you,
path of success. Thank you, sir.
Thank you, ma'am.
My niece is there, sir, in Germany.
Ah,
She is
that's nice.
working on, yes, sir.
Mhm.
In Karshul also. In
Karlsruhe.
Only in Karshul. Karshul University she is doing MS. Yes.
Ah, that's nice.
Yes.
I think
I
yesterday
will
I got,
ask her to meet you.
yesterday I got a message in LinkedIn from some Mohabe. So I thought maybe he's your niece.
Yes, sir.
Yeah.
She is
Okay.
working on sensor technique.
Sensor technology, SST.
Sensor
Sensor
technology.
science and technology. Yeah.
Sensor
Yeah, yeah.
technology, yes, sir.
Then I think she is the person.
I
who
will ask
contacted.
her, sir, to meet you.
Sure.
Sir, you have done very good work. Proceed
Thank
in
you.
this. I asked my niece to work on this only, solar
Yeah.
system,
Okay.
but she
Yeah.
diverted because
Yeah.
yes,
Yeah. Different people have different.
solar energy is very important. Wind energy. She had done BTech with a project on wind energy.
Yes.
Wind energy can be also converted into electrical energy.
Yeah. I think Germany is one of the front runner producing wind energy.
Yes.
In
Yes.
Norway.
Yes.
Yeah.
Thank you, sir, for
Thank you very much,
contacting
ma'am.
us.
Yeah.
And we got privilege due to the Digvijay College and
Thank you,
the
ma'am.
Department of Chemistry, Dakeshwar Verma, Miss Gokul Nishad, Priyanka
Yeah,
Singh.
I'm really thankful to
These
all
are
these
energetic
colleges.
persons, sir. They must also go to abroad for their study.
Yes.
Thank you, sir. Because
you,
of you, sir, we got the opportunity to meet you.
Yeah.
Thank you, sir.
Thank you.
Thank you, madam.
Thank
Thank you, sir. Thank you so much. A big thank to you for your lecture, and we expect the same for our future work. If you organize any kind of conferences in future,
Yeah.
we'll expect
Photoelectronic
the
spectroscopy is
same
topic of
cooperation from
MSc.
you. Yes, ma'am.
So therefore, you invite, sir, for lecture to our students.
Yes, ma'am. Definitely, we will make it sure, ma'am.
Sure, maybe if I'm visiting India in December, I can come in person.
You have deep knowledge of PES, sir, photoelectronics.
Just we are trying
And
to
that our students should be
understand the things.
benefited with that. Thank you, sir.
Thank you, ma'am.
Okay, sir. Thank you so much, sir.
Thank you, ma'am.
Thank you, sir. Thank you, sir. Thank you so much.
Good day.
Good day.
Thank you, ma'am. Bye.
Uh,
Dr. Soni is there.
Yes,
Namaste,
yes,
ma'am.
yes, ma'am.
No, sir, continue करिए आप.
Okay, continue
Please,
कर
ma'am.
रहे हैं. जी, ma'am, जी, ma'am.
Okay. Very good afternoon once again, respected all. In this series, we have next lecture of Dr. Rajendra Singh Thakur, sir.
I'm unable to share my
Dr.
screen.
Thakur,
How-
sir, are you here?
Can you hear me?
Am I audible to you?
No, I can hear you.
Okay, sir. Okay, sir.
But I'm not able to share my screen. How to do it?
Sir, if you are facing any problem, please you can. Yes, sir. Yes, sir. You are also audible, sir.
No, but can you see my screen? How will I present?
Okay. If you're getting problems, sir, please send your on the behalf of you.
Okay, let me do that.
Just wait.
ठाकुर सर को स्क्रीन शेयर को करिए ना, ठाकुर सर को को-होस्ट बनाइए। नहीं वो को-होस्ट बने हैं कि नहीं बने हैं? ठाकुर सर को-होस्ट बने हैं कि नहीं बने? ठाकुर लिखा है।
Dr. Thakur sir, just wait for a while, sir. Actually,
ओके सर, मैं आपको तब तक मैं मेल कर लेता हूँ। आप ट्राई कीजिए, तब तक मैं आपको
unable to
हाँ ये शेयर स्क्रीन हाँ आ गया। ओके, is it good now? Can you see some kind of presentation here? Hello?
Sir, it's okay.
Hello?
Okay. Hello. गोकुल सर, मेरा आवाज
मैं-
Hello, Thakur sir, are you here?
हाँ,
Okay, screen
yes,
is
I'm
visible,
here.
sir.
You are able to see my screen and you are able
Yes,
to
sir.
hear
Yes,
me?
sir. Yes, sir.
Okay, now I'm
Yes,
starting.
sir.
है ना?
Clearly, sir.
Okay, sir.
Sir, please, just for a minute, sir. Let me introduce you, sir. Sir, please.
Okay.
Okay, dear participants, dear audience, professors, respected all. We have in this series another young and energetic scientist, Dr. Rajendra Singh Thakur, sir. And you will be happy to know that he is the scientist at CSIR, CSM, CRI, Bhavnagar, Gujarat, India, as well as he is also assistant professor at SIR, CSM, CRI. Sir has completed Raipur. He is also gold medal during on his PG degree, that is MSc Chemistry. He has completed his PhD chemistry from Tata Industrial Fund and analysis of skin in solid state nuclear magnetic resonance. Has served as various responsible position in various institutes in India. From 2009 to 11, he has served as a scientist under UHS at CSIR.
Hello.
Hello? Hello?
Mute. Yes, mic mute. Yes, you are audible.
Hello?
Just a moment, sir. Still
Okay,
connected. Okay, okay, just a moment.
Extremely sorry to all. Due to some technical issue, I was left, unfortunately. Let me continue about Dr. Thakur, sir. As I told you that he has served as a various responsible position at various reputed institutes in India. In this regards, he has served as a senior scientist at CSIR, CSMCRI, Bhavnagar, India from 2015 to onwards. As he is a senior scientist at CSMCRI, and this during this, he and his team published various research paper in very esteemed and renowned journals like Elsevier, RSC, Springer, and many more. Approximately, they have published 9 research paper as at this position in which he have. They have filed as well as published various patents in this position. One patent having title of activated carbon metal organic framework composite materials with enhanced gas adsorption capacity and process for the preparation thereof. And another one is a process for the defluoridation of drinking water. And sir is the leader, principal. He has total of he has published various research paper during his PhD as well. And total he has published total 9 research paper in various prestigious journal during his PhD. And also, sir has completed SAPI of a DST WTI sponsored grant in aid project scientific understanding of defluoridation employing indigenous resin and comparison with activated alumina. MSc student will happy to know that sir has qualified CSIR NET JRF held in December 2003, and he has also invited for SPM fellowship screening. Sir, he visited Weizmann Institute of Science, Israel for 2 months, that is July, August 2007, with travel support from Taifer Industry Network, Sarojini Damodaran Fellowship local hospitality was provided by the host lab as well. He has also awarded Ernst Woodridge Fellowship to attend 5th Elfin Conference September 9 to 13, 2007 on solid state NMR in Chamonix, Mont Blanc, France. Sir has presented CSMCRI in Indian Science Congress 3rd to the 7th January 2020. He has worked in many teams on variety of basics and applied problems, published mechanism of Borate conversion in LDH, biochemical pathway marine algae, writing and whipping for the combination of chalkboard and duster, mechanism of dust chalk, mechanism of fast and safe defluoridation process. And this is the last but not least about the sir. Also, additionally, he has total 524 Google Scholar citation with H index of 11 and I10 index of 12. Sir, I kind request and invite you to please bless us by sharing your valuable thoughts and knowledge. Thank you so much. Dr. Thakur, sir.
Thank you, Dr. Verma, for nice introduction. Good afternoon, everyone. Should I start?
Yes, sir. Yes, sir. Yes, sir. You can start.
Okay.
Sir. Okay.
So, The title of my today's presentation is Study of Biochemistry and Metabolite Signature of Plants and Produce Using NMR. Some part of this presentation might be familiar to overlapping audience we had in a nearby college, I think couple of months ago. Dr. Verma was there. I think I know Dr. Beg for last 20 years. We studied in same college in our hometown, and then I think he was also there in the university. So it's a home crowd. I hope I might be able to do some justice with my presentation here. Even to the people who have attended it a couple of months ago, I have added some extra detail here and some new finding also. So the title of my today's presentation is Study of Biochemistry and Metabolite Signature of Plants and Produce Using NMR. Just let me know if audio or video cuts due to some signal issue at my end. I have some kind of backup. So to give you some perspective, it's a study of plant extracts we have done over last around 8 to 10 years. We had our first publication in 2013, and on top, if you see, where I'm rolling my cursor is a typical NMR spectra of a plant extract. We will see more of it. And using studying different plants of same environment in different season, we have said that some plants, our set of plant has this kind of biological pathways, and this is a typical appearance of an NMR spectrometer. Geol and Bruker are two companies. I have taken a picture from Geol website. Now, okay, so the content. You can go through the content, and of course, we will go through the same in the following slide. We will talk a little bit about metabolomics and NMR spectroscopy, and then we will look into the plants which we study. These are called marine algae. We are a Central Salt and Marine Chemicals Research Institute, so we take plant also as some source of chemicals, and then we will discuss about some NMR study of algae. Where we will see examples from different species, and then how do the species look in different season. And then we will see how this NMR study has been useful to identify life cycle stages. And then we'll see how one can go about understanding the biological pathway. And there are some tools which are available on the internet. And of course, I will tell you about those sources. There are nice summaries in the reviews. And then this new fifth and sixth is additional information from my last presentation. I will talk about how we have used it to identify plant from NMR spectra. And the last application we will discuss is how we can identify or do a quality control of plant produce. You are familiar about these plant produce using different name, but I think that will be a good ending point. So to start with, let's start with NMR spectroscopy. And this is a typical chemical shift appearing on the top right side of the slide. Most of the chemists, the chemists present in the audience, we recognize it, that TMS appears in the far right side of the spectrum. We use it as an internal reference, and aldehydes appear in the far left of the spectrum, and that's how we identify aldehyde. The point is, functional groups have unique position in this in the NMR spectra. That's why we call that y-axis as chemical shift. The position tells you about the functional group, but it also means that functional group dictate the chemistry, and that is the part which has been of interest to people who study plants. So they say that from 0 to around 3 ppm, characteristic peaks of amino acid appear. So they call this amino acid region. The far left side, from around 6 to 9 aromatic peaks appear. So they call it aromatic region. And in between region, the mostly characteristic peaks of sugar appear. So they call it their own chemical shift axis. The other thing one has to know is that NMR spectra is quantitative. Even if you have multiple molecules, the ratio between peaks is scaled by the concentration and the number of hydrogen. And this is of important interest used for study of prompt that my internet speed is not good. Okay, so just tell me if you are not able to hear, if it is too bad. So the important thing to know is that the other way to study plant extract consist of chromatography methods, LCMS, liquid chromatography, and gas chromatography coupled with mass spectroscopy. But these methods are based on molecular property of absorption, fluorescence, in some case reflection also. And these molecular properties mean that the sensitivity is different for different molecules. While in NMR, we detect the nucleus signature or frequency arising from nuclear gyro motion. So sensitivity remains the same for all molecules, all class of molecule, all type of molecule, because we are directly looking at the nucleus, and chemistry happens in the outer shell. So only the position get affected, but sensitivity remains the same. So let's go to the next slide. The other important thing which I feel important, and it will form the basis of our studies, is that we basically look at the chemical basis of life when we record the NMR spectra of plant extracts. Because we know the basic fact that for plants, their respiration produces sugar by converting their respiration produces sugar by utilizing CO2, water, and sunlight. And for them, the metabolism involves production of sugar as well as utilization of sugar, because sugar acts as raw material. As you can see, glucose becomes the raw material. From here, they are able to produce few amino acids. And sometimes, some of these what is called nucleic acids also. I think somewhere I have come across some nucleic acid also. So these sugar and amino acids are used for synthesis of cell walls in other organs. So in a way, these small molecules govern life processes. And because we get a quantitative spectra, it's a quantitative snapshot of biochemistry. So now we look into the context of our plants, from where I started my study. So CSMCRI was working on sea plants for a lot of time, and they have made a lot of efforts on classification and other things. So you can see that some algae, they are classified on the basis of morphological properties like color and shape. So one classification is presented here. You can see that all these algae appear green, but they have very different anatomical features. And in the same way, the same thing can be observed among brown algae and red algae. So either way, you are going to mess up somehow. So they started with color. So once you collect a green algae, then you bother, okay, which one you are supposed to, among which species you have to do a cross check. We will come to this part again. Now, as you can see, a lot of algae are produced all over the world, and it's a kind of what is called trade survey. A total of 32 million wet tons of produced, having a value of $12 to $15 billion, and it can go up to 26 billion US dollar by 2025. CSMCRI also published a patent on production of cost-effective agarose from Gracilaria dura, which is shown over here. Now, what we tried, we started studying different marine algae species way back in 2013. And you can see that, a species of Alveolectuca and Gracilaria dura and Sargassum terrarium, gives you different spectra. Somehow these have affected. And additionally, we can identify metabolites by using two-dimensional spectroscopy. So two-dimensional spectroscopy, generally we use what is called 1H spectroscopy of COSY, where you will get a cross peaks having a different value of X. मैडम सविता मैडम आप थोड़ा हेलो सविता मैडम ओके सॉरी हाँ so we use 2D spectroscopy of COSY where we get cross peaks having different value of protons in X and Y axis, saying that these two protons of these two different chemical shift has a chemical bond between them. That's the only way these COSY peaks can appear. So that way we can map the whole molecule by going into from one correlation to other correlation. So different algae gives different spectra, and you can also see that the same algae gives different spectra in different season also. So on the right hand side, you see a Gracilaria dura spectra. Top one was recorded in, I think, month of April, and the bottom one was recorded in the month of December. The same is the story on Alba lactuca, which you can see on your left side. Now, the other interesting thing about algal species is, they follow what is called life cycle stages. I mean, in the sense we know that papaya plant has male and female plants, and then only one type of plant will give you fruit, the other plant will not give fruit. The same is happens with marine algae. It's a bit complex, but they have life cycle stages. So after a certain age of stage of their growth, some plant become male, some plant become female, and then some group become a tetraspore from where their life progresses. So as you can see that we could identify these different life cycle stages using NMR spectroscopy. The characteristics peaks are, you can see that alanine is very low for female species. In the same way, certain peaks around 3 appears only in tetraspore and male. So the identification of life cycle stages was also possible using NMR spectroscopy. So if you look into various metabolites and their variation with different season, you can go into various databases. There are databases of metabolite profile. Metabolite pathway databases are also there. If you want to do a disease and physiology study, those databases are also present. I have given the reference over here. It's a good review. I can send somebody a copy. So looking into all the metabolites and their distribution over different seasons, we have proposed this pathway in 2013, which was a good experience. We also said that it's possible to do a taxonomy of marine plants. It was in the supplementary information, and we started work on that last year ago, a year ago. So how did we do it? We have, as you can see, why we need to do it. As you can see, among brown algae studies, as we have seen that we have a CSM Chari has a patent on Gracilaria dura. So you can see that if you take a small plant or if light conditions are poor, you can easily misidentify it. And then if you want to do a quality control, say that okay, your produce is good, the final product is good, and then for that your source also has to be good. So we have said that we will record a lot of spectra of Gracilaria dura from the favorable season, and then we will convert spectra into number by what is called a bucket integration, which is basically that you integrate small regions throughout the spectra. So as you can say, you can see between 7.1 to 7.3, I'm getting a value of 7.7, what is called a milli integral value, small integral value. It's like centimeter, millimeter kind of thing. And between 6.9 to 7.1, I'm getting an integration value of 2.93. Between 6.7 to 6.9, I'm getting an integration value of 6.37, and so on and so forth. So the whole spectra is broken into such small regions, and then you can arrange all of them in a stack-wise manner, and we tried to determine average and standard deviation of the whole set of numbers. And then we have made a proposed a model spectra. Okay, that if your spectra, I mean, you take a plant and you record the spectra, if it is between that average and standard deviation, you can say that this is Gracilaria dura. This was recently submitted to one of the journal. And now let's come to more interesting part. You know, everybody is affected by it, and so let us see how it has been used for various characteristics. So as you see on your left hand side, you will see a spectra of two tomato samples and tomato samples in black and gray region, and top and bottom are different region. So the number of samples, and they said that the saccharose is the marker for taste. And in the same way, around a few years ago, authors studied a fair number of instant coffee samples, and they said that this 5-hydroxymethyl 2-furfuryaldehyde is the marker for taste. If it's there, you will get a good taste. If it's in lesser quantity, you may not get a good taste. So as you can see, if you take tomato sample or coffee sample, you have a difference of few peaks here and there. Otherwise, the spectra remains the same. So we decided to use this feature for our interest, and this is our study. We were looking into what is you can call Ayurveda medicines. I call them herbal preparations. That's how scientific community knows it. So what we said that if you have a fixed composition herbal preparation, we know that the composition of Triphala. So you get one spectra for each composition. So we are saying that you can get unique NMR spectra for unique composition. We have made additional studies like the one we have discussed here. We have calculated average and standard deviation of few samples of same composition, and we have proposed a model spectra. And it is going to journal, and it's coming with interesting opinion. If some of you can suggest a good journal, I will submit it there also. And I think I am done with my presentation. If somebody has a question, I would like to answer it. Thanks everyone for attending it.
Thank you so much, sir.
Hello.
Yes, please.
Yes.
How you prepared samples for NMR of these? For example, amla.
No, we have not prepared sample of amla. We have taken commercial Triphala samples available from the local drugstores.
Okay, yes.
So we take the Triphala sample, we heat in water for some time, and then we filter it.
Yeah.
That's
Then,
all.
and solvent?
Water.
Water solvent. Yeah. So NMR of water will not interfere with.
Oh no, those details I have omitted. One can do a lot of spectroscopy allows suppression of water signals. So there are methods available. I mean, we
Yeah.
can do it if you are sending sample to CSMCR, right?
Yeah. You have done yourself these NMR.
Yes.
Yeah.
See, these are friendly samples. The algal samples I was talking you about, those are more difficult samples.
Yeah.
These are quite easy.
Easy samples.
These are easy samples. The algal samples were more difficult. They were viscous, and you know, it was very hard to work with.
Yeah. So how you distinguish between OH peak and that COOH peak?
Oh, you don't have to distinguish.
Yeah.
See, OH peak, peak.
You only compare NMR spectra with standard spectra, correct? To identify
Let me say something, madam. For example, just to give you an example, suppose I want to go after alanine.
Yeah.
Alanine has a peak of CH3 and then CH, and I don't look into this NH2 and COOH peak. They don't appear, and I don't have to bother about it. What we do is we look into CH3 and CH peak and get their correlation using 1H peak, and even we can get 13C correlation.
Yeah. Very
and
good.
Even we can get we get 13C peaks for COH also by something called multi-bond correlation spectroscopy.
Multi-bond. Correct. Very good.
So those methods are standard. You know, we can run it in 5 minutes. I mean, we can set it up in 5 minutes, and the spectra will come in, you know, half hour to 10 hours, depending upon the concentration. But it's pretty standard.
Yeah. Sir, you are working at Bhavnagar? Yes,
ma'am.
So there will be a sophisticated laboratory with this NMR spectrophotometer, etc.
Yes, ma'am.
Yeah. So that advantage you are taking out. Yeah.
No.
Very good. बहुत अच्छा है sir. बहुत बढ़िया है. It is very fine.
No, I am trying to do something useful with this facility.
Yeah, sir. This is very useful for finding out our daily use material, that is food like amla.
Actually, you know, it's actually a proposal stage, but it's also possible that you can fix dose of Ayurvedic samples.
Yeah,
I can
this
say
is useful for medicine also. Yani, even in allopathy, they can take the extract of these materials and for preparation of allopathic medicines also.
No,
Because
what I can say that what I will be able to. No, what I mean to say is I can say that 100 mg of one manufacturer is equal to 100 or 110 or 120 mg from another manufacturer using my NMR data.
Yeah.
So that way, the active constituent, the useful constituent, I will not use the active constituent. It's a bad word in here, mixture system.
Yes.
But it's possible to fix doses also.
Very good. Both are. So, sir, congratulations for doing this successfully, because it is very difficult to take out NMR spectra of a compound. NMR.
Thank you, ma'am.
You can use C12 also, C14 also, carbon spectroscopy. Yeah. Because these contain carbon also. Okay, sir. Thank you, sir.
Next participant, please ask your question to Dr. Rajan Singh, sir. Sir, in my opinion, it's a kind of very rare work you have presented to us actually, because marine algae, your presentation was totally based on marine algae, since we don't have sea around us in Middle India. We are living in Middle India. So if a fellow
आप लोग वो सिंघाड़ा और वो जलकुंभी और वो उसका अगर आपको करना तो आप कर सकते स्टडी, राइट? आपके यहाँ भी तो प्लांट्स है, वाटर प्लांट्स, राइट?
यस सर, डेफिनेटली सर, बिल्कुल सर। आपके इस लेक्चर से सर हमारे बच्चे भी बेनिफिट, उनको भी बेनिफिट होगा और हमको भी बेनिफिट होगा सर, डेफिनेटली। ये एक आपने जो है डायरेक्शन हमको दिया सर, बिल्कुल। और कोई जो है अगर कोई प्रश्न पूछना चाहे सर से तो डायरेक्ट डॉक्टर सिंह सर से डायरेक्ट आप क्वेश्चन पूछ सकते हैं। अभी सीनियर साइंटिस्ट है भावनगर गुजरात इंडिया में। ये बिल्कुल आपने रेयर चीज हम लोगों को सब आपने शेयर किया, बहुत ही शानदार था ये।
बहुत बढ़िया, यूनिक।
यस मैम। सो ठीक है सर, फिर वंस अगेन सर, थैंक यू सो मच फॉर योर कोऑपरेशन। आपको जब भी हम याद करते हैं आप हमेशा खड़े रहते हैं हम लोगों को हेल्प करने के लिए। एंड रियली इट्स अ प्रिविलेज टू अस दैट यू आर हैविंग, वी आर हैविंग यू हियर। थैंक यू सो मच सर, थैंक यू सो मच।
थैंक यू वर्मा जी।
गोकुल
आप
सर माइक और, यस सर प्लीज।
नहीं, कुछ नहीं, आप मुझे लगा आप
ओके
जा
सर,
सकते हैं।
सर गोकुल सर माइक ओवर टू यू।
All the participants, I hear me. We will meet again after 30 minutes for a oral presentation. And we have last technical session. Sorry, we have a last session, our valedictory session. So our almost above the 30 participants present the oral presentation. So all the participants will prepare. After 30 minutes, we will meet again. Thank you very much.
Shall we leave the meeting, sir?
Exact time.
Hello. 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 Okay, good afternoon, everyone. Am I audible?
Yes, sir. Yes, sir.
Okay, so here we are in the last technical session of this two-day event, Novel Trends in Chemical Sciences 2021. Yesterday we have two technical sessions and one session for oral presentation by the presenters. Now today in the morning session, we have one keynote lecture by Professor S.P. Rath. And after that, two invited talks, one by Mr. Chitranjan Das and another by Dr. Thakur. In this session, we are going to have total 29 presentations from participants from different states of India. During this session, Dr. Ashish Asatkar from Government PG College, Kondagaon, will judge the presentations by the presenters. I formally welcome Dr. Asatkar this technical session.
Thank you very much, sir.
Good evening, sir.
Thank you, sir. Good evening.
Okay, so before starting this session, I must introduce Dr. Asatkar to all of you. Dr. Ashish Kumar Asatkar is presently posted as Assistant Professor at Government Gundadur PG College, Kondagaon, Chhattisgarh since 2017. Dr. Asatkar has completed his master's in 2007 with gold medal, and he has done his PhD from Swami Vivekanand Technical University, Bhilai, Chhattisgarh in 2011. After that, he worked as postdoc researcher from 2011 to 2013 at Indian Institute of Science, Education and Research, Kolkata, West Bengal. He was awarded as Young Scientist during his PhD studies. Till now, Dr. Asatkar has published 15 research papers in various journals of repute. He also has 2 book chapters in his credit. Before joining as assistant professor in Chhattisgarh, he served as scientific officer in Forensic Science Service, Madhya Pradesh. I am glad to have such an dynamic and energetic researcher among us to judge the presentations of different presenters. So I would like to formally ask Dr. Asatkar to grant his permission to call the presenters.
Thank you very much, sir, for the kind words.
Most
And I'm really happy with this event. You are really organizing a great event, and very reputed speakers from various reputed organizations across the India you have. So I really wish you very grand success for this event. And without wasting much time on the formalities, I would like to start this session. As we have already plenty of candidates for presentation. I think 29 candidates are there.
Yeah,
so
sir.
We can start, sir. Yes, sir. So we can start, sir. Sure.
Okay, sir. So before calling first presenter, I would like to share some instructions regarding the presentation. First, every participant will get maximum six minutes for presentation and 2 minutes for questionnaire. So you have to keep the time limit in your mind. Number 2, we have total 29 presenters, but our yesterday's experience is not good regarding the response of presenters. Yesterday we have 11 presenters to present their research work, but only 7 were present to deliver their lecture. So I would like to ask everyone to be ready every moment for the presentation. So first one is N. Jayashree.
Yes, sir.
Okay, you can start your presentation now.
Sir, I'm not able to share my screen, sir.
मैं शेयर कर रहा हूँ ना.
Yes, sir.
तो बोल
Thank you,
दीजिए
sir.
सर. मैं शेयर कर रहा हूँ. ओके जस्ट अ मोमेंट.
Okay.
Just a moment.
Yes, sir.
Is it visible?
Yes,
Yes,
sir.
yes,
Visible,
sir.
sir. Thank you, sir. Sir, you start. Good afternoon to all of you. Yes, sir.
Just a moment.
Yes, sir.
You can start.
Thank you, sir. Good afternoon to all of you. I extend my sincere gratitude to organized team of Government Digvijay College, Rajnandgaon, to give me an opportunity to present my work at national level conference. Today's my topic is influence of complexing agent on structural and optical properties of tin sulfide thin films deposited by chemical bath deposition method. Sir, next slide. These are the contents. Next slide. This is the introduction. First of all, I introduce some points to related my topic. First is the thin film. A thin film is a layer of material ranging from fraction of nanometer to several micrometers in thickness. Second is the CBD process, chemical bath deposition process. This is the method to deposit thin films and nanomaterials. It can be employed for large area bath processing and continuous deposition. CBD process deposition conditions such as concentration of precursor, deposition temperature, complexing agent, deposition time, pH of solution have a significant impact on the phase formation and layer properties that affect the performance of final photovoltaic system. So we in this, so many complexing parameters. I select the complexing agent is to study our topic. Second thing is our select is the tin sulfide as a formation of thin film. At the present time, it is a completely necessary to develop a low-cost solar energy absorbing material using a non-toxic elements to achieve the purpose of economically valuable and environmentally beneficial solar cell formation. Some properties of tin sulfide is related. It is a 3 types of structure: cubic, orthorhombic, zinc blend for use as a solar cell. And second thing, it is a p-type semiconductor height light absorbing coefficient. It is a potential candidate particularly in photovoltaic device, photo detectors and optoelectronic devices, etc. Thank you, sir. Next slide. So next, it is the method, the chemical bath deposition method. In this method, we use tin source for the tin sulfide thin film as a SnCl2, and solution is used water plus acetone. Second is then we add the complexing agent, 2 type of complexing agent. First is the EDTA, ethylene diamine tetraacetic acid, and second is the triethanol amine. Then we use all the chemicals are combined with magnetic stirrer. Then we put the all mix. After mixing, we put the beakers in water bath at 60-degree temperature and 9.5 pH meter. Yes, sir. Next slide. Yes, this is the results. Our thin films, we use the 4 type of characterization: XRD, EDX, UV, and SAM. First is the XRD. EDX is confirmed the formation of SNS. 1:1 ratio is obtained. It's confirmed the S2 is not formed. It is formed the SNS. So next slide. These are the SAM result, scanning electron microscopy result. It clearly shows the 2 types of structures related my work. First is needle shape, and second, and below that is the white and flower-like structures is obtained. Yes, sir. Next. These are the XRD result and clearly shows the EDX. That was second graph shows the EDX related, EDTA related XRD graph is clearly shows the more crystallinity graph is obtained with using EDTA as a complexing agent. And XRD is the useful for the structure, phase purity, and microstructural parameters like peak position, full width at half maxima, interplanar distance, crystalline size, micro strain and dislocation density, etc. We use the grain size determination, Debye-Serres formula, and we use a micro strain determination, Williamson and Smolson's equation. Thank you, sir. Next slide. These are four slides are present in. First is the absorbance versus wavelength, and the higher absorption is in the visible region is favorable for the enhanced presentation of photovoltaic effect. So next, this is the transmittance versus wavelength. It is obtained by Beer-Lambert law. So next, it is reflectance versus wavelength. Reflectance is also the very useful property for solar thin film. So next, last slide is the calculated the Kubelka-Munk function for the determination of band gap. Band gap is the low value is favorable for optical device. Here we 2 types of band gaps is present. First is the EDTA is equal to 1.31, and second is the triethanol amine band gap 1.41. So band gap is large for triethanol amine. It is obtained by Kubelka-Munk function. Thank you, sir. Reference.
Okay, thank you, Anjan Jayashree.
Yes, sir.
So, Asatkar, sir.
Yes, sir. So, Jayashree, your presentation was really good, and your topic is also very good.
Thank
I
you,
have
sir.
just one question first. The tin sulfide you have prepared, what
Yes,
are
sir.
the benefits of this tin sulfide over conventional semiconducting materials?
Sir, it's non-toxic, sir. First of all is 2 elements are non-toxic and available in low cost है sir. इसका cost भी कम पड़ता है. tin sulfide का,
But
tin का भी और
जिंक सल्फाइड से कम नहीं होगा आई थिंक. tin तो रिलेटिवली लोअर कॉन्सेंट्रेशन पाया जाता है लोअर एक्सटेंट में. और
Yes,
जिंक
sir.
भी टॉक्सिक नहीं है. Zinc sulfide is also not having any toxic effect.
सब नेक्स्ट इसका बैंड गैप वैल्यू भी काफी कम आ रही है सर, 1.3 से लेकर 1.4 के बीच आ रही है.
Okay. One more thing, your particle size is 1 micrometer.
No sir, it's nanometer.
So I was observing in your slide, yeah, this one also. It is something around 1 micrometer. I can see here.
Yes sir, but XRD results device carriers formula से 60 nanometer to 40 nanometers calculate की हूँ सर मैं.
60 to 40 nanometers.
Yes sir.
But SAM is saying something different story. As per the SAM, it should be something around 800 nanometers, I think. It is just something around 1 micrometer. So why you are giving more importance to the XRD result over the same image?
Yes sir, XRD कैलकुलेशन तो इजी पड़ रहा था सर, और सैम का कैलकुलेशन हो नहीं रहा था. मतलब मैंने ट्राई किया था सर कि मतलब उसका भी ग्रेन साइज निकाल सकूं सैम ग्राफ से भी,
बट यहाँ से तो बहुत क्लियर है, बहुत क्लियर है. ये लगभग 800 नैनोमीटर के आसपास दिखाई दे रहे हैं. बहुत ही क्लियर है ये.
यस सर. सर मैं ट्राई करूंगी सर नेक्स्ट टाइम सैम एनालिसिस.
ये जो डिफरेंस मिल रहा है इसको क्लियर करिए कि डिफरेंस क्यों आ रहा है. कहीं कैलकुलेशन में मिस्टेक तो नहीं है? अदरवाइज इतना डिफरेंस नहीं आना चाहिए. और आपके पार्टिकल साइज अच्छे, मतलब मोनोडिस्पर्स्ड है आपका जो नैनो पार्टिकल्स बन रहे हैं. हालांकि सेम को देखकर इसको नैनो नहीं बोल सकते, बट एनीवे आपका जो पार्टिकल है यहाँ मोनोडिस्पर्स दिख रहे हैं काफ़ी अच्छे. बट साइज को लेकर आपके इसमें डिफरेंसेस आ रहे हैं. XRD से आप कुछ और कैलकुलेट कर रहे हैं, तो इसको चेक करिए, क्योंकि एक जैसे आना चाहिए. थोड़ा बहुत डिफरेंस आता है, ऑब्वियसली डिफरेंस आएगा, बट इतना डिफरेंस नहीं आना चाहिए. 60 नैनोमीटर और ये मोर देन 600 नैनोमीटर है. ऑलमोस्ट 10 टाइम्स का डिफरेंस है.
यस सर. ओके सर, आई विल चेक.
ओके देन फाइन. ऑल द
बेस्ट. थैंक यू सर. थैंक यू सर. थैंक यू.
Thank you, sir. Let me ask next participant, Prabha Raj. Prabha Raj, are you there? Next participant is Prabha Raj. No. Next one is Prashant R. Mahale. Third participant is Prashant R. Mahale. Are you there to present your work? Next is Sheikh Abdul Rahim. Sheikh Abdul Rahim, are you there to present your work? No. Next one is Ritu Gupta.
Yes, sir.
Okay. Are you ready to present?
Yes, sir, I am ready. Please allow to me share my screen.
Okay. I think you have permission to share your screen.
Okay, sir.
Okay, start your presentation now.
Okay, sir. It is visible. Screen is visible, sir.
Yeah, yes, it is visible.
Yes. Myself, Ritu Gupta. I am research scholar from Department of Chemistry, Dr. C.V. Raman University. My topic is harmful effects of food preservative. Introductions there. Preservative is a substance or a chemical that is added to products such as food, beverages, pharmaceutical drugs, paints, biological sample, and many other things. But here we will discuss about food preservative. Food preservative improves appearance of food as well as shelf life of food. Actually, there is a classification of food preservative. These are natural food preservative, for example, salt, sugar, rosemary extract, etc. Second one is artificial food preservative that contains antimicrobial agent, antioxidants, and chelating agent. And chemical food preservative. Here we will discuss about chemical food preservative that are benzoates, nitrites, nitrates, sulfites, potassium sorbate, and sodium sorbates. Chemical food preservatives are widely used in the food industries and are invariably cheap ingredient that are effective against a wide range of spoilage organism. Actually, chemical food preservative जो है वो माइक्रो ऑर्गेनिज्म को क्या करता है, डिस्ट्रॉय कर देता है. And chemical food preservative includes sodium benzoate, benzoic acid, nitrite, sulfite, sodium sorbate, and potassium sorbate. Methodology: there are different methods which we will use to analyze different preservative. For example, benzoic acid and sorbic acid, which for which we will use overlapped HPLC, high performance liquid chromatography. For sodium benzoate and potassium benzoate, also HPLC. For benzoic acid, UV spectroscopy. For sorbic acid, UV spectroscopy. For methyl paraben and propyl paraben, HPLC we will use. There are some preservatives, types of preservatives, and maximum permissible limit. Benzoate and sorbate is antimicrobial types of preservative, which is maximum permissible limit of this is 200 ppm. ppm means parts per million. Propionates, it is 0.32%. Sulfites and sulfur dioxide 200 to 300 ppm, and nitrites and nitrates it is 100 to 120 ppm. This is maximum permissible limit. It means कि इससे अगर ज्यादा हमारे बॉडी में जाता है तो this is harmful for you, for us. Okay, and harmful effect of food preservative is there, that is sulfites and nitrites. These are harmful for us. There are certain harmful effects of using chemicals for preservation, such as sulfites are common preservative used in various fruits, may have side effect in form of headache, allergy, and even cancer. Nitrates and nitrites, these additives are used as curing agent in meat products, and it get converted into nitrous acid and when consumed and is suspected of causing stomach cancer. There are some harmful effects of benzoates and sorbates also. Benzoates are used in food as antimicrobial preservative and have been suspected to cause allergy, asthma, and skin rashes. As well as sorbates and sorbic acid are added to food as antimicrobial preservative, and reaction to sorbates are rare but have include reports of urticaria and contact dermatitis. These are skin disease. Now, advantage and disadvantage of food preservative. Food preservatives are good. Its advantage also, but disadvantage also. Advantage of food preservatives are this make food stays fresh longer, look nicer, and taste better, as well as make food last longer. But disadvantage also there, that is associated with serious disease like cancer and asthma and toxic effect also. So conclusion is there that if we must use food preservatives because of their advantages, these should be natural ones which have minimal effect and those that are generally recognized as safe, GRAS, permissible. And in the case those not generally recognized is safe, the acceptable daily intake should not be exceed, and it is best to eat a preservative-free diet if at all possible. These are references, and thank you, sir.
Okay, thank you, ma'am. Asatkar sir, please.
Thank you, madam. Your topic was really very interesting, but I could not see any data in your topic. Actually, if you are saying about toxic effect of preservative, then you should mention certain products and your observation, what limit you have found that
Yes, sir.
preservative. But there is no data actually in your slides. Just theoretical concepts is there.
Yes,
So
sir.
have you worked on certain preservatives, and did you find any preservative beyond the permission limit?
Yes, sir. Benzoic acid and sorbic acid.
In which food product you observed that?
Sir, in sauces, benzoic acid as well as
So that
in
was under permission limit or beyond that?
permission limit.
That was under permission limit. Okay. So
Yes.
then, if you are getting things under permission limit, then what is your plan to identify if everything is perfect?
Permission limit, only one or two products is beyond permission limit,
Okay.
and not very exceed permission.
Okay.
That is not, harmful for us.
Okay. One ethical question: if you found something, this preservative beyond the permission limit, then can
Yes.
you report that directly? Because those products are also those products are also analyzed in their R&D lab, and after that they publish. So what is the procedure if you found something beyond the limit, if they are above the permission limit, and you have to report those data? In that case, what is their provision?
Yes, sir. But in brands products, permissible limit is not exceed actually. But if it is a local product, then it may be exceed.
Okay. But I think you should represent certain products and your report what you observed in those products.
Yes.
So that would make more effective to your work.
Yes, sir. I have data also for benzoic acid and sorbic acid, sir.
Okay, okay. So next time, better to include those data in your presentation. Otherwise, it would look like just theoretical concept.
Yes, sir.
Thank you.
Thank you.
Okay, thank you, ma'am. Thank you, sir.
Other persons can also ask the question if they are interested.
Yeah. If any participant want to ask any question, Ritu ma'am, please stop sharing your screen.
Yes, yes, sir. Yes.
Okay.
Dr. D.K. Verma is also there.
Yeah. Yes, sir. Verma
Sir,
sir,
yes, sir, I am here, sir.
So, would you like to ask some question?
I have a single question, just a single question.
Yes, sir.
रितु मैडम, ये बताइए कि कौन सा जो है प्रिजर्वेटिव है जो गैसियस फॉर्म में यूज होता है?
Yes, sir.
Which preservative has been used in the gaseous form?
Sir, benzoic acid also used in gaseous form.
Are you sure?
Yes, sir.
Okay. Okay. Sir, next.
Okay. Thank you, Verma sir. So our next presenter is Lakshmikant D. Chauhan.
Yes, sir. Do you hear my voice?
Yeah.
Yeah.
It is
Okay.
audible. You
Okay. Can I share my screen now?
Yeah.
Whether my presentation is visible to all of you?
Now it is visible.
Yes.
Okay, thank you very much. Good afternoon, everyone. I am Dr. Lakshmikant Dhaneshwar Chauhan, working as an assistant professor in the Jawaharlal Nehru Engineering College, Aurangabad. And my topic of presentation is an efficient synthesis of 2H-indazole thalazine trione catalyzed by 11 molybdenum 1 vanadidophosphoric acid under solvent-free conditions. Aim and objectives of this work is to develop the eco-friendly, efficient, and economical method for the synthesis of biologically active compounds, and to characterize the synthesized catalyst by using the FTR, TGDTA, XRD techniques, and to study the applications of synthesized catalyst in the synthesis of 2H-indazole thalazine triones. So before starting the actual work done, I will shortly introduce what are the polyoxometallics. Polyoxometallics are the large class of nano-sized metal oxygen cluster anions, and generally it is obtained by self-assembly process in acidic aqueous solution. The general formula of that polyoxometallic is the XM. Here you can see this general formula, in which the X is the heteroatom. Commonly used heteroatoms are the phosphorus, silicon, germanium, and arsenic. M is the ident-diatom. Commonly used ident-diatoms are the molybdenum, tungsten, and palladium. And the Q is the charge, which varies in between -3 to -28%. So there are two types of the polyoxometallics. Depends upon the whether the ident-diatom heteroatom is present in their structure or not. Isopolyanions, they does not contain the heteroatom in their structure, and heteropolyanions, they contain the heteroatom in their structure. So the heteropolyacids are again classified into the various categories depending upon the number of ident-diatoms present in their structure. If the 12 ident-diatoms are present, then it is called as the Kagan type of the heteropolyacid. Dawson type contains the 18 ident-diatoms, Anderson contains the 6, and Silverton contains the 12 ident-diatoms. Out of these 4, the Kagan types of the heteropolyacids are most studied, and they are more widely applied in the catalytical application or for the synthesis of different kind of the products, because of their thermostability and because of their structure can be easily altered. The unique features of heteropolyacid includes they are strong Bronsted acids. They contain the great number of water molecules. They can work as a homogeneous as well as heterogeneous catalyst. Their structure can be easily altered. Chemical composition is also altered. They also work as an efficient oxidant. They are insoluble in the non-polar solvent, and they are environmentally benign. So these are some of the unique features. Now, in our work, we have prepared the mixed heteropolyacid, particularly vanadium ion is introduced in between the molybdophosphoric acid. For that purpose, the method which is used is mentioned over in this slide. So first of all, the sodium metavanadate, 6.1 gram of the sodium metavanadate is dissolved in the 100 ml of boiling water, and simultaneously in another beaker, the disodium hydrogen phosphate 7.1 gram is dissolved in the 100 ml of water. Both this mixture is mixed together with continuous stirring, and after complete mixing, the concentrated sulfuric acid, 5 ml of concentrated sulfuric acid is added dropwise. Then solution develop a red color. In that red color solution, the 200 ml solution consisting the disodium molybdate is added dropwise, and in parallel the concentrated sulfuric acid is also added 85 ml. Then solution is allowed to cool at the room temperature, and then that Elion molybdo 1 vanadium acid is extracted from that using a diethyl ether. So in this way we have prepared that catalyst. And for the characterization of that catalyst, we have used the FTR technique, TGDTA technique, and XRD technique. So from the FTR, the Kagan structure is confirmed. The TGDTA is commonly used for studying the thermostability of that particular catalyst, and XRD is also used to identify the Kagan structure. Okay, so in the FTR, so this is the FTR spectrum of that synthesized catalyst. Here you can see that 4 characteristic peaks were at the 780 centimeter inverse, 870, 964, and 1065. So the characteristic peaks of the Kagan structure is already mentioned in the literature. For example, PO stretching is in between 1060 to 1080. M double bond stretching is in between 960 to 990. Inter-octahedral MOM stretching is in between to 870 to 900, and intra-octahedral is in between 760 to 810. So the characteristic, the peaks of the synthesized catalyst is exactly in that region. That's why we have identified that the synthesized catalyst has the Kagan structure. And one more research publication is already published, and here in that paper, the characteristic peaks of the Elion molybdo 1 vanadium acid is mentioned, and that peaks are exactly matched with the catalyst which we have prepared and characterized using the FTR. So from the FTR, we have identified that the synthesized catalyst is nothing but it is the Elion molybdo 1 vanadium acid, and it has a Kagan structure. Okay. So for studying the thermostability, we have done the TGA as well as the DTA. So in the TGA graph, you can see that the one mass loss is observed in between 30 degrees centigrade to 120 degrees centigrade, particularly 11.6%. This is due to the absorbed and free water. And after the 120 degrees centigrade, again mass loss is observed in between the 130 to 450 degrees centigrade. For the 2.7%, this is because of decomposition of Kagan structure and evolution of protonic water.
So answer?
Yes, sir.
You have last 30 minutes to conclude.
Okay.
Do it
Okay.
faster.
So in the DTA, you can see that two endothermic peaks are observed in between the 40 to 125 degrees centigrade, and exothermic peak is at the 434 degrees centigrade. So endothermic peaks which are observed over here is due to the removal of free and absorbed water, and exothermic peak is due to the decomposition of Kagan structure. So from the DTA, we have concluded that the synthesized catalyst is thermally stable up to the 434 degrees centigrade, means its thermal stability is very high. We have done the XRD also. The objective of performing the XRD analysis of synthesized catalyst is to again identify the Kagan structure. In the literature, the characteristic peaks of the Kagan structures are mentioned, which is in between 6 to 12 theta, 16 to 23, 25 to 30, and 34 to 40. And the peaks of the synthesized catalyst are exactly in that particular region. So we have again confirmed that the synthesized catalyst has the Kagan structure. Now the synthesized catalyst is used for the preparation.
Sir, time is over, sir.
Okay. Can I stop now?
Yes.
Okay.
You can
So
come
this
to
is the
conclusion.
procedure. This is the procedure for the preparation of indazolothalazine trions.
Sir, please come to the conclusion.
Okay. Okay. Conclusion: an efficient protocol has been developed for the synthesis of indazolothalazine trions using the 11 molybdenum 100 phosphoric acid. This reaction is carried out under the solvent-free conditions and it gives the excellent yield. This approach offers the advantage: simple methodology, clean and mild reaction condition, easy handling of the catalyst, short reaction time, and low environmental impact and high yield. And this method not only afford the product in excellent yield, but also avoid the problems associated with the catalyst cost and pollution. We are thankful to the principal of our college and also the HOD of the Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, for providing the necessary facility for that work. Thank you very much.
Thank you, sir. Ashatkar, sir, please.
So thank you, sir. It was really a very nice lecture. Actually, your work is really advanced work, very advanced work, and we have been learning and teaching this topic in the PG level. But first time I met something who is working research in this topic. So it's really good to see you are working in this topic. Sir, did you try this compound, your indazolo compound, for any biological activity?
No, sir. Just I have prepared the products. Now, in the next level, we are trying to identify their biological activities.
So, which type of biological activity you are expecting, sir?
Actually, at that moment, I have not planned that. Actually, our motto is to prepare the catalyst and to study their application. So that's why we have only prepared that product. But I am working on that. So at this stage, I don't know what exactly to do for the microbiological activities.
Okay. I think you did not have sufficient time to present all the things you wanted to show actually.
Yes, sir.
But it is really good topic, and all the best, sir, for your upcoming future. I think you will get something good biological activity if for particular any disease.
Okay, sir. Okay. Thank you very much.
Thank you, sir.
Okay, thank you, sir. Verma sir, would you
No, sir. Thank you.
to ask?
Thank you.
Thank you, sir. Thank you, Chauhan sir. Please.
Yes, sir.
Stop sharing your screen.
Okay. Thank you, sir.
Okay, so next presenter is Ahilya Panda. Are you there?
Yes, sir.
Okay. Ready to present?
Sir, just for a minute. I'm.
Are you ready to
allow
present?
me screen share.
Okay.
Yes, sir.
Yes, sir.
Everyone has permission to share their screen. Okay, you can start now, Ahilya Panda.
Yes, sir. Just 2 minutes, sir.
If you have any problem, I can call the next participant.
No, sir. I will start.
Your screen is not visible, Ahilya.
Only 1 minute.
If you have any problem in sharing your screen, you can share your PPT with us. Ahilya, are you there? Am I audible to you? She is not responding. So
I think we can call next participant, and she
okay,
will
sir.
be given time after 1 or 2 candidates if she is ready.
Okay, let me ask the next candidate. Aditya Narayan Tiwari. Are you there, Aditya?
Yes, sir.
Okay, sir. Okay,
Yes, sir.
Aditya, wait. I think Ahilya Panda is sharing her screen.
Okay, sir.
Yes, sir.
Do it fast, Ahilya.
Yes, sir. I will share.
Ahilya, please mail your PPT to us. Your screen is visible now, but your presentation is not visible. I think the file is not supported by the system. It's not opening.
Okay.
Okay. Now it is
Am I
visible.
audible, sir?
Yeah, you are audible and your screen is visible. Just a few moments before, but now it is not visible. Ahilya, please mail your file, PPT file to us. Do you have our email ID?
Yes, sir. Yes.
Okay, so please.
I will send this file.
Yeah. Okay, next one is
Ji.
Aditya Narayan Tiwari. Aditya, please share your screen and start your presentation.
Yes, sir.
Okay. Next participant is Monica Compose. Be ready for the presentation.
Okay. Good afternoon, everyone.
You can start your presentation.
Okay, sir. So good afternoon, everyone. My name is Aditya Narayan Tiwari. I am here to give oral presentation of synthesis of biotreated magnetic nanoparticle and its application. I am a PhD scholar under the supervision of Dr. Mrs. Kavita Tapadia, Associate Professor of Department of Chemistry of NIT Raipur. Outlines of the work. Introduction. As we know, nanoparticles are the particles between 1 to 100 nanometer in size that behaves as a whole unit with respect to its transporting properties. Nanoparticles have greater surface area per unit weight than larger particles, which make it more reactive. Nanoparticles are being used in many fields like medicine, manufacturing and materials, environment, energy and electronic, etc. This is the scale which represents the particles, the things in centimeter to nanometer range. One side they represent the man-made things, and another side represent the things that occurs in nature. Types of nanoparticles are broadly divided into two types, that is nanospheres and nanocapsule. Nanospheres are the matrix type structure in which a drug dispersed, and nanocapsule are membrane wall structure with a polymeric system contain drug. This is the image of nanosphere and nanocapsule. There are two different approaches to fabrication of nanomaterial. First one is top-down approach and another one is bottom-up approach. In top-down approach, we will start with the bulk material and cut away material to make the thing what we want. And in bottom-up approach, we synthesize the thing we want from the smallest thing like atoms and molecule. Objective of the research work, synthesize nanoparticles through green approach so that less chemical can be used. And next, characterization of the nanoparticle to get exact idea of their shape, size, and chemical composition so that perform a better approach toward its application, approaching towards a method that can be less time taking but more effective. Green synthesis of iron oxide nanoparticle using glow stem powder. What is glow? The scientific name of glow is Stenospora cordifolia. It belongs to many Spermaceae family. In Ayurveda, glow also used to cure many diseases. Glow is an antipyretic herb. It improves platelet count in dengue fever too. Synthesis in brief, I have synthesized the iron oxide nanoparticle by using glow stem extract and solution of iron salt. Synthesis of glow stem extract. Glow stem was thoroughly cut into pieces and dried with 10 grams of glow stem powder dissolved in 90 ml of methanol, stirred at 80 degrees Celsius and 400 rpm for 1 hour. Glow extract was prepared and it was kept into the fridge for the further use. Synthesis of nanoparticle using glow stem extract. There is ferric chloride and ferrous chloride was taken in 2:1 ratio in 10 ml of distilled water, stirred for 30 minutes to make homogeneous solution. Then next 5 ml of plant extract was added to drop-wise. Color changes from yellow to brown. Color changes indicated formation of glow shoot extract iron oxide nanoparticle. Solution is heated on oven at 80 degrees Celsius for overnight. Formation of iron oxide nanoparticles took place. This is the practical what I perform in the lab. First, I have taken glow plant extract, then added it into ferric chloride and ferrous chloride solution, and finally synthesis of iron oxide nanoparticles takes place. Color changes during the reaction. Starting, the color is yellow of the solution of ferric chloride, and after 1 hour, light brown color appear. After the addition of plant extract, and after 3 hours, brownish black color appear. This synthesized nanoparticle is magnetic in nature. In first image, what I want to show is the nanoparticle having bead, and at t is equal to t0 is equal to 0 minute, and after 1 minute, bead attracted all the magnetic nanoparticle towards itself. Characterization tool what I used for my nanoparticle. Characterization UV spectrum. Absorbance of iron oxide nanoparticle lies between 200 to 450 nanometer here. 272 nanometer peak represent that iron oxide nanoparticle confirms the synthesis of iron oxide nanoparticle. FTI of nanoparticle. This is the FTI image of the iron oxide nanoparticle. First one represent the OH stretching at 3443.99 centimeter inverse, and 1635 centimeter inverse represent NH bending, and at 578.56 represent FE stretching, which confirms the presence of FeO bond. XRD image. This XRD image clearly shows that the synthesized iron oxide nanoparticle is FCC in nature, and it is similar to JCPDCS file number 893854. This is the ADS image. ADS image confirms the element of present iron and oxygen in the synthesized nanoparticle. This is the same image. This is the HR10 image. So in this image, some of the glow shoot iron oxide nanoparticles are spherical with 10 nanometer size, and some are square in shape with 25 nanometer in size. This is the application of the synthesized nanoparticle. We can perform so many applications on iron oxide nanoparticle. I have selected antioxidant ability. Antioxidants are free radicals are unstable molecules that the body produces as a reaction to environment and other pressure.
Aditya,
Antioxidants
you
are
have 30
substances that can
seconds to
prevent or
conclude.
slow. Okay, sir. Conclusion: since nanoparticle is synthesized by greener approach, less chemicals are used and hence more beneficial. Since synthesized nanoparticles are magnetic in nature, so that they can be easily separated by applying external magnetic field. Separated nanoparticle can be further used, but after treating with suitable chemicals. Since I have chosen Gular shoot, which is easily available, and corn silk hair, which is a waste of corn. So using this made my synthesis more cost effective. Acknowledgement: I would like to express my sincere thanks to the organizers of NTCS 2021 for allowing me to participate in this national conference. Thank you.
Thank you, Aditya. Asatkar sir, please.
Thank you, sir.
Nanoparticles are magnetic in nature. The synthesized particles are magnetic in nature. How you justify that?
Sorry,
Why
ma'am.
the particles prepared are magnetic? Nanoparticles magnetic क्यों होते हैं? They can be separated by magnet. Sir, my voice is coming? No. No
Sorry, ma'am. Your
It's properly
voice
audible,
is
ma'am.
not clear.
Actually, madam is asking, जो आप नैनो पार्टिकल्स बना रहे हैं वो मैग्नेटिक क्यों हैं? The nanoparticles you are preparing is paramagnetic, magnetic. Is it true? What you are
Yes,
saying
sir.
in your lecture?
Magnetic in
So,
nature.
what is the reason
Yes, sir.
behind that, madam? I think
Yes,
the
sir.
same question is asked.
Yes, sir. Correct है sir. यही पूछना है.
Sorry, yes. I don't know the reason, ma'am, but it attracted towards the magnet, so it is magnetic in nature. I think.
There must be
No,
unpaired electron.
but yeah, that is your observation. You must have some reason behind that. Madam is trying to know the reason.
And explanation also.
Explanation behind that magnetic behavior.
And how you find that it is paramagnetic.
Ma'am, synthesized magnetite nanoparticle is spinal structure Fe3O4, where a weak field ligand oxygen is present, so that it cannot pair the electron of iron, and that is the reason why yes, ma'am, the unpaired electron present, which made this nanoparticle magnetic in nature.
Aditya, you are preparing iron oxide nanoparticles. My question
Yes,
is,
sir.
why is it difficult to prepare iron nanoparticles?
Sir, because I think it should provide proper nitrogen condition to prepare iron nanoparticle. If we cannot provide proper condition,
Okay, if you
then it
prepare the
convert into
iron
oxide
nanoparticles
form.
under inert atmosphere.
Iron nitride भी तो बन सकता है.
Yes.
And would that
yes, sir, in inert.
And would that iron nanoparticle be stable in open atmosphere?
If
you have, I think you had you
would
have seen the silver nanoparticles, gold
yes,
nanoparticles, but iron nanoparticles, I think you rarely
yes,
would have been seen. So why is it difficult to prepare iron nanoparticles? Rather, you are preparing iron oxide nanoparticles.
I think, sir, iron is more reactive, so that it can react to the atmospheric oxygen.
Okay, yeah, that's fine. That's fine. One more question I have. You have prepared iron oxide.
Yes,
so
sir.
which type of oxide you are preparing? FeO or Fe2O3 or something else?
Fe3O4.
Fe3O4, sir.
Fe3O4. But in
Fe3O4,
your IR
sir.
spec, but in your But in
Yes,
your
sir.
IR spectra, you are showing OH stretching frequency something around 3400 centimeter inverse. So,
Yes, sir.
so
Yes,
why
sir. Yes,
that peak
sir.
is appearing? Can you explain that?
Due to presence of
Moisture.
sir, due to presence of phytochemical, I have synthesized by Greener approach, and in phytochemicals, OH group is present, and
That so it is coming
this
from
shows
your
that the iron oxide
okay. So it is coming from your capping
plant
agent
parts,
actually.
sir, which I used as reducing and capping agent.
Okay.
Yes,
And
sir.
somewhere you have classified the nanoparticles as nanotubes, sorry, nano capsules and nanospheres only. So what about nanosheets and nanorods?
Yes, sir.
So
Yes,
that
sir.
classification is not
Should
appreciable actually.
classified into broad category. Yes, sir.
Yeah, yeah.
Yes, sir. Yes,
Anyway,
sir.
anyway, it's good.
Yes, sir.
Your work is really good, and yeah, that's fine. All the best.
Thank you, sir. Thank you, sir.
Okay. Thank you, Aditya Narayan Tiwari ji. Thank you so much, ma'am. Thank you,
Thank you, sir.
Asatkar sir. So our next presenter is Monica Kamboj. Monica, are you ready to present? Monica, are you there?
Next.
Okay. Next is Jayashree Khicharia. Jayashree Khicharia, can you hear my voice? Are you ready to present? No response. Next is Mr. Sandeep Kumar. Sandeep, would you like to present? No response. Next is Jyoti Rathod.
Yes, sir, I'm present.
Okay.
Okay. Should I share my screen?
Yeah, you can.
Good afternoon, one and all present here. Today my topic is comparative studies on antimicrobial activity on different aspects, leaf, bark, root, flower, and seed of moringa leaf. The introduction is there that the moringa leaf belonging to the family of Moringaceae is an effective remedy for malnutrition. Moringa is rich in nutrition owing to the presence of a variety of essential phytochemicals present in its leaf, pods, and seeds. So not just taking too much time, the review of it there. And in that one point is that it has been reported that different solvents have different extraction capabilities. He reported that to extract broad spectrum antimicrobial compounds from plants is confirmed by the ethanol solvent. The difference observed between antibacterial activities of the extract could be explained by the difference in the chemical composition of this extract. So as my topic is antibacterial about the moringa, I am saying, so the antibacterial activity of moringa seeds has been reported by many researchers. Our results were in agreed with the website who reported that moringa seed extract has the best antibacterial activity. The petroleum ether has no antibacterial activity against Staphylococcus aureus E. coli than C. aeruginosa, while seed water had antibacterial activity against Staphylococcus aureus. Chemical compounds that are also found to give antimicrobial effect include phenol, acid, phenolic, quinone, flavon, flavonoid, flavonoid, tannin, and phenol. So what I have done in this topic is that I have just compared with the help of a research paper what type of activity has been done for for identification of antibacterial activity. So one comparison chart I have made. So 5 types of solvent we have taken here. That is petroleum ether, methanol, then ethyl acetate, ethanol, and in the case of water, generally results are not shown. So from the graph, you can see that from blue color we are showing Bacillus spinalis, and then next one is your Bacillus subtilis, and next one is your Staphylococcus aureus. So then I have compared all this in the bark of Moringa oleifera. What result I have seen that the antibacterial activity is more seen in the case of mild association. Afterwards, then I have studied the papers about the flower that how much antibacterial activity has been found out there. So in that condition, Staphylococcus Escherichia coli have shown the nature, and but the solvent was ethyl alcohol and water. And then in the next piece in leaf also, so many papers are there. So in that I have compared, I have tried to take all the parts. So whatever already we have read from that I am saying. So from blue color we are showing Bacillus spinalis, then further color is, and here also what we can say that ethyl acetate is the main solvent where we can study the antibacterial activity. So in the same way, in the roots of Moringa oleifera, we have studied and make the comparison chart. And then in Escherichia coli in seeds, only in one microorganism we have seen that. So conclusion here is that the antimicrobial activity of the 5 extracts, that is petroleum ether, acetate, ethyl alcohol, methyl alcohol, and water of Moringa oleifera, and the different parts are there. They're studied on 5 microorganisms. Then came a part in study here. And what we have said that ethyl acetate shows the inhibition zone diameter in the range of 34 to 45 mm has highest antimicrobial activity than the other extract. So that was my conclusion and result.
Okay, thank you, ma'am. So, Ashatkar sir, please. And Mohobe ma'am, please ask the questions.
So should I stop it?
Jyoti madam, you have observed the antimicrobial activities of plant extract. It is clear from your data that the extract in case of ethanol and water is giving better antimicrobial activity. So what is the reason behind that? Is that solvent is playing some role, or that extraction is better in these two solvents?
It is better in this solvent.
Okay, that means concentration is higher in these two solvents, ethanol and water.
Yes. Yes.
Okay. I think then solvent is not, if solvent is not playing any role, then it's better to remove all these things. Just you have to emphasis on that extraction is better in ethanol and water, and then you should start your next study of antimicrobial activity actually.
Okay.
Miss Jyoti, our question is, your bark, your flower, they are acting as antibacterial. But if you do not use alcohol, it itself has germicidal property. Then how you compare?
Question, you are clearly not audible. Sorry.
Solvent used.
Madam, I'm not getting question.
Hello.
Madam, could you repeat your question? I'm not getting.
Yeah. You have prepared solutions in alcohol, methanol, ethanol, and ethyl acetate water, and you find that in ethyl acetate it has highest germicidal property. Alcohol itself is sterilizer. Itself kills microorganisms. Then how you can compare the germicidal properties of your extract? अपने एक्सट्रैक्ट की जर्मिसाइडल प्रॉपर्टी कैसे आप जज कर सकते हैं, क्योंकि आपने अल्कोहल में डिसॉल्व किया है, अल्कोहल तो खुद ही बैक्टीरिया किल करता है।
ज्योति मैम, क्वेश्चन समझ में आया आपको?
ये सर समझ में आ गया है, but yes, it is right that it is not possible to get it. Definitely, I will work on that.
Okay, thank you.
ठीक है मैडम, करो काम उस पर। नेक्स्ट।
Okay, thank you, ma'am. So next is Mr. Satyam Kumar Kumbhakar.
Good afternoon,
Satyam,
sir.
good afternoon. Ready to present?
Yes, sir.
Okay. Start, sir. Share your screen, sir. Okay, it is visible.
Assessment of lead concentration.
Am I audible, sir?
Yeah.
Yeah,
Yes,
you are
yeah,
audible.
yes. Start.
Okay. So, good afternoon to all of you. My name is Satyam Kumar Kumbhakar, research scholar, School of Studies in Biotechnology, Pandit Raghunath University. Here I am going to present a part of my research work that is entitled Assessment of Lead Concentration Research Lab in Dalsi when street growing at the mine technique site of Chhattisgarh. Here is the content. Introduction. So as you know that lead is one of the major toxic heavy metals released in a various industrial effluents like oil, refinery, gasoline related, brake wire, power generation plants. And lead is a highly persistent and has very less solubility in soil solutions. And because of that, lead can be absorbed by plants and vegetable stuff and enter the human body through the food chain system. And there haven't such kind of mechanism which remove lead or other heavy metals from our body. And because of that reason, they have need to reduce their bioavailability. And for that particular purpose, phytoremediation is a promising technology used to remediate toxic heavy metal from the soil by plant species that are tolerant to this heavy metal. So we better know that Central Chhattisgarh state is surrounded by so many industries. And on the basis of our observation, we have seen that the tree species, Pithecellium dulci, is commonly found within these areas. Pithecellium dulci is a leguminous tree belonging to Fabaceae family, semi-evergreen, small to medium size, that is 5 to 20 meter height. Pithecellium dulci is commonly called Ganga Imli, Jungle Jalebi, and also Madras Thorn. Objective. So here detection of lead in contaminated soil and the candidate tree species, that is Pithecellium dulci species. Materials and methods. So first of all, we have collected soil and plant samples from the industrial contaminated area. Then after all, washing the sample and oven dried at 70 degrees Celsius. And all the samples were grinded into fine powder and passed through 60 mm. And then after all, acidization of all the sample has been performed. For the acidization of sample, there are soil sample and plant sample. We have optimized the protocol. We using 3 different acidization protocols. As mentioned in the soil sample, that is nitric acid and HCl, that is aquaresia, and nitric acid and perchloric acid. And that then after all, we analyze this sample by using same atomic absorption spectroscopy. As I mentioned in the next slide, that is aquaresia method for the analysis in soil sample. Actually, when we using that 3 sample, we got better result in aquaresia method for the analysis of lead in soil sample. So here 500 mg of fine powder soil sample was taken in a triplicate, and 12 ml of aqua was added, incubated for overnight. Then after all, that is digested at 65 degrees Celsius for 180 minutes. And then after all, filter the sample and adding distilled water 50 ml, and phase analysis has been performed. Similar kinds of things also used for the analysis of lead in plant sample, but here in case of aqua, we are taking nitric acid and perchloric acid and digested the sample at 110 degrees Celsius for 3 to 4 hours. We also calculated the bioconcentration factor that will show the plant's ability to accumulate the heavy metal from the soil, and also calculated translocation factor that will show that plant's ability to translocate the heavy metals or lead content which they have accumulated in the root part to aerial part. Results, as here I am showing in result that site 1, site 2 and site 3. That site has been chosen on the basis of distance, on the basis of distance from the industrial effluent site. Site 1 is near to the industrial effluent area. Site 2 is far away from the industrial effluent area, and site 3 is too far away from that particular site. And on the basis of our analysis, we have observed that site which is near to the industrial effluent area, we got a high concentration of lead in soil. And also in our plant sample, we got the lead in a root only in site 1 and site 2, but not in site 3. And as we have seen that it is not translocated to the same leaf or bark portion. As I also mentioned in the next slide, here. This table is showing the bioconcentration factor and translocation factor in 3 different sites. Here we have seen that in site 1, bioconcentration factor that is 0.86, site 2 that is 0.58, but translocation factor nil in all the 3 sites. So Kawata Prentice also reported that 100 to 400 mg per kg concentration of lead is toxic for vegetation, and Lewis Baker also reported more than 1000 mg per kg. Dry weight of lead in root is considered as lead hyperaccumulator. And as we have seen that our candidate plant accumulated 13.5.2 mg per kg, that is more than the guidance value of lead. That's why we can say that our candidate tree can be used as a lead hyperaccumulator. So result of our investigation showed that the concentration of lead in Pithecellium dulcis that grew in potentially contaminated areas exceeded the phytotoxic and excessive value found in the plant. Here is the references. Thank you.
Okay. Thank you, Satyam Kumar Kumbhakarji. You have completed your presentation within the time limit. Congratulations. Now I request Asatkar sir to ask questions from to Mr. Satyam Kumar, and also request to Mohabbe ma'am.
Satyam ji, you detected this lead through flame AAS, right?
Yes, sir. Yes, sir.
So what is the detection limit of this method, flame AAS for lead? Actually, go to the slide where you show the graph actually.
Yes.
Minimum
This
amount which
condition.
can be detected.
Actually, here what I can see just I think minimum is 400, and after that just 0 limit is there. So maybe detection limit, maybe lower side, and the UV be unable to detect maybe somewhere around 200 milligram per kg. Sample may be there and it's beyond detection limit, and that is why you are not able to detect there.
Actually, yes, actually, sir, whenever we perform our evaluation, so we got the concentration, that particular concentration is multiplied by the dilution factor, and by calculation we found this result.
Actually, your results are somewhere around 400, then 600. There is no point between 0 to 400 milligram per kg. So that is why I am asking this question. Maybe your detection limit is a little bit higher, and that is why you are not able to detect, and just lower side, that is 0 milligram per kg he
Limit.
has shown here.
सर ASI तो बहुत कम में भी डिटेक्ट होता है.
हाँ, जनरली ये इसमें
What
काफी
are
कम हो
the
जाता है.
बहुत ही कम परसेंटेज में डिटेक्ट होता है. इसमें जो हमारा सैंपल था उसमें जो पर्टिकुलर हमको कंसंट्रेशन जो मिला था, जो डिटेक्ट हुआ था, उसका फर्दर हम क्योंकि जो एनालिसिस किए हैं उसमें डाइल्यूशन प्रिपेयर किए थे. तो ऑन द बेसिस ऑफ जो हमको रिजल्ट मिला है उसको डाइल्यूशन से मल्टीप्लाई किए हैं, उसके बेसिस पे हमको ये रिजल्ट मिला है सर.
मैडम यू कैन
interference क्या है इसमें? There must be interference with the other elements. लेड के साथ आयरन भी हो सकता है, जिंक भी हो सकता है.
जी मैम, लेड के साथ आयरन हो सकता है, जिंक भी हो सकता है, कैडमियम भी हो सकता है, लेकिन मैम क्योंकि
आपने एलिमिनेट कैसे किया? खाली लेड को कैसे आइसोलेट किया?
नो मैम, एक्चुअली
इंटरफेरिंग एलिमेंट्स.
जी मैम,
इंटरफेरेंस.
यस मैम, जो अदर हेवी मेटल्स है डेफिनेटली
अदर मेटल्स एसोसिएटेड.
जी मैम, बिल्कुल, दैट कैन इंटरफेयर.
ठीक है.
जी मैम,
लेड के एस्टिमेशन में इंटरफेयर कर सकता है ना, उसके कंसंट्रेशन को कम ज्यादा कर सकता है.
जी मैम, एक्चुअली मैम दैट इज फीचर प्रोस्पेक्ट मैम. मैम we only selected a single heavy metal, that is
नहीं, you selected lead for estimation,
कुलेश्वर.
but when the stem is growing, root is there in the soil, then other metals are also present there and they can interfere with the estimation of lead. So what are they? Interference studies.
sorry ma'am,
ठीक
I'm
है
not getting.
You go on doing that.
Okay ma'am, thank you ma'am.
नाम कौन नहीं करना?
Interference भी स्टडी करो बेटा. हाँ,
जी मैम, बिल्कुल. जी मैम, थैंक यू फॉर योर काइंड सजेशन मैम.
next.
Okay, thank you ma'am.
Next please.
Thank you Satyam sir. Thank you Asatskar sir.
Thank you sir.
So next presenter is Mr. Kuleshwar Prasad Patel. Kuleshwar, are you there? Ready to present?
Yes sir. Yes sir.
Okay, please start your presentation.
Yes sir.
Ahilya Panda, please be ready for the presentation. After Kuleshwar's presentation, you will be given one more chance to present. Okay, be ready.
Yes sir. Thank you sir. Yes sir. जा बेटा थोड़ा या साइड हो जा, अभी अहिल्या पंडा का सुनना बस.
Sir, can I audible?
नहीं,
Yeah.
आप audible
Yeah.
हो. Yeah.
You are audible and your screen is also visible.
Okay.
Yes.
You can start now.
Yes sir. Thank you. Good afternoon to all the respected professor and ma'am and research scholar.
Kuleshwar?
My name is Kuleshwar.
Kuleshwar,
Yes sir.
you can start a play mode of PPT presentation. It is easier to presentation of your PPT. Play mode. अरे यार. Kuleshwar Prasad Patel.
Yes sir.
Where is your screen?
Kuleshwar, do you have any problem?
सर इसमें जो स्क्रीन शेयर किया था वही से स्टार्ट करूँ ना?
Yes, yes, yes.
हाँ, वहाँ उसके नीचे प्ले मोड रहता है, प्ले ऑन कीजिएगा, फिर वो स्क्रीन कंटिन्यू आ जाता है अपने आप. ठीक है.
ठीक है अभी?
विजिबल नहीं है।
यस 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 यस, पीपीटी विजिबल कीजिए। उसमें देखिए नीचे तरफ प्ले लिखा होगा। प्ले में क्लिक कीजिए। प्ले में क्लिक कीजिए।
यस सर। सर hello.
Yes, yes, you can start your PPT presentation. It is visible.
Yes, thank you. Good afternoon to all the respected sir and ma'am and research scholar. My name is Kuleshwar Prasad Patel, research scholar under the supervision Dr. Priyanka Singh. Today I am going to give a brief presentation of my research work entitled Synthesis, Characterization and Sensing Activity of Silver Nanoparticle for the Detection of Thiol-based compound. These are the contents. Contains introduction, material and methods, result and discussion, and reference and conclusion. Now, why we do study of nanotechnology? Because nanotechnology is one of the most advanced and innovative important in the field of science, such as life science, physical science, health science, and chemical science. Nanoparticle. The particle size with range of 1 to 100 nanometer, that are called nanoparticles. In this presentation, we develop a colorimetric sensor investigation of the interaction of nanoparticle with thiol-based compound. The nanoparticles for the detection of biomolecule is rapidly due to their crucial role in many biological pathways. And their
Kuleshwar ji, please check your network connection.
My slide back using, yes sir.
Please check your network connection. Your voice is not clear.
चलो बेटा सैंडल कहाँ है? चलो पहनो।
सर आ रहा
Noor Afsa, please mute your mic. Kuleshwar sir?
Yes sir.
Please do continue. You are not audible. Kuleshwar sir?
ये सर कुछ प्रॉब्लम आ गया है, थोड़ा मैं
सर
देख दूं क्या?
सर आप व्हाट्सएप कर दीजिए ना, प्रेजेंटेशन को व्हाट्सएप कर दीजिए मुझे, या गोकुल सर को कर दीजिए, हम लोग शेयर कर देंगे यहाँ से। ओके ओके, अभी नाउ आई वुड लाइक टू कॉल अहिल्या पांडा।
यस सर, मैंने मेल किया है, प्लीज शेयर कर दीजिए।
या
ओके ओके, ये स्टॉप करने बोलो इसको
कुलेश्वर सर, प्लीज स्टॉप शेयरिंग योर स्क्रीन।
स्टॉप योर स्क्रीन कुलेश्वर प्रसाद पटेल। स्टॉप स्क्रीन स्टॉप कीजिए आप जूम में जाके, एग्जिट हो जाइए या तो जूम मीटिंग से। कुलेश्वर प्रसाद पटेल, जूम मीटिंग से एग्जिट हो जाइए अगर आप stop नहीं
कुलेश्वर
कर पा
सर
रहे हैं।
सुनाई दे रहा है आपको? Okay, Gokul sir, please share PPT of Ms. Ahilya Panda. Yeah, it is visible now. You can start your presentation.
Okay, sir. Thank you. Good afternoon, sir, ma'am, and all participants.
Assessment of health.
My Ahilya from Dr. University, Bilaspur. My topic of health risk due to pesticide residue in fruits. Sir, next slide. Introduction. Pesticides are substances that are meant to control pests. The extensive use of pesticide in agriculture has become a very common practice in developing countries. Recently, the increased concentration of pesticide of these hazardous pesticides in fruit. The study aimed to assess the health hazards associated with the presence of pesticide residues in fruit. Sir, next slide. Please share. Now, health risk of pesticides. Pesticides can have grave effect on the health of anybody consuming fruit highly contaminated with pesticides. Some other health risks associated with these harmful chemicals include nausea, diarrhea, abdominal cramp, dizziness, and anxiety. Please share next slide, sir. Now, pesticide effect on environmental health. The impact leads to an contamination of the environment and harmful effect of biodiversity, security, and water resources. Pests are ongoing challenge to agriculture processor. How to prevent from the harmful effect of pesticide? First is consider non-chemical method for controlling pest. Second one is select the product that best fit your needs. Third one is follow level discussion exactly when mixing and applying pesticides. Fourth is store and dispose of pesticide properly. Fifth is prevent pests from entering your home or garden. Next is choose the best and least hazardous pesticide. Next is crop rotation is very helpful to control the pest. Next is wear personal protective equipment. Next is apply pesticides only to right environmental conditions. Please share next slide, sir. Now conclusion. Identify the circumstances under which chemical pesticide may be required in future pest management. Determine what type of chemical products are the most appropriate tools for ecologically best pest management. Explore the most promising opportunity to increase benefits and reduce health and environmental risk of pesticide use. Recommended and appropriate role for the public sector in research, product development, product testing and registration, implementation of pesticide use strategy, and education about pesticides. Thank you for attention.
Okay, thank you, ma'am. Asatkar sir, please.
Hello.
Yes, ma'am. Yes, ma'am.
What are the alternatives for keeping food fresh? फ्रूट्स को ताजा रखने के लिए पेस्टिसाइड के सिवाय और क्या अल्टरनेटिव हो सकते हैं? What alternatives we can do for keeping our food safe?
Hello.
My voice is there?
Yes, ma'am. It's clear.
सर आवाज आ रही?
हाँ मैम आ रही है।
No, ma'am, not clear. Clear नहीं.
देखिए पेस्टिसाइड का रिप्लेसमेंट क्या है? अगर हम पेस्टिसाइड यूज नहीं करना चाहते खेत में, झाड़ में, है ना? तो what we can use? The novel tradition, the new tradition, new technology. What is it for keeping foods safe, for eating?
I'm sorry, ma'am. No idea.
न्यू टेक्निक्स है ना, न्यू टेक्निक्स में तो अभी बहुत सारा आ गया है, रेडिएशन है, कल ही बताया रेडिएशन।
Oh. Okay, ma'am. I will improve.
तो आइलिया जी आपने कुछ किसी पेस्टिसाइड्स पे काम किया, उसका डिटेक्शन ऑब्जर्व किया है आपने? Am I audible to you?
Yes, sir.
So, have you detected any pesticide in certain food?
Yes, sir. Methyl parathion, triazopos.
अच्छा आपने डिटेक्ट किया है, तो आपको बेटर है कि उसका डिटेल डाला था आपने, किस मेथड से डिटेक्ट किया है, डिटेक्शन कितना मिला डिटेक्ट करने पर, परमिशन लिमिट कितनी है उनकी, परमिसिबल लिमिट, वो सब चीजें आप ये थ्योरेटिकल जस्ट एक थ्योरेटिकल स्टडी जैसे आपने पेपर प्रेजेंट किया है, अगर आपने स्टडी किया है तो बेटर है कि आपको वो सारी स्टडीज
डाटा बनाई थी और इसमें मेंशन नहीं की हूँ। जी
You must
improve, sir. Next time.
Okay, next time उन सब चीजों को इंक्लूड करो, जब आप वर्क कर ही रहे हैं तो बेटर है अपना खुद का भी कंट्रीब्यूशन उसमें शो करिए।
जी Thank you, sir.
May I call next participant, sir, madam?
Sure.
Okay. So next is Chetna Gupta. Chetna Gupta, are you there? Your voice is not clear, Chetna.
Sir, am I audible?
Audible
Yes,
but
yes.
not clear.
Yeah.
Sir, now?
Yeah. Now it is
Should
clear.
I share my screen, sir?
Yeah, you can. Do you have any problem in sharing your screen? Hello, am I audible?
Yes, sir.
I think she has some issue related to the internet connection. That's why not able to share her screen or even not responding. Chetna, are you there?
I think it would be better to give chance to another person, and she may be given chance later.
Yeah, actually she has requested to prepone her presentation.
Sir, am I audible, sir?
Yeah. Yeah.
Sir, am I audible now?
Yeah, you are
Yeah.
audible.
Audible.
Sir, should I share my screen?
Yeah, you can. Please share your presentation.
So I'm trying to share, but maybe because of some technical issue, I'm unable to. Yes, sir, I'm trying to share it.
You can mail your PPT to us. We will share this PPT from host computer. Okay. So, Kuleshwarji, are you there? Would you like to present now?
Yes, sir.
Okay. चेतना गुप्ता जी, आप अपना जो पीपीटी है उसको मेल कर दीजिए. हम लोग यहाँ से शेयर करेंगे, आप वहाँ से उसको उसके बारे में बता सकते हैं.
आई थिंक सभी पार्टिसिपेंट्स को शेयर कर लेना चाहिए अपना पावर पॉइंट सर के साथ, ताकि अगर आप अपने एंड से स्टार्ट ना कर पाए तो सर अपनी ओर से फिर स्टार्ट कर दे, अदरवाइज टाइम अननेसेसरीली वेस्ट होगा.
यस सर, आप बाकी जितने भी बच्चे हैं सब लोग आप मेल कर दीजिए अपने पीपीटी, जिससे कि हम लोग यहाँ से शेयर कर सकें उसको. ओके कुलेश्वर जी, आपका पीपीटी हमने शेयर कर दिया, आप स्टार्ट कर सकते हैं.
यस सर, थैंक यू सर. Good afternoon, all respected sir and ma'am and research scholar. Thanks for giving me opportunity. My name is Kuleshwar Prasad Patel, research scholar under the supervision Dr. Priyanka Singh. Today I am going to give a brief presentation of my research work entitled Synthesis, Characterization and Sensing Activity of Silver Nanoparticles for the Detection of Thiol-based Compound. These are my contents: introduction, material and methods, result and discussion, and reference and conclusion. Next. Next. Sir, next slide. Now, why we study nanotechnology? Because nanotechnology is one of the most advanced and innovative important in the field of science, such as life science, physical science, health science, and chemical science. What are the nanoparticles? The particle with size that is called nanoparticles. In this presentation, we develop a colorimetric sensor investigation of the interaction of nanoparticles with the medicinally thiol compounds. The nanoparticles for the detection of biomolecules is rapidly due to their crucial role in many biological pathways. Sir, next. This picture represents the properties of nanoparticles, which is highly depends on its size, shape, surface modification, and composition. Sure, next. Keeping this idea in mind, we decide that using the particle of sensor can be designed. So what is a sensor? Sensor is anything that can sense something. For example, our eye sense color, our tongue sense taste, our ear sense sound, and nose sense smell. Next. Now the fundamental objectives of our work is synthesis of citrate capped silver nanoparticle, characterization of citrate capped silver nanoparticle, and development of nanosensor for the investigation of sensing activity toward the thiol based compound. Sir, experimental section. Sir, these are the materials or chemicals used in during my experiment, such as silver nanoparticles, sodium borohydride, citrate, cysteine, mesna, and thioptic acid. Sir, next. This scheme represents the general synthesis procedure of silver nanoparticles. Citrate capped silver nanoparticle has been synthesized by dissolving silver nitrate in 50 ml of millipure water, followed by the addition of citrate and sodium borohydride with continuous stirring. The synthesis of silver nanoparticle is confirmed by the appearance of yellow color solution. A synthesized nanoparticle is used as a sensor for the sensing activity of thiol compound. Silver nanoparticle solution were transferred to 2 ml ependrop followed by the addition of thiol, and then absorption spectra were recorded. The change in absorption spectra used as an analytical signal for the detection of sensing activity of thiol at optimized condition. Sir, next. Result and discussion. This slide shows the absorption spectra and time image of silver nanoparticle. The sharp and intense surface plasmoresonance band at 400 nanometer confirm the formation of highly monodispersed silver nanoparticle. And this is the time image of silver nanoparticle, which clearing shows the silver nanoparticle with size of 10 to 15 nanometer. And this absorption spectra of silver nanoparticle in the presence of thiol and their TAME image. The spectra shows the surface plasmon resonance band at 400 nanometer gradually decreases and surface plasmon resonance band shifted at higher wavelength at 520 nanometer. Their TAME image size of the thiol capped silver nanoparticle increases due to the aggregation. And this picture shows the absorption spectra of silver nanoparticle in presence of L-cysteine. The ASPR band at 400 nanometer decreased simultaneously. A new band at 520 nanometer appeared. This change in absorption spectra used as a signal for reacting the L-cysteine. And this picture shows the silver nanoparticle in the presence of different concentration of L-cysteine after incubating the sample with L-cysteine. Next, and the same procedure, and this picture shows the absorption spectra of silver nanoparticle in the presence of Meshna. In this case, the band at 400 nanometer decreased and simultaneously a new band appeared at approximate 530 nanometer appeared. And this picture shows the silver nanoparticle in the presence of different concentration of Meshna and the sample with silver nanoparticle. Next. And this picture shows the absorption spectra of silver nanoparticle in the presence of thioptic acid. In this case, the SPR band at 400 nanometer decreases simultaneously. A new band at 520 nanometer appeared. Next. This animation shows the detection mechanism of thiol capped silver nanoparticle. When we added thiol compound to the silver nanoparticle solution, these silver nanoparticles got aggregated by electrostatic interaction or hydrogen bonding, and that reflect by the decrease in SPR band at 400 nanometer with the evolution of a new band at 520 nanometer. Sir, next.
Sir, time is
yes, sir.
Almost over.
Yes,
to conclude.
Yes, this scheme represents the detection mechanism of thiol capped using silver nanoparticle. When nanoparticles is interact with L-cysteine, form aggregation of nanoparticles due to L-cysteine Zwitter ion such as NH4 plus ion and COO minus ion. Next. And this slide represents the FTIR spectra of pure thiol and at the presence of silver nanoparticle. Some peaks are removed at presence of silver nanoparticle, so easily differentiate the pure thiol spectra and thiol capped silver nanoparticle. Next. And this whole work can be concluded as synthesized silver nanoparticles are highly stable and give characteristic SPR band at 400 nanometer. UV visible spectroscopy, TAME and FTIR spectroscopy were used to confirm sensing activity of interaction of the biomolecules towards silver nanoparticles. And this method is successfully applied to detect the L-cysteine, Meshna and thioptic acid. In addition to its good sensitivity and other advantages of this method include its simplicity and rapidity. Next, these are references.
Okay, thank you, Kuleshwarji.
Thank you.
So, I request Asatkar sir to ask questions. Okay, ma'am, please.
So,
Hello. Hello.
Yes, ma'am. Yes, ma'am. You are audible. You can please ask.
First of all, tell me what is L16? What do you mean by capital L?
कैपिटल एल मीन्स मैम हिंदी में बता
हाँ बता दो
मैम कायरल कंपाउंड के लिए जो डीएल नॉमेनक्लेचर करते हैं तो उसमें जो NH2 ग्रुप अगर लेफ्ट साइड है तो एल, राइट साइड है तो डी, वो एल।
राइट है ना। तो एल इज एक्चुअली एक्टिव साइट है ना, विच रिएक्ट्स, एंड डी हैज नो कहना चाहिए एप्लीकेशन इन our biological processes. Second thing, you have taken spectra where maximum lambda max is at 400 nanometer.
Yes.
What is this region? और कौन से स्पेक्ट्रोफोटोमीटर में आपने स्पेक्ट्रा लिया?
UV विजिबल।
UV विजिबल, या तो ये कौन से रीजन में आएगा? 400 नैनोमीटर, लैम्डा मैक्स 400 नैनोमीटर है।
यस सर, यूवी रीजन
400
विजिबल चालू हो गया ना, यूवी विजिबल है ना। देयर आर टू पिक्स कंफर्मिंग दैट टू मायोटीज आर फॉर्म्ड। एक का लैम्डा मैक्स 400 के आसपास है, एक का उधर 520 के तरफ खिसक गया है लिगेंड यानी लाइसिन।
Yes.
Right? Because of the formation of, you have told that it is hydrogen bonding, it is missile formation, etc.
Yes.
Yeah. So these how you calculate which solvent you take for this spectrum?
Ma'am, water media, water solvent.
Water solvent.
Yes.
Water में color देता है वो?
Yes, ma'am.
ठीक है।
So, Kuleswar ji, what is the role of sodium borohydride in your synthesis?
Sir, sodium borohydride is a reducing agent.
Good. And what is the role of citrate?
Citrate is a capping agent.
Good.
How you maintain pH of this solution?
pH,
the pH range for taking this spectra was pH maximum 6. Which pH you have taken spectra?
6 pH पे मैम।
हाँ, तो कैसे मेंटेन किया?
6 pH में
कैसे मेंटेन किया?
मैम ये HCl और HCl and NaOH solution प्रिपेयर किया था और pH
HCl and NaOH are not buffer. No? Buffer solution should be used. To maintain the pH, we have to add buffer. Buffer, you know what is buffer solution? है ना? Buffer solution क्या होता है? So you have to
pH constant रहता है, pH change नहीं होता buffer solution.
नहीं तो मैडम का कहना है कि HCl और NaOH से बफर नहीं बनेगा. You would have been used some
pH constant रखने के लिए आपको buffer solution use करना पड़ेगा. Sodium acetate and acetic acid buffer, and the concentration of sodium acetate and acetic acid is such that it should be within the range 5 to 6.
Yes.
Good work, बहुत अच्छा काम है, इसको बहुत अच्छा करिए, है ना?
Yes.
You have all the facilities in Digvijay College. You have learned professors. Priyanka Singh is laborious, intelligent, and a very fine supervisor. D.K. Verma sir, you can take help from him also. Ashwini Sharma sir, everyone is here to help you, है ना? But you do hard work in the laboratory.
Yes, ma'am.
ठीक है बेटा.
Very
nice. बहुत
Thank you.
All the best, sir.
Thank you, sir.
All the best.
Thank you, Kuleshwar ji. Thank you, Asatkar sir. Thank you, ma'am. So, Asatkar sir, can we continue this session?
Yes, sir. चालू रखिए.
Better you should ask with madam.
नहीं, हम लोगों ने 10 मिनट का टी ब्रेक
प्लान किया. Great privilege to have madam with us.
Yeah.
Please ask.
Absolutely, sir. So, continue करें मैम?
हाँ बिल्कुल.
Okay. So our next presenter is Dileshwari Sahu. Are you ready? Dileshwari Sahu, are you there? No response. Next one is Archana Sahu. Archana Sahu, would you like to present your work? No. So, Chetna Gupta, are you ready?
Yes.
चेतना गुप्ता का तैयार होगा.
Okay. So we are sharing your PPT from our computer.
Okay,
Can you see your PPT?
yes, sir. Should I start, sir?
Yeah, you can.
Good evening to all of you, all the respected teachers, research scholars, participants, and students. I'm Dr. Chetna Gupta from Government Kamla Devi Rathi, PG Mahila Mahavidyalaya, Rajnandgaon. Firstly, I'm very thankful to the organizer for giving me the opportunity to present a small part of my work in National Web Conference. So today I'm going to present cyanobacterial biodiversity from different freshwater ponds of Rajnandgaon, Chhattisgarh, India. These are the contents of my work. So as we all know, cyanobacteria, also known as blue-green algae, they are the simple primitive life forms of Earth which closely related to bacteria, and they present each and every environment where moisture and sunlight are available. And they can also perform and participate in many environmental activities like nitrogen fixation, remediation of pollutants by soil and water. For this study, I collected the algal samples, 6 freshwater ponds of Rajnandgaon, and through the microscopic study, by considering of these given characteristic features, I identified and systematized the cyanobacterial species by the monographs given by Dasikacharya, Chalapa, and Prescott. So in this work, I observed total 17 cyanobacterial species from 6 studied ponds, and with the number of 14 cyanobacterial species, pond number 5 was the most diversified pond, and with the number of 5, that Lingbia silentica is the most abundantly present cyanobacterial species in all the 6 studied ponds. These are the pictures of my reported cyanobacterial species. This is Syncoccus aeruginosa. They are the unicellular colonial cyanobacterial species. Microcystis aeruginosa, Microcystis viridis, Aphnocapsa montana, Gomphosphaerian aglinum, Lingbia species, Oscillatoria species, Nostoc spongiforme, Hypocystis cyanobacterial species, Campylonamidicum, Calothrix species, and already preliminary studies done by the many researchers in Durg Rajnandgaon region, and they also revealed that they are abundantly present in indigenous environment, and these cyanobacterial species are often cultivated for required nutritional supplements and for research purpose. And by my research work, I concluded that if we produce this cyanobacterial species in a large scale, then wastewater use can become progressively safer worldwide. These are the references of my work on the basis of work on Chhattisgarh region. Thank you so much.
Okay, thank you, ma'am. Asatkar sir, please. Mohbin ma'am, please question.
Madam, what is the importance of your work? And why did you focus on the Rajnandgaon region only?
Sir, because Rajnandgaon area, as I saw Rajnandgaon, especially Rani Sagar and Buda, is mostly polluted by the arsenic. That's why I chose Rajnandgaon area for my work. As my work is basically is bioradiation. It's based on bioremediation.
So is there any direct relation with arsenic?
So you are not clearly audible, sir. I'm not getting your question.
Hello. So is your work directly related with arsenic?
Sir,
Arsenic contamination?
Yes, sir. I worked on arsenic, lead, mercury, and copper contamination.
Okay. Madam, you can please ask. If you have any question.
Hello.
Yes,
Yes,
ma'am, you
ma'am.
can please ask.
You can analyze water also where these water bodies are present, and you can compare the properties of water, properties of fresh water with this water which contains these algae, these
Sorry,
plants.
ma'am, I'm not getting. Sorry, ma'am, I'm not getting your question. Can you please repeat, ma'am?
या ये जो वाटर बॉडीज आपने कलेक्ट की है ना, उनका एनालिसिस किया नहीं किया? Which pond is most polluted? बूढ़ा सागर, रानी सागर, मोती तालाब, बहुत सारे तालाब है यहाँ राजनांदगांव में. Have you reviewed the water analysis of Rajnandgaon district? देखिए बेटे, कोई भी जैसे हम वाटर बॉडीज पर रिसर्च कर रहे हैं और तो हमको कुछ हिस्ट्री, कुछ बैकग्राउंड पता होना चाहिए कि इस पर कितना काम हुआ, क्या क्या हुआ, and then we can conclude, we can reach to some conclusion.
Ma'am, am I audible now?
You
Ma'am,
are
I'm
audible.
not getting your voice, ma'am.
You are getting my voice? मेरी आवाज आ रही है
No,
आपको?
ma'am.
नहीं आ रही?
I think there is some network issue, ma'am.
Yeah. मेरे तो पूरा नेट.
She is not able to hear the question clearly.
चलिए सर, नेक्स्ट इसमें तो कुछ काम है ही नहीं अभी.
Okay, ma'am. Thank you, ma'am. Thank you, sir.
Next.
So our next presenter is Mr. Niranjan Kumar. Niranjan ji, are you ready?
Yes, sir.
Okay. Please start your presentation.
Yes, sir. Am I visible, sir?
Yeah, it is.
Okay. Good evening, everyone. I am Niranjan Kumar, and I am pursuing my PhD under the supervision of Dr. Y.K. Mahipal sir from Pandit Ravi Shankar Shukla University. And my today's presentation topic is study on anic conductivity and thermal properties of sodium ion conducting solid polymer electrolyte membranes. These are my contents. Introduction. Solid state ionics is an interdisciplinary research area where physics, chemistry, and material science can meet. In solid state ionic materials, mainly we deals with the motion of ions in solids. For the practical application of such kind of materials, we should require some following properties, which are ionic conductivity should be very high in the range of 10 to the power minus 4 Siemens per centimeter at room temperature, and ionic transference number, which also known as T ion, should be close to unity, means principal charge carrier should be ions only, and activation energy should be very low, around 0.3 electron volt or less. Then the electronic conductivity is negligibly small, and high chemical, thermal, and electrochemical stability are required. As we know, lithium-ion batteries has dominated the market of portable electronic devices, electric vehicles, due to its high voltage and high energy density, but due to some toxic nature, less natural abundancy, and high cost, researchers are trying to replace lithium by sodium. That's why I'm also trying to work on sodium ion conducting solid polymer electrolytes, because sodium has 1,000 times more abundancy than lithium. That's why it's cheaper also. In my present investigation, binary system of NaI and Na3PO4 has been already reported by Ahmad et al. In 2014. So I am trying to complex it with PEO and ion transport and temperature dependency of solid electrolyte. Also, I am trying to study. By this following formula, I have calculated conductivity, T-ion, and activation energy. Synthesis method. For the synthesis of solid polymer electrolyte, I have take polymer host PEO and complexing salt and physically mixed together by mortar pestle till 30 minutes at room temperature, and hot mix it around 70 degrees Celsius for around 30 minutes only. Then the soft slurry was pressed by KBR press machine with a pressure of 2 tons per centimeter square, which we get from which we get uniform SP film of thickness of 200 micrometer. As we can see from the figure, our film is transparent, as we can see. Then at result section, this one is log sigma versus concentration plot. As we can see, for 0% means for pure PO, the ionic conductivity is very low. But after the enhancement of the sodium salt, we can see the ionic conductivity get enhanced, and we got maximum ionic conductivity for 30% of our salt. This is the Nyquist plot, which shows the bulk resistance. As we can see, with the enhancement of concentration of sodium salt, the bulk resistance gets shifted towards the lower region, means the resistance getting decreases and ionic conductivity get increases. And we can see for the maximum conductivity, means minimum resistance I have get for 38% of sodium salt. And the ionic conductivity for the 30% which I got is around 4.89 into 10 to the power minus 6 Siemens per centimeter. And also we know pure PO shows the room temperature ionic conductivity around in 10 to the power minus 9 Siemens per centimeter. So we got 3 orders enhancement in ionic conductivity. After that, log sigma versus 1000 by T plot, which shows or tells about the enhancement in ionic conductivity with respect to temperature. When we enhance the temperature of the sample, we got lower resistance, mean the conductivity got enhances. By this plot, we calculate activation energy also, which is around 0.10 electron volt by the formula of Arrhenius equation. And this is the ionic transference number. Ionic transference number tells about the total ionic current in our sample. As we can see in the figure, total current is very near to I ion, means all the current which I am getting is totally from the ions, movement of ions. Conclusion. At last, a dry solid polymer electrolyte film with the composition of 70 PO and 30 sodium salt have been synthesized using hot press technique, which is very fast and unique method. And its room temperature conductivity is around 4.89 into 10 to the power minus 6 Siemens per centimeter. And the T-ion is very close to unity, which is 0.99. And the activation energy is also very low, which is very useful for us, which is 0.10 electron volt. So, but the room temperature conductivity is not so good. So we can enhance the ionic conductivity by the dispersion of micro and nano fillers in SP host materials. And we can also use some techniques like ball milling to reduce the particle size. That's why we can enhance the ionic conductivity as well as the properties of materials. At the last, for the production of inexpensive wearable electronic devices like smartwatch and fitness trackers, sodium ion conducting solid state batteries can be helpful for us, and it can be also useful in supercapacitors or electric vehicles or in electrochemical sensors also. These are my references. Thank you.
Okay, thank you, sir. Ashatkar sir, please.
Niranjan ji.
Yes, sir.
I think the ionic conductivity of sodium is higher than lithium. Am I right?
No, sir. Lithium is higher than sodium.
No, I am asking about ionic conductivity independently.
Independently, yes, sir.
Sodium ionic conductivity of sodium is higher. Am I right?
Yes, sir.
In solution.
So, yeah, in solution, yes.
Yes, sir. Yes.
That's true. So, is there any benefit of this fact while switching from lithium-ion battery to sodium-ion battery?
Sir, actually, we can't say because we are just trying to make a sample with solid, not by liquid, so that we can save our battery from leakage problem also.
Solid conductors.
Okay. So it's based on electronic conductance actually.
No, sir. No, sir. It's
Ionic
totally
conductance.
ionic conductance. Yes, sir.
So in this case, ions are moving or just electrons are moving?
Yes, sir. Ions are moving, as we can see from this plot also. The total current due to the ion is very close to total current, which is here also. The ion is very close to unity, means only 0.01% conduction is due to the electrons.
Okay.
Yes, sir.
Okay.
You are using 50% sodium iodide and 50% sodium sulfate by mass.
Yes, ma'am.
But they are not equivalent, no?
Yes, ma'am. This
Moles
composition
are
is
not
already.
Moles are
Yes,
not
ma'am.
equivalent, and you use 30% of this mixture.
Yes, ma'am.
Then you get maximum conductivity.
Yes, ma'am. Yes, ma'am. This one.
The electrode potential of lithium is more negative.
Yes, ma'am.
Lithium has-
Electronegativity. Yes, ma'am.
Electrode potential is minus 3.04 electron volt.
Yes, ma'am.
Lithium and sodium is far below it.
Yes, ma'am.
Because of the smallest ion.
Yes, ma'am.
Sodium has the electrode potential is more negative because it is the smallest ion and its hydration energy is higher than its ionization energy, which is compensated.
Yes, ma'am. Yes, ma'am.
Then how lithium can be replaced by sodium? Sodium ion की conductivity तो कम होती है.
Yes, ma'am. Yes, ma'am. It's ma'am. We know that for
The mobility of sodium ion will be also less.
Yes, ma'am. For the small production like batteries, we know the output voltage and energy density is high in case of lithium. But if we want to go for the large production like electric vehicles where the energy density is not necessary, we can complete it by large size. There we can replace lithium ion batteries by sodium ion batteries, ma'am.
Sodium ion will be more covalent than sodium chloride. Sodium iodide.
Yes, ma'am.
Is not very ionic. Sodium in comparison to sodium chloride.
Sodium chloride. Yes, ma'am. Yes, ma'am.
So you use sodium iodide. It will not ionize.
Yes, ma'am. Yes, ma'am.
Sodium.
Why you do
Actually,
not?
yes, ma'am.
यहाँ सोडियम आयोडाइड क्यों लिया आपने?
एक्चुअली मैम केमिकल की अवेलेबिलिटी सोडियम आयोडाइड की थी मेरे पास में, मेरे लैब में सोडियम क्लोराइड नहीं था, तो मैंने इसी पे काम स्टार्ट किया मैम. That was the only
Sodium
reason
chloride is
behind
easily
that.
available and very cheap also. So I think
No, sir. Actually, this is a physical lab, not a chemistry lab.
no. Still sodium
नहीं
chloride
नहीं
is easily available in market and it's
but
very cheap.
I know that physics prepare solid state batteries.
Yes,
and
ma'am.
they
Yes, ma'am.
use potassium iodide, silver iodide.
Yes,
they
ma'am.
use iodide. They do not use chloride. Why?
Chloride.
Why?
Ma'am, basically the reason behind this is the cationic and cationic radius. We try to have a cation a small size. That's why it can move properly and fast.
No,
In
cation would
comparison
be
to
same in
Cation
that
तो
case
सोडियम
also.
आयन तो बड़ा होता है ना.
cation. मैम सोडियम आयोडाइड में आयोडीन का रेडियस बड़ा होगा, सोडियम छोटा होगा, तो कैटायन आपका जो सोडियम है
लिथियम
वो
आयोडाइड
इक्विलिब्रियम.
में तो लिथियम आयन तो और छोटा हो जाएगा, लेकिन but it will be covalent. And
Yes,
therefore
ma'am.
we cannot use lithium iodide. We will use sodium iodide. Because
ma'am,
sodium
actually-
iodide will be more ionic than lithium iodide.
Yes, ma'am. Thank you for your
Your
valuable
work
service.
is very nice. बहुत अच्छा
Thank you
काम
so
है.
much, ma'am. Thank you
है
so
ना,
much.
इसको आप करिए और बहुत डीपली जाकर करिए, है ना.
जी
You
मैम.
read more and try more efforts.
Thank you so much, ma'am.
ठीक है बेटा.
Thank you
All
so
the
much
best,
for your
ma'am.
blessing, ma'am.
Next.
Thank you, Niranjan sir.
Yes, sir.
Thank you, sir. Thank you, ma'am. Our next presenter is Sanjay Jain. Are you there?
Sanjay Jain.
Please stop the share screen.
Yes, sir.
Sanjay Jain ji, are you there? No. Rajkumar Rathod.
Yes, sir.
Yeah. Please do start your presentation.
Yes. Good afternoon, everyone. Am I audible, sir?
Yeah.
Yes, sir. Yes,
You are
sir.
audible
I'm
and your screen is
going.
visible.
Yes. Yes, sir. Yes, sir. Myself, Rajkumar Rathod, Assistant Professor from Department of Chemistry, Government EVPG College, Korba. I'm going to give a presentation on analysis of soil of Gauthan area in Kartala block of Korba district. Introduction. Availability of fodder works as a limiting factor for animal husbandry, and the physico-chemical analysis and properties decide the qualitative and quantitative yield of the fodder, which ultimately affect the production of livestock products. In India, 18% of human population and about 33% of livestock population is supported only in 2% of land, world's land in India. So there is a large pressure on area in India. Essentially, day by day, agricultural as well as grazing land due to population explosion and industrialization. So here I am focusing only on the livestock, and I want to throw light on the 10 5-year plan data of the government of India, which shows that from 1995 to present time, there is a deficit in the green as well as dry fodder, and it is going to be the same scenario in the 2025. So the production is required to be increased. The qualitative yield of forest production is much required for sustainable growth and development. So more emphasis is given only to the cropland and crop production, but no proper attention is given toward the forest production. Here, soil fertility study of grazing land can help in better qualitative and quantitative yield of the forest crop. We greatly improve appropriate attention to soil testing, liming, and fertilization. In Chhattisgarh, Narwa, Darwa, and Bali scheme is operated by the state government to provide green fodder to the livestock. So here Gauthan has been developed, and near Gauthan grazing land is going to be developed, and in some areas we can see the grazing lands which are already developed in these areas by reserving revenue land. So the physico-chemical analysis of soil can reduce the unknowing and inadequate use of fertilizer, and optimal use of fertilizer along with manure can lead to greater yield without compromising with the soil quality. Here I have chosen the site for study as Kartala block of Korba district, and in this I have taken 10 Gauthan area grazing lands of Gumia, Limdi, Dadarkala, Kathrimal, Jogipali, Dhitori, Nawadi, Sindripali, Bandapali, and Botli. The sample soil was collected from the area after removing the contaminated material with the help of spade or kurpi, and by making V-shaped holes at a depth of 15 to 20 centimeter, and collecting the soil in the clean plastic bucket at from 6 to 8 places from one spot. The soil were mixed in a clean cloth, air dried, and then lumps were broken with the help of wooden pestle and mortar. Later on, the particles were disaggregated and shaped, and then stored in glass bottle as well as clean polythene bag. Whatever is there with me. Now, analysis of sample is done for this soil property: electrical conductivity, pH, organic matter, boron, sulfur, phosphorus, nitrogen, potassium, copper, zinc, iron, and manganese. The analytical result was shown here in this table. On plotting the graph, we can see the pH of this all areas was slightly acidic. So maintaining pH is required for proper nutrient uptake by the forage crop. Electrical conductivity measurement shows that the soil is not saline, so it is not a problem for us. Organic carbon is very low in this area, so it is required to be increased. Boron is also low. Nitrogen in limb D is high, except limb D, the nitrogen content in all other areas is very low. Potassium is also, here we can see it is sufficiently high. Sulfur, iron, manganese, and copper is also sufficiently high. The qualitative and quantitative yield of forage crops should be enhanced by supplying appropriate amount of nutrient to the forage crops. So manuring and applying to supplement nitrogen and boron is required. We can conclude that for better qualitative and quantitative yield of forage crops in limited space, proper manuring to increase the organic content and applying fertilizers to increase the nitrogen boron content is the future perspective of doing this work, and also studying the soil properties of other Gauthan areas can help us in this. Encroachment of grazing land causes decrease in availability of grain fodder, which result in damage of crop by animals. So the physico-chemical analysis of soil can help in better yield of fodder and reduce the loss from these animals. A higher yield of fodder may provide an economical feed source, which could reduce the expense on livestock, resulting in more profit in livestock product. Better quality fodder may upgrade the quality of livestock product like milk, meat, eggs, and enhance its nutritional properties. Well-managed pasture farming system are beneficial for building soil health and capturing carbon from the atmosphere. It also provides an attractive landscape for viewing public. Properly managed perennial pasture planting can improve the soil quality. Pasture can greatly be improved with appropriate attention to the soil testing, lambing, and fertilization. Thank you.
Okay, thank you, sir. Asatkar sir, please ask questions to Mr. Rajkumar Rathod.
Sir, how did you estimate this
Mahogany ma'am, please. Yes, sir.
elements?
Hello.
Hello, Rajkumar sir. How did you estimate these elements?
Actually, sir, I have given these samples in the soil testing laboratory to analyze all the samples.
Okay, okay.
Actually, I'm not having all the facilities in my lab, only except doing pH and electrical conductivity. Other material is not there in my lab.
Okay, fine, fine.
Which method they adopted?
Madam, they have used tachymetric method for phosphorus, nitrogen, potassium, and AAS for sulfur, iron, manganese, copper, zinc, and metals.
What about the percentage of iron in the soil? आयरन आयरन एस्टिमेट किया है, इसमें आयरन का नहीं दिया आपने, जिंक का लो है ना?
मैम आयरन का भी था, आयरन भी सफिशिएंटली हाई थी मैम.
हाई है आयरन
एरिया? हाँ मैम हाई है कतरा एरिया में.
या आयरन हाई रहने से क्या इफेक्ट होगा क्रॉप पर? व्हाट इज इफेक्ट ऑफ आयरन ऑन क्रॉप प्रोडक्शन?
एक्चुअली sorry madam, actually I'm
ये भी पता चलता है ना, it is iron polluted, the soil is having excess of iron, then the leaves will become green to yellow. तरह का कुछ changes आते हैं. For example, क्लोरीन कंटेंट हाई होने से भी लीफ में और ग्रास में कुछ चेंजेस आते हैं, है ना?
मैम नेक्रोसिस होती है, लेकिन एग्जैक्टली मैम क्या चेंजेस होगा वो नहीं मालूम.
ठीक है बेटा, है ना? इट इज ए गुड वर्क, है ना? इट इज कंटिन्यू वर्क. ऐसा नहीं है कि आज आपने कर लिया तो दूसरा कल नहीं कर सकता है. ये एवरी टाइम द सॉइल क्वालिटी मस्ट बी टेस्टेड सो दैट वी गेट गुड क्वालिटी फूड एंड abundant food, and therefore quality of soil should be always maintained, and soil analysis should be done by every laboratory present in our town. अपने आसपास तो करना ही चाहिए. थैंक यू. Very nice.
Yes, yes. Thank you, ma'am.
Your work is really very good, sir, and it's really fruitful actually. And you can share your data with government also if you are confident, so that they can work out on the deficiencies of certain elements which are necessary for the plants and animals. So that also you can plan in future.
Yes, sir. Actually, I am trying to do the work in this direction only, and in next time. I'm trying to analyze the heavy metals in the soil. Actually, we are not having a laboratory facilities, so it is a challenge for us.
Yeah, that's true, sir. But still, you are working good. It's really appreciable, sir.
Yes, sir. Thank you, sir.
Thank you, sir.
All the best.
Thank you, ma'am.
Okay, thank you, sir. Thank you, Asatkar sir. Thank you, ma'am. So next participant is Pushpender Singh Jaget. Pushpender, are you ready to present your work? Pushpender, are you there?
How many are remaining, sir?
1, 2, 3, 4, 5. More participants are there. Next one is Mahendra Kumar Parthe. Mahen, are you there? Mahendra, would you like to present? No response. Mr. Yasdev Devangan. Yasdev, okay. Mr. Amit Kumar. Amit ji, Are you there? Satish M. Chawanji, are you there? Satish M. Chawanji, are you there? No response. Amitji, are you ready?
I am there, sir.
Satish ji?
Yeah, I am there.
Okay. So start your presentation, sir.
Okay. Sir. Continue, sir. अच्छा वो कर रहे हैं फिर Okay, sir. I am Dr. Satish Chauhan, Associate Professor in the Chemistry Department, RNC Arts, JDB Commerce. I am audible, sir? Okay, sir. I am audible?
Yes, sir. Yes, sir. Yes, you can start.
Yes.
I am Dr. Satish Chauhan, Associate Professor in the Chemistry Department, RNC Arts, JDB Commerce, and NSC Science College, Nasik Road, Nasik, Maharashtra. I welcome all participants for my oral presentation, Green Synthesis and Biological Activity, Evaluation of the Novel Ethyl 3 Amino -2 substituted benzylidine 4-cyano 5-methyl sulfonyl thiopine 2 carbohydrates. So thiopine-based analogs have been fascinated by the growing number of biologically active compounds, which are playing a vital role in the medicinal chemistry to improve the advancement in the variety of the biological activities. So these are some compounds: metaphenylene, which acts as an anti-allergic compound; tigabyne, anticonvulsant activity; then biotin, vitamin B7, which has important role in the pregnancy. Then some thiopine-based analogs have been largely used as anti-cancer agents. So these are some examples. All thiopine compounds generally show the antibiotic activities, anti-proliferative, anti-inflammatory, antifungal, HIV inhibitor, hypoglycemic activity, and analgesic activities. Also, anti-inflammatory and all these activities. So these are some examples. The biological activities of the thiopine-based sulfoxides and sulfonamide show the anti-inflammatory, antibacterial, antifungal, urease inhibitor, carbonic anhydrase inhibitor, diuretics, and campylobacter inhibitors. So these are some examples. Then there are some thiopine-based carbohydrates which act as anti-cancer, analgesic, and antibacterial, antifungal, etc. So these are some thiopine-based marketed medicines used for the various purposes: antibacterial, larvicidal, antifungal, and microbial activities. So coming to my part, the synthesis of ethyl 3 amino 4-cyano 5-methyl thiosulfonyl 2-carboxylate 2 was achieved by the overnight stirring of ethyl amino 4-cyano 5-methyl thiopine 2-carboxylate 1:3:2 one mixture in presence of glacial acetic acid and hydrogen peroxide at 0 to 5 degrees Celsius. So just so this compound ethyl 3 amino 4-cyano 5-methyl thiopine 2-carboxylate 1. There was SME, which was converted into the sulfoxide. The sulfonyl group is formed by the oxidation using the hydrogen peroxide. Then this compound was reacted with the hydrogen hydrate in presence of ethanol and refluxer for 5 hours, the ester group is converted into the hydrazide group. So this was the thing. The progress of reaction was monitored by TLC, that is hexane ethyl acetate mixture, H2 in proportion. Then reaction mass was reflux for 3 to 5 hours to yield the product in good yield. So we get the 3-amino 4-cyano 5-methyl thiophene 2 carboxyl as a compound. Then this compound was compound 4, that is hydrazide compound, was reacted with the aldehydes in presence of ethyl alcohol as a solvent and reflux for 5 to 6 hours. We get the hydrazine derivatives of these compounds. So they are the same reaction was carried out in a microwave irradiated method, and this reaction is observed in 5 to 7 minutes. So these are the some practical yields. So when we use conventional method, that means compound 4 aromatic aldehydes in presence of ethyl alcohol and reflux for 5 to 6 hours, the yields were 60.6%. And by using microwave irradiation method, the yields were increased up to the 91%. So after that, this is the higher spectrum of this compound, sulfoxide compound, where in SME, where it was sulfur, it was its value was higher value was 1350 to 1340 as a stretching frequency, and when it was converted into sulfoxide, the SO stretching frequency has been increased to 1070 to 130. So this is an NMR spectra of this compound. So we have got this value. So for 1.34 for the ethyl group here. Then we have 3.46 for the CH2. Then we have 6.52 for this NH2, and this for NH, first NH we have got it for 8.16, and for another NH2 it is 9.46. This is an NMR spectra. Then after that it was subjected for the antimicrobial activity evaluation of these compounds. And then it is found that the compound 6A shows very little biological activity. Compound very little biological activity with the gram-negative and gram-positive bacteria. Gram-negative and gram-positive bacteria, S. aureus, E. coli, P. aeruginosa, and then antifungal against fungus, that is Aspergillus niger and Candida albicans. So compound 6B with 4-methoxy substituent, it shows the good activity against S. aureus and against the P. aeruginosa. Compound D shows good activity against S. aureus, and it also shows the good antifungal activity with Candida albicans.
The time is almost over.
Yes,
please conclude, sir.
Compound 6E shows the good activity against E. coli, and so these are the some activities. So it was observed that 3-amino N-424 substituted benzylidine 4-cyano 5-methyl sulfonyl thiopene carbohydrates were synthesized in good yields using the micro irradiation method. These compounds show the moderate antibacterial and antifungal activities against gram-positive bacteria and fungi when compared with the standard antibacterial drugs such as dentamicin and antifungal drug fluconazole. So, thank you.
Okay, thank you, sir. So now I request Asatkar sir and Mohan to ask question to Mr. Satishan Chauhan.
Sir, which media you used for antifungal activity?
Sir, madam, compounds were dissolved in DMSO and then DMSO में dissolve किए, उसके बाद apply किया उसके ऊपर.
Yeah. Dimethyl sulfoxide.
Dimethyl sulfoxide, yeah.
And in water, you have not tested it. It is not soluble.
In water, these compounds are not soluble.
Sir, is there any antifungal or antimicrobial activity in DMSO also? I think it is there.
हाँ, DMSO में दिया है ना यहाँ पे.
DMSO. What is effect of substitution, sir? You have compared 4-methoxy, 4-nitro, and simple phenyl or chlorophenyl. Which is more active? That is 4-methoxy phenyl is more active.
Methoxy and chloro is more active, sir, madam.
The methoxy group is the electron releasing group.
Releasing group, yeah.
And chlorophenyl is electron attracting group.
Attracting group.
So of these two, which will be more active? 4-methoxy.
For this gram-positive P. aerogenesa, it was 4-methoxy is good active, and
then
for
then chloro.
Then chloro, like that.
It requires more study. Yeah.
Yes.
You have done elemental analysis of these compounds. No? Characterization of this compound.
Characterization is done. Yeah.
Yeah. So you have studied elemental analysis, spectrophotometry.
Elemental analysis, mass also.
UV, IR, mass.
IR studied. UV not studied, ma'am.
You will give more clue. And mass spectra.
Mass spectra is also there.
Now, sir, now thermal techniques are also important. The thermal stability of this compound should be tested.
Okay, ma'am.
Thermal stability, DTA, TGA.
Okay.
Maybe.
Yes, sir, very good. You are far away from us, but you are near us today.
Yeah.
We are hearing you. Thank you, sir.
Okay.
Definitely, it's very advanced work, sir. Please keep it up. It's really very good work, sir.
Thank you.
Thank you, sir.
Okay. Next, sir.
Thank you. Thank you, ma'am. Thank you, sir.
Thank you.
So our next participant is Mr. Amit Kumar. Amitji, are you ready? Amitji, can you hear me? Amit sir, are you ready?
अब सर सवेरे थे अभी तो कहाँ गए?
Sir, I am ready.
Yeah. Amit is also ready, ma'am.
Okay.
I will call upon you after presentation of Mr. Amit.
Okay, sir.
Sir, I am ready, sir. Sir, I am audible, sir.
Yeah, you are audible. Please start your
Amit Kumar.
presentation.
Okay, sir. Okay.
Amit Kumar.
Good afternoon to all of you. I'm Amit Kumar, research scholar from Government Digvijay Physics College, Rajnathgaon, Chhattisgarh. Now I want to tell presentation under the topic on magnesiothermic synthesis of silica nanoparticle and their characterization. So these are the contents which are involved in my presentation. Firstly, I introduce about the silicon nanoparticle. Actually, the silicon is the most extraordinary element in the periodic table because it is used in the various sectors like electronic manufacturing, as well as biosensor, as well as optic manufacturing, and silicon nanoparticle bear a significance in nanotechnology. Actually, this silicon is found in the earth crust, approximate 28%. Silicon have the metallite character, and silicon is mostly found in the form of silica. So why silicon is involved in my presentation? So first, silicon is actually found in silica in our Chhattisgarh in more amount. So I want to synthesize silicon from the silica sand of the Chhattisgarh river. For the synthesis of the silicon nanoparticle from the silica sand, various types of methods have used for the synthesis, just like a magnesiothermic reaction, aluminothermic reaction, reduction method, and magnesio-aluminothermic reaction. In my presentation, in our work, magnesiothermic reaction is involved for the synthesis of the silicon from the silica sand. The entire work, entire experimental work will be done in the following 3 steps. First step is the sample collection, and second one is the treatment of silica sample, and third one is the chemical reaction and the characterization. So this in this slide is you can see the about the magnesiothermic reaction. In this the magnesiothermic reaction, magnesium element is used as a reductive element. When magnesium treated with the silica sand, then silica sand is reduced as a high high temperature. When magnesium is treated with the silica sand, exothermic reaction is occurred. It means the temperature increases during the reaction, and it's provide to the driving force for the forward reaction, and it is a making to the self propagation reaction. Actually, in this reaction, magnesium is used because the magnesium have the less melting point as well as more reacting power with the silica sand. So magnesiothermic reaction is efficient as compared to another synthesized reaction. In our synthesis of the silicon from the silica sand by the magnesiothermic reaction, the whole reaction process involve in different steps. In the first step, sample will be collected from the silica sand. Sample will be collected from the rivers of the Chhattisgarh, from just like Narangi River, Mahanadi River.
You're not.
Okay, ma'am. Mahanadi River, and as well as Indravati and Sivnath Nadi. After the sample collection, sample will be dried 2-3 hours, and it will be messed. Then after the messing, the sample will be weighing, and after the weighing, the sample will be washed. Sample washed with the water at the same time, and up 5 times washed with the distilled water, and again 5 times washed with acetone. Again sample the weighing and calculate the weight loss. By the weight loss method, we can calculate the impurity in the silica sample. Then after the weighing, sample will be dried approximate 150 degrees Celsius for 1 hour and put in the capped bottle. Then goes to the second process, and in this process our entire work is done in the 6th step. And the first step, sample will be mixed with the magnesium ribbon in the appropriate ratio. Actually, the same magnesium exists in the room temperature in the solid state. So magnesium cut into a large number of small particles, and this magnesium react with the sample in the reaction chamber. Actually, the reaction chamber is the hot muffle furnace. In the muffle furnace, temperature at the temperature 1000 degrees, approximate 1000 degrees Celsius, magnesium react with the silica sample and reduce by the magnesium. Then reaction is completed approximate 1 hour. After the reaction, sample will be cooled at the open atmosphere. Then the compound treated with the acid. Generally, different types of acid used for the acid leaching. In our work, as SCL used as a acid leaching acid leacher. Then after the acid leaching, sample will be washed in with the distilled water, and PPT of the silicon will be collected, and after the collection, sample
come to the result point. Result point. Come to the result.
Okay.
Characterization technique.
The whole reaction occurs in the in this chemical reaction. Silicon oxide react with the magnesium, and magnesium oxide and magnesium silicide is formed. And again, magnesium oxide reacts with the hydrochloric acid. Then magnesium chloride is formed, and then magnesium chloride is very purely ionic in nature. And after the washing of H2O, the whole magnesium chloride is removed from the sample. The pure silicon obtained obtained in the magnesiothermic reaction. For the characterization of this silica, different characterization technique used in this our work. SAM, TAME, EDX, FTIR, and Raman involved for the characterization. So in the same characterization, actually the same reveal the information about the external morphology and crystalline structure. Okay, sir.
Please conclude.
Okay, sir. Conclude. Okay, sir. Same image inform to the morphology of the silicon nanoparticle and introduce to the size of the silicon nanoparticle. Approximate 50 nanometer diameter of the silicon nanoparticle observed in silicon nanoparticle. And this slide represents to the EDX characterization. from the EDX characterization, we observed approximate 90% of the silicon and with involving of oxygen and some amount of magnesium. IR characterization. This FTI IR characterization informed to silicon stretching frequency as well as silicon hydrogen as weighing stretching frequency. This silicon hydrogen stretching frequency observed from the acid leaching process, because the acid leaching during the acid leaching process, silicon some of the silicon element react with the hydrogen from the hydrochloric acid, and this slide represent to the Raman analysis. In this characterization technique, we observed to the actually the silicon stretching frequency approximate 400 to 480 and 520 centimeter inwards.
Time yours.
Okay. And the conclusion of this work is actually the silicon nanoparticle can be readily produced from the silica with a low cost method, and the magnesiothermic in this magnesiothermic reaction purifies the silica nanoparticle from the silica sand and by the acid leaching process. And fourth of the conclusion is the silica sand powder, which is composed of the nanoparticle, can be purified with the small size. And most important of this conclusion is the silicon nanoparticle observed carbon free. So this is the conclusion. Thank you.
Okay, thank you, Amit sir, for sharing your research work. Now I would like to request Asarkar sir and Maube ma'am to ask question to Mr. Amit Kumar.
Silicon nanoparticles are amorphous or crystalline? आपने जो नैनो पार्टिकल्स बनाए हैं, they are of very small size. Are they crystalline or amorphous? Hello?
Ma'am, silicon observed by the SAM technique according to the.
Yeah, आपकी technique बहुत अच्छी. It is very easy and very simple, and you are getting nanoparticles of free silicon from silica. That is good. But this silicon is is amorphous or crystalline, because the properties depend on the structure of the element also, particle also. The particles are arranged in ordered way or in zigzag manner. Next question is, what is a change in properties of this silicon obtained by this method? Nanoparticles आपने बनाए सिलिकॉन के, इनकी physical properties में क्या changes आए? You have studied physical properties of these nanoparticles.
Okay.
Conductivity in
सिलिकॉन नैनोपार्टिकल जब अप्रोक्सीमेट 50 नैनोमीटर की रेंज में जाता है और यहाँ पे पोरस नेचर स्टेबलाइज करता है, और पोरस नेचर के कारण इसकी बाइंडिंग कैपेसिटी बढ़ जाती है मैम, और साथ ही साथ इसकी रिएक्टिविटी भी बढ़ती है। और
कंडक्टिविटी
इलेक्ट्रिकल
कंडक्टिविटी
ओके मैम, electrical conductivity also increases in nanocrystalline silicon nanoparticle because the surface area increases, and due to the increasing of the surface area,
silicon is a semiconductor. Which type of semiconductor?
Silicon is the intrinsic semiconductor.
intrinsic semiconductor. And on increasing the temperature, its conductivity increases. Right?
Yes, ma'am.
तो ये जो आपने nano particles बनाए हैं, that will be the effect of heat on these nanoparticles or radiation. ये सोलर पैनल में ज्यादा यूजफुल होंगे कि कम होंगे?
Actually, ma'am, this silicon is the purified silicon. When ultra pure silicon is obtained, then it is used in the formation of solar panel. Actually,
they will be good. They will form good solar panels.
Okay, ma'am.
They will be good semiconductors. Right?
Okay, ma'am. It can be used in for the formation of solar panel.
We can use them many things. Huh?
It can also use for the formation of transistor.
Silica is heat resisting. Silica, SiO2. Right? Silica is refractory, na? Refractory. It can bear good temperature.
Okay.
So,
actually, the silica, I don't know, madam, the physical property of the silica.
You prepared magnesium silicide and then you prepared magnesium chloride and silicon.
Okay.
Right?
Okay.
So, you prepared magnesium chloride, a magnesium silicide, but you have taken magnesium and silicon in appropriate proportion.
Okay. Okay.
And if excess of magnesium is present, then it will form magnesium silicide.
Okay. And the excess when actually magnesium excess में हो जाएगा मैम, तो magnesium silicide
पर आपने appropriate amount में लिया है ना?
Okay मैम.
तो ये magnesium silicide कैसे बना दिया? magnesium silicide बनाए हैं तो ठीक है ना? Then you add dilute HCl to it, and you get silicon and magnesium chloride. Why not silicon tetrachloride?
Actually, ma'am, the silicon tetrachloride is not properly formed at the temperature of 150 degrees Celsius, because this acid leaching process occurs in the 150 degrees Celsius.
Leaching process है, ठीक है. Acid leaching process है, तो magnesium तो electropositivity ज्यादा है, so it will form magnesium chloride. But silicon is also having vacant d orbitals also, and it is also having a very big size, and it can adjust chlorine atoms along with 4 chlorine atoms. It can form hydroxylic acid also. बना सकता है क्या? सिलिकॉन टेट्राक्लोराइड तो बनाएगा ही बेटा.
Okay.
And then silicon tetrachloride will hydrolyze again. Silica will be reproduced. फिर से सिलिका बन जाएगा. तो HCl आप जो ले रहे हैं, तो कितना % ले रहे हैं?
HCl मैम. HCl is highly concentrated.
हाँ, ठीक है बेटा. हाईली कंसेंट्रेटेड. ये हमारे यानी दिग्विजय कॉलेज में आप लोगों के कारण नैनो टेक्नोलॉजी पर बहुत बढ़िया काम हो रहा है. नैनो पार्टिकल्स जो प्रिपेयर कर रहे हैं, दे आर वेरी यूजफुल, है ना? बट वी हैव टू गो बियॉन्ड दिस. हमको नैनो पार्टिकल्स बनाना तो आ गया है. नाउ वी शुड स्टडी देयर इलेक्ट्रिकल, फिजिकल एंड थर्मल प्रॉपर्टीज आल्सो, है ना? इस डायरेक्शन में भी आप काम करिए. यू आर working on absorption property.
Thank you.
So there is very good work going on in Digvijay College. I appreciate it and congratulate you that you are doing this job in Digvijay College. और ज्यादा काम करिए और ज्यादा अंदर जाइए, इसमें क्या क्या हम कर सकते हैं, and proceed. Thank you. बहुत सारा congratulations.
Amit, you have really smartly isolated this silicon from your sand, It's really very valuable work and really something novel work it's looking like.
Novel work.
Yeah. And I wanted to ask one thing. What information you extracted from this Raman spectroscopy?
Stretching.
Okay.
ऐसा ही वो फ्रीक्वेंसी नहीं होगी तो वो प्योर सिलिकॉन है।
Actually, sir,
ऐसा ही
Raman,
वो सिलिकॉन ऑक्सीजन बॉन्ड एब्जॉर्प्शन फ्रीक्वेंसी नहीं होना चाहिए।
Yeah,
That's
this
the
one.
ma'am,
subset.
Yeah.
there are two peaks, ma'am. Actual में क्या होता है कि रमन स्ट्रक्चरिंग फ्रिक्वेंसी रीजन में ये जो स्ट्रक्चरिंग फ्रिक्वेंसी का रीजन है ये प्रोवाइड करता है इंफॉर्मेशन मॉर्फोलॉजी क्रिस्टल के अमॉर्फस नेचर की। तो यहाँ पर ये जो हमारा स्ट्रक्चर जो मिला है ये डिफाइन करता है कि हमारा जो नैनो पार्टिकल सिलिकॉन नैनो पार्टिकल ऑब्जर्व हुआ है ये हमारा अमॉर्फस नेचर का है एक्चुअल में। बट आई डोंट नो मैम।
नहीं, मैम ने जो एक चीज कहा कि आपको सिलिकॉन ऑक्सीजन स्ट्रेचिंग की एब्सेंस जो इसमें पता चलेगी वो बहुत वैल्यूएबल होगा आपके लिए।
ओके
कि आपने सिलिकॉन
तब वो
आइसोलेट किया है।
नहीं है।
Okay, Amit, all the best. You are working really very good. Keep it up.
Next.
Okay, thank you, ma'am. Thank you, sir. So we have one more participant here, Khushbu Sahu.
Yes, sir. I'm here.
Are you ready to present?
Yes, sir, I'm ready.
Okay, do start.
Please stop sharing Amit Kumar Devangan ji, your screen. Amit Kumar Devangan ji, stop sharing.
Khushbu ma'am, you can start your presentation.
Yes, sir.
Yes, sir.
Sir, is it visible?
Yeah, it is visible.
You can start your presentation.
Yes, sir. Sir, may I audible?
Yes, you are.
आ रही आवाज आ रही।
Yeah. Very good evening, every respected professors, Honorable Dr. Mohbe ma'am, and I am Khushbu Sahu. My title is Application of Silver Nanoparticle for Determination of Kasuga-mycin. This is the introduction of nanoparticle. A nanoparticle or ultrafine particle is usually defined as a particle of matter that is between 1 and 100 nanometers in diameter. The term is sometimes used for larger particle up to 500 nanometer or fibers and tube that are less than 100 nanometer. Is only two directions. At the lowest range, metal particle smaller than the lower range. Metal particle is smaller than 1 nanometer are usually called atom cluster instead. Silver nanoparticle, silver has antibacterial property, however, is nanoparticle. The antibacterial property are magnified as the surface area to as the surface area to volume ratio is increased, allowing them to easily interact with the fight with bacterial more efficiently. The silver nanoparticle are increasingly used in various fields, including medical, food, healthcare, consumer, and industrial purpose due to their unique physical and chemical property. These include optical, electrical, and thermal high electrical reductivity and biological property. Due to their peculiar properties, they have been used for several applications, including as antibacterial agent in industrial, household, and healthcare related product, in consumer product, medical device, coating, optical sensors, and cosmetic, the pharmaceutical industries. These are wide. It is very wide area for application of silver nanoparticle. This is my compound name. This is kasugamycin. Actually, kasugamycin is an aminoglycosidic antibiotic that we identify for the registration against fire blight and other bacterial disease in our United States. Kasugamycin will be first antibiotic introduced in over 35 years for controlling phytobacterial disease, and it has a different mode of action from other antibiotics currently registered. This is the structure of kasugamycin. Kasugamycin this is my experimental section. Reagent and solution preparation: analytical grade reagents such as silver nitrate, sodium borohydride, kasugamycin, and trisodium citrate were obtained high media. The standard solution of kasugamycin was prepared by dissolving appropriate amount of drugs in diionized water. Silver nitrate, trisodium citrate, sodium, and sodium borohydride were also prepared by dissolving appropriate amount of substances in distilled water. This is the color, you can say, increasing concentration of silver ions. Other steps of reaction: I have taken trisodium citrate and sodium borohydride, which is reducing agent, and one of the is trisodium citrate is capping agent, and react with my compound kasugamycin, and I have got various concentration of solution which have added kasugamycin and also nanoparticle which has capping agent, and it is further dispersed and give aggregated nanoparticles. As the application portion, we can see in environmental sample with soil, water, and leaves, I have detected, and recovery percentage of kasugamycin is given here, and various sample of vegetable, grain, and soil, each other of 5 gram were taken, collected from agriculture field where kasugamycin has been spread out, and the insecticide. As reagent for the analysis, this method can be considered as one of the good alternative to most of the high costing, delicate appropriate which need much more in maintenance. It can be very efficiently applied for the determination of streptomycin in water, fruit, and vegetable sample. The recoveries ranges from 92 to 98% by the proposed method. These are the graph. One is for calibration curve for the silver nanoparticle, which is pure silver nanoparticle, and second is the calibration curve for the determination of kasugamycin. The range is given to 200 to 800 using silver nanoparticle as colorimetric sensor probe, and this second B graph is for various concentration of drugs kasugamycin. This is the toxicity, we can say, in our vegetable which is affected by the pollutant and antibiotics.
Then please do conclude.
Yes, sir. These are the proposed methodology, you can see, and the conclusion here. The study is expected to achieve the following: a new low-cost method to be developed for determination and detection of pollutant using less toxic chemicals. The method developed during the period of study are expected to be sensitive, non-toxic, and faster. And we can say that giving nanoparticle which I have using, it's less toxic. So you can say it is green method, and also it is good for environment protection, while the pollutant and toxic reagent which we are using, it is very harmful for environment. So it is good for reaction. These are references. Thank you. Thank you, sir. Thank you, ma'am.
Thank you so much, ma'am. Asad sir, please.
So, Khushbu, have you characterized these nanoparticles you prepared?
No, sir. It is on the way.
It is?
It is under proceeding.
So, how did you confirm that your sample is having
Means
nanoparticles?
all total characterization is not worked there, and some of characterization like UV. Yes, sorry, sir. UV characterization. The graph is here. So yeah, you can ask. Related characterization. Yeah. I seen the range that is 430 during characterization.
430 for silver nanoparticles.
Yes, sir.
Okay. And did you perform UV for the colored sample while detecting this what Kasugamycin?
Yes, sir.
Visual control.
Are you hearing me?
Yes, yes.
After forming a nanoparticle, when I have added Kasugamycin solution in a particular specific which are molar molarity, then it is the color is changed, a dark color which was firstly it was yellow color, and then I added Kasugamycin sample, it convert to dark yellow, or you can say blackish color.
Okay. So, what was the lambda max after the formation of complex with silver nanoparticles?
430 nanometer.
430 was for silver nanoparticle. Am I right?
Yes, sir. Yes, sir.
And what after the complexation with this Kasugamycin?
Yes, sir.
That should give
430 to 50. Yeah,
wavelength.
430 to 450. We have get for paper 2 ranges.
Okay.
Yeah, you got two
Yes,
maxima.
ma'am. Yes, ask me.
You got two maxima, no? One for pure silver, that is
Yes.
around 400,
Yes,
and
ma'am.
another is around 430, 500,
450. Yeah.
So it is which effect? Hyperchromic,
Which type
hypochromic,
of shifting is this?
red shift, blue shift.
I read about it. I'm not sure.
No. Pure silver is reacting, how you know? If you take samples in soil, you add, right? The
Yes,
absorption of the antibiotic is there.
Yes,
Some
ma'am.
98% absorption, 90% absorption. How you know that? कैसे पता चला कितना absorption है?
By UV or for recovery, ma'am, for recovery, you are asking?
नहीं, absorption study की होगी ना आपने, तभी तो absorption. How you did that?
Ma'am, I used UV. Their color is changed, and the range is shows to 420 to 450, and I'm not getting your question. Sorry.
No, कोई बात नहीं. देखिए, आपने टेबल दिया है ना कि इतना परसेंट एब्जॉर्प्शन हुआ.
Yes, ma'am.
है ना? So this much percentage.
Okay, okay. Yes, ma'am. I'm telling you that the before my sample is Kasukamycin, where spread out in an environment sample like leaf, soil, and water you can we can take, and other is the other antibiotic or other organic pollutant. So I just comparison and the see that their whatever their recovery percent and what is mine, then compare and it show that what will be result.
देखिए मैं आपको बताती हूँ कि आपने सॉइल सैंपल लिया है.
हाँ हाँ.
You took your that कौन सा माइसिन है एंटीबायोटिक.
Kasugamycin. Yes, ma'am.
है ना.
Yes,
Then you added soil to it.
Yes, ma'am. Yes, ma'am.
You wait for 1 minute, 2 minutes.
Yeah. Yes, ma'am.
And then you add your nanoparticle to the filtrate.
Yes, ma'am.
And you take out.
No, ma'am.
And then you take absorption spectra and then compare the amount of.
Yes, ma'am.
Antibiotic.
Yes, ma'am.
तो बेटा unless you study, है ना, जब तक आप करोगे नहीं तब तक जानोगे नहीं, है ना.
हाँ. Yes, ma'am.
है ना.
Yes,
तो
ma'am.
करना बहुत जरूरी है ना. And there is interference of other elements also. Soil में तो कई elements रहते हैं. हाँ. उनके कारण भी एब्जॉर्प्शन हो सकता है ना.
हाँ मैम, उसके कारण फ्लक्चुएट होता है जो रिजल्ट आएगा वो.
ये सब स्टडी करना बहुत जरूरी है ना. फिर भी आप लोगों का जो ये वर्क चल रहा है छत्तीसगढ़ में, खासकर ध्रुव और राजनांदगांव में, है ना, इट्स एप्रिशिएबल एंड इट विल गिव यू वेरी हाई हाइट इफ यू डू इट सिंसियरली.
यस मैम. यस मैम.
ठीक है बेटा, कांग्रेचुलेशन. थैंक यू.
थैंक यू मैम. थैंक यू.
Thank you, ma'am.
Thank you, sir.
आगे बढ़े.
Okay, so she was last participant, ma'am. So
I'm leaving firstly, then I
yeah, you can. So this session was very long. I think we have started it at 2:15 or 2:30 p.m. and now it's almost 5:45. So this session was very excellent. Asarkar sir and Mobe ma'am, I think I am amazed to see their interfere and command in every field of the research work shared by different presenters. So I would like to congratulate all the presenters, participants. I hope they have learned a lot of new things during this session. Now I would like to convey thanks and gratitude on the behalf of Department of Chemistry, Government Digvijay PG Autonomous College, Rajnandgaon, to respected Asarkar sir and respected Mobe ma'am. Thank you so much, ma'am and sir. I would also like to convey my sincere thanks to everyone attended this session for their valuable time and contribution. Now I hand over the mic to Dr. Priyanka Singh for the conduction of valedictory and final session of this 2-day long conference. Thank you, ma'am. Thank you, sir. Thank you, everyone. Over to you, ma'am.
Welcome everyone. Welcome everyone to the valedictory session of the web conference, Novel Trends in Chemical Sciences 2021. We had a large number of eminent speakers from different parts of the country. Mandal sir from IISER, Kolkata, Ras from IIT Kanpur, and Ghosh sir from IIT Roorkee. Rajendra Thakur sir from CSM CRI, Bhavnagar, Chitranjan Das from Germany, Mohabbe madam from Digvijay College, and a very large number of participants presented their research work, and the enthusiasm of all the participants is appreciable, and the guidance of all the speakers and our chief guest, Mohabbe madam, was also appreciable. She has been with us throughout these sessions. And the chief guest of our valedictory session will be Hemlata Mohabbe ma'am, retired principal, Government Digvijay PG Autonomous College. And special guest would be Dr. Ashish Kumar Asatkar from Government College, Kondagaon. Now, I'd like to all the participants for their feedback. I'd like Mr. Anil Kumar Khosle from Government College, Takeri, District Odisha, Madhya Pradesh, to share his views about this conference. Anil sir, you're invited to share your feedback.
Good evening, all the respected guests and respected participants. May I audible, ma'am?
Yeah. Yes, sir.
Yes, ma'am. जितने भी सारे लेक्चर्स हुए रियली मतलब बहुत ही ज्यादा इंफॉर्मेटिव लेक्चर्स थे, और ऑर्गेनाइजर जो टीम थी उनने बहुत ही अच्छा परफॉर्म किया हर चीज को लेकर के, और जो टाइम मैनेजमेंट था वो बहुत ही शार्प टाइम मैनेजमेंट था। तो बहुत बहुत धन्यवाद आप सभी लोगों को, बहुत बहुत शुक्रिया इतनी बड़ी अपॉर्चुनिटी प्रोवाइड करवाई कि नेशनल लेवल पर हम इंटरनेशनल लेवल के जो लेक्चर्स थे उनको सुन पाए, उससे बहुत सारी चीज सीख पाए। तो इसके लिए बहुत बहुत धन्यवाद सभी टीम को। मैं डॉक्टर अनिल कुमार कौशल, हेड ऑफ डिपार्टमेंट ऑफ केमिस्ट्री, गवर्नमेंट कॉलेज लटेरी, मध्य प्रदेश। थैंक यू सर, थैंक यू मैम।
Next, I would like to call upon Dr. Jyoti Rathore from Government PG College, Korba, Chhattisgarh, to share her feedback. Dr. Jyoti Rathore. Any of the participants who want to share their views about this conference are welcome to share their feedback. They can unmute themselves and share their feedbacks.
Vikas sir is there.
Vikas sir, please share your feedback. A lot of feedback is coming in the chat box. If anyone wants to speak up, they are welcome.
Hello, myself Rajkumar Rathore.
Yes, sir.
I want to say that the experience with this webinar was very excellent, and I think such type of initiatives should be taken by each and every colleges. I am very glad to be the part of this webinar, and I want that such type of webinar and conferences should be conducted in our this state so that we can go in a better in this direction of research and upgrade our knowledge, as well as we can give more knowledge to our students as well. So the invited lectures as well as the presentation by different participants as well as the experts which are there with us was very good and nice. I'm very thankful for getting an opportunity to present my presentation. Thank you very much for such a pleasant experience. Thank you.
Thank you, sir. Anyone else who would like to share the feedback are most welcome. I think.
Shall I say something now?
Yes, you can say.
Good evening, all the organizers and the participants. The conference was well organized, and there were eminent speakers in the conference. It was a great opportunity for all of us to learn new things, because it's very difficult. Otherwise, I am from Haryana. It's very difficult to travel to any other state to attend the conference. But this virtual platform has given us the opportunity to learn new things or to attend the conference to present the paper. So thank you, everyone. It was well organized, and I congratulate all the organizing committee members. They were so patient, and they took the presentations so meticulously. And thank you, everyone. Thank you. And it was a successful event, and congratulations to everyone.
Thank you so much. Anyone else would like to share the feedback?
Good evening to all.
Yes, sir,
I am
welcome.
Mr. Vikas Punde, Department of Chemistry from Ale, Pune district. I would like to share my thoughts. I am really being impressed by the energy which is shown by today's Madam Hemlata Mobe. It's being hats off to them. After the at the age of after retirement also, Madam is contributing and guiding us. It's my pleasure that you all have given us an opportunity to attend such a kind of seminar, webinar, because in pandemic situation it is not possible to go outside. Even if this conference is organized offline, then we were meeting the peoples which are nearby areas and not the people which are from outside the country and which are from different states. So congratulations to all. They had given us an opportunity, and thank you for everything, the knowledge which is given by this conference. I'm hats off to all. Thank you, madam.
Thank you so much, sir. Anyone else who would like to share the feedback?
Good evening to all. This side Charming Fatima, PG
Yes,
student
welcome,
Zoology. Thank you, ma'am. I'm very glad to be the part of this webinar. Actually, I don't know how to present paper, but with the help to be the part of this webinar, I'm able to learn how to present the paper, and the topic was very good. Thank you to all the organizers.
Thank you so much, madam. I think we should carry forward the valedictory session. So I would like Dr. Ashish Sarkar sir from Gundadhur PG College, Kondagaon, to share his expertise. Ashish sir.
Thank you, ma'am. Yes, ma'am. Thank you very much, madam. First of all, I would like to congratulate the entire team of Digvijay College for the successful completion of this grand event. It was really a wonderful event. I saw the speakers. I listened to them also, and the speakers were really very nice. Their work was really have a very high level, and it would definitely help our students to do something good, something big, and it will definitely motivate to all of us. And thank you very much. And I am very happy and feeling very proud to share a screen with Hemlata Mohbe madam. I think she was principal in the 2002-3 in Science College Raipur when I was in BSc first year. So I am feeling very proud to share screen with her. So thank you, madam, for being with us. So thank you very much, and all the participants were performed really very well. They are working really very well. Their work is really appreciable. They are presenting the things in a very good manner. So I wish all the best to all the participants. Thank you very much.
Thank you so much, sir. Now I would call upon Dr. Hemlata Mohbe ma'am, our guiding light, to share her views and the reason of her so much energy. Mohbe ma'am, you're most welcome. Mohbe ma'am.
Ma'am, please unmute yourself, ma'am.
Mohbe ma'am.
Ma'am, please unmute.
Respected principal, who is not here, perhaps she is learning. Respected head, Department of Chemistry, Government Division College, and members of organizing committee. 2 days web national seminar is now at the end. In 2 days, especially myself, has got dopamine hormone, which is a happy hormone, which has been increased. This hormone gives us feel good, and dopamine is primary driver of brain, and it is generated when we experience something pleasurable. I got this in these 2 days. We stay mentally active by these seminars. This seminar improved our attention, and the keynote addresses given by distinguished scientists of chemical science was appreciable. I hope the new horizons will be definitely open due to these hard workers. I thank Dividend College team and congratulate them for organizing such a grand seminar. The COVID-19 has given us a new direction that from distance we can learn many things from different countries. By they incorporated Chitranjan Das sir in the seminar and gave an example that though it is a national seminar, but it became international. I appreciate the Vijay College professors for having research attitude. They are doing very good in the college for benefit of the students. They have great knowledge, deep knowledge of chemistry, basics knowledge, and their behavior for students is very appreciable. They love them. Their students are their thin, and the teachers are role model for them. D.K. Verma sir is doing very nice. Priyanka Singh, Ashwini Sharma sir, Gokul Nishad sir, Yunus Beg, who is the pillar of the chemistry department, all are very good and very hardworking. This seminar has proved that they have managing capacity very nice. I thank you all for involving me in this seminar and activated me by arranging this seminar and taking me in confidence for their seminar. Thank you, and my appreciation for the success of seminar. I congratulate you all for this seminar, though we know that Rajnandgaon is a remote place, but now it is connected very nicely, and the seminar was without any obstruction, and it was continued. Only half hour's break was given during lunch, and this was the example that a seminar can be done without much expenditure. Thank you very much.
Thank you so much, ma'am.
Congratulations to all.
Thank you, ma'am.
Congratulations, you have done a great job.
Thank you so much, ma'am.
For Rajnandgaon, not only for Rajnandgaon, you have given example that you can do anything. Thank you.
Thank you so much, ma'am.
Thank you, ma'am. I would like to bring notice to the participants that Hemlata Mohabbe has been a part of this web conference from the day one we decided or we proposed to have this conference. She has been actively participated in all the 4 technical sessions we had during this web conference. So she is the pillar of this conference. And after this, I would like to call upon Dr. Dakeshwar Kumar Verma to share the results of the oral presentation competition held here. Dr. Verma, sir.
थैंक यू प्रियंका मैम। जैसा कि आप सभी ने देखा, हमारे जो कीनोट स्पीकर थे, इन्वाइटेड टॉक थे, सभी बहुत ही शानदार रहे। और इससे भी अच्छी बात रहे कि सभी पार्टिसिपेंट्स ने बहुत ही अच्छा जो है प्रदर्शन किया और बहुत ही शानदार हमको जो है एक तरह का मल्टी डिसिप्लिनरी अप्रोच जो है यहाँ पे देखने को मिला। बहुत टफ डिसीजन था ये जो है जजेस के लिए। मैं अनाउंस करना चाहूँगा, वैसे तो हमने इसमें टोटल 3 ही कैटेगरी रखे, फर्स्ट, सेकंड एंड थर्ड। बाकी सब अपने आप में बहुत ही बेस्ट है। जो फर्स्ट आए उनका नाम मैं आपके सामने अनाउंस करना चाहूँगा। डॉक्टर आर सुहास फ्रॉम JSS कॉलेज ऑफ आर्ट्स, कॉमर्स एंड साइंस, OT रोड, मैसूर। ये जो है इनका प्रेजेंटेशन हमारे जजेस के हिसाब से फर्स्ट रहा। सेकंड है डॉक्टर सतीश चवन, डिपार्टमेंट ऑफ केमिस्ट्री, गोखले एजुकेशन सोसाइटी, RNC आर्ट्स, JDB कॉमर्स एंड NSC साइंस कॉलेज, महाराष्ट्र। और थर्ड है मिस N जयश्री फ्रॉम डिपार्टमेंट ऑफ केमिस्ट्री, कल्याण PG कॉलेज, छत्तीसगढ़, इंडिया। Thank you so much. Mic over to you, ma'am. Priyanka, ma'am.
Thank you, Verma sir, for declaring the results. Now I would call upon Mr. Yunus Raja Beg, the head of our department, to share the vote of thanks. Beg, sir.
Thank you, Priyanka, ma'am. Very good evening, all of you. On behalf of Department of Chemistry, Government Digvijay Autonomous College, Rajnandgaon, and organizing committee, I extend my sincere gratitude towards Dr. Swadhin K. Mandal sir from IISER, Kolkata, who delivered his lecture as keynote speaker on the topic reduction of carbon dioxide. I am thankful to Professor Shankar Prasad Rath sir from IIT Kanpur, who delivered his lecture on the topic life with oxygen. I extend my gratitude towards Professor Kaushik Ghosh sir from IIT Roorkee, who has delivered his lecture on the topic carbonyl, nitrosyl, and hydrogen sulfide. I extend my sincere gratitude toward Dr. Chitranjan Das from Germany, who delivered his lecture on the topic photoelectron spectroscopy. I also extend my gratitude towards senior scientist Dr. Rajen Singh Thakur sir for his valuable lecture on NMR. I extend my sincere gratitude towards respected Dr. Hemlata Mohabbe ma'am for her lecture on applications of radiation in agriculture. All of these speakers took us to the roller coaster rides on the novel trends in chemical sciences. I am very thankful to Dr. Ashish Asatkar sir from Gundadhur College, Kondagaon, for giving us valuable time as a judge in the technical session of presentation. I am very thankful to research scholars of our department, Mr. Amit Devangan, Mr. Yusdev Devangan, and Mr. Kuleshwar Prasad Patel, for helping us in the technical sessions. I am very thankful to research scholars of our department. I extend my sincere gratitude towards principal of this college, respected Dr. B.N. Mishram, madam, for always encouraging, supporting us, and providing us all the facilities. I extend my sincere gratitude towards Honorable Vice Chancellor of Hemchand Yadav Durg University, Dr. Aruna Palta, madam, for giving us her valuable time in this web conference. I am very thankful to Mr. Ashish Mandle sir and his team members from Department of Computer Science for supporting us as technical members. I am very thankful to head Department of Computer Science, Dr. Raju Khute sir, for providing us facility of computer lab. I am very thankful to the Autonomous Cell of Government Digvijay College for providing us funding for this web conference. I also extend my sincere gratitude towards all the participants, our fraternity and students for joining us in this national web conference. I extend my sincere gratitude towards all the organizing committee members, Dr. Priyanka Singh, Mr. Gokul Ram Nisad sir, Dr. Aswani Sharma, Dr. Rakeshwar Kumar Verma, Mrs. Rima Sahu, and Mr. Vikas Kande sir for their support. Without their help, organizing such a conference was not possible. You all stood side by side to me from the beginning, whenever I was in need. Thank you all. Thank you very much. Thank you, ma'am. Ma'am, thank you. आसटकर सर, बहुत बहुत धन्यवाद आपका।
थैंक यू वेरी मच सर।
इतना समय आप लोगों ने दिया, इतने समय तक आप जुड़े रहे पूरे सेशन तक, बहुत बहुत धन्यवाद।
थैंक यू सर, आपने मौका दिया और हमें भी कुछ नई चीजें जानने सीखने को मिली और प्रेजेंटर्स इतने अच्छे थे कि वाकई में इन्होंने एक नई हाइट दी इस इवेंट को। इतना अच्छा वर्क प्रेजेंट किया कि वाकई में एक नेशनल लेवल का प्रोग्राम जो मैडम ने कहा इंटरनेशनल बना दिया। इतने अच्छे अच्छे आपने स्पीकर्स और रिसर्च स्कॉलर्स के पेपर एक्सेप्ट किए कि वाकई में इंटरनेशनल। तो आप लोगों को बहुत बहुत कॉन्ग्रेचुलेशन सर, पूरी टीम को आप लोगों की। इट्स रियली वेरी गुड सर, यू आर डूइंग वेरी वेल।
थैंक यू सर, थैंक यू मैम।
यस आसरकर सर, बहुत आशीर्वाद।
धन्यवाद मैम, आपके आशीर्वाद
कई सालों बाद देख रहे हैं आपको।
हाँ मैम, मैं उस समय फर्स्ट ईयर सेकेंड ईयर में था जब आप प्रिंसिपल थे साइंस कॉलेज रायपुर में। तो बहुत समय के बाद आपसे ऑनलाइन इंटरेक्शन हो पाया, ऑफलाइन तो